All right, good morning, OLF. Let's hear it. All right, fantastic. I almost said good morning, Columbus, and welcome to all of you who are here in Columbus, but I also want to give a welcome to those who are watching us on the YouTube stream as well. A couple of announcements. We do have a coffee service outside the room here. That'll run through 10 o'clock or so. So once this talk is over, feel free to go and grab some. Thank you to CIQ for sponsoring that. I also wanted to say that if you, as part of your registration, if you had purchased a t-shirt or if you had gotten it as part of a bundle, those are going to be available out at the registration desk. If you've checked in but haven't picked it up yet, please do that before noon. At sometime in the afternoon, any that are left over, we're going to make them open for sale. So make sure you don't miss out on the one that you were entitled to. And I guess I'll move on to introducing our keynote speaker for this morning. So Amber Grainer has been a longtime friend to OLF, a longtime presence in the free and open source software community. And she's going to be coming up and talking to us about the non-technical end user. So Amber, come on up.
Thank you. Good morning. It's so great to be here, and it's great to see all of you here this morning. It's weird seeing me on the slide and not my slides up there. So, but this is a topic that's very near and dear to me for a whole lot of reasons. When I first got started, gosh, Bethlehem, I think it's been maybe 13 years now since you encouraged me to go give that first BOF talk. And people would come up to me and go, "Oh, you're not technical." And that would make me feel about this big back then, because I had the same misconception that in order to be technical in open source, you had to write code. Not true. And just from the folks that are here, I wish I could see those of you that are online because I can see your hands being raised. But for those of you that are in the room this morning, just out of curiosity, how many of you all write code? All right. Now, how many of you all ask people, and you don't have to raise your hand on this one, but just think about it. How many of you all have walked up to somebody and said, "Are you technical?" And what you really meant was, "Do you write code?" And it was interesting, and I'll talk about both Beth Lynn and Mad Dog a little bit later in my slides here, but both of them, that very first year back in 2009, had very, very pointed and concise conversations with me that guided my path in open source. And it put me on a path to almost doggedly determined to prove that you didn't have to be a kernel developer to be successful in open source, and two, you didn't have to write code to be successful in open source. I almost became, as zealot as people are about their choice of Vim or Emacs, I became zealot about getting involved in open source, that anybody could do it. And I wanted to make sure that even if you just wanted to bake cookies and come to a release party, that you were just as important as the person that wrote the code, because that release party wouldn't be successful without the other people, helping to create the ambiance around a successful participation. So that's why, I came up with that little acronym INTO, non-technical end user. And when you think about it, somebody's always has more information than you do or less information than you do. So there's always somebody smarter than you in the room, and there's always somebody that, that can learn from you sitting in the room. And so that's why I thought about, no matter where you feel like you fall on that continuum of skill sets, you're somebody's guru. Think about how many people, like you, I might say, I'm not technical back then, but you know what? My sister might call me and ask me for help. My mom and dad might call and ask me for help. Somebody else, might call and say, hey, can you help me with my computer? So even though I considered myself at that time self-identified, please don't ever identify somebody as you're non-technical. But if somebody self-identifies as that, like you're somebody's guru. Somebody looks up to you and your skill set. So with that, let me tell you a little bit more about why this is important. So I got started in the Ubuntu and Fedora communities way back in 2009. At the time, my husband worked when I got involved in Ubuntu, he worked for Canonical, but before that worked for Red Hat. And he would, it was back when Red Hat Linux, before Fedora, before all of that, he would leave me a laptop, everything would be working. I'd go to try to print something. Nothing would print. And I'd be like, and I would just kind of toss the computer like wherever I tossed it. Sometimes it would survive, sometimes it wouldn't. And then I would go back to whatever I knew at the time to print whatever I wanted to. And I think back in that, sometimes I filed one bug at that, and it was just a grammar thing, but I learned how to file a bug, right? So I got started like in the communities of Ubuntu and Fedora really heavily back in 2009. And then I helped co-author a couple books you might have heard of, the official Ubuntu books, helped co-author a couple of those, helped launch Ubuntu User Magazine back in the day, and then went over to Linaro, which was Linux on ARM for those who aren't familiar with that. And I was their social media manager and then later became their community manager. And that was also at the same time, I think, Mad Dog actually became either a consultant or working for Linaro at that time as well. So I got to say one of my mentors also worked for the same company that I work for. So that was pretty special to me back then. And then went over to Open Compute. I happened to be at a Linaro Connect, and Open Compute had just gotten started. And I walked up and I was like, do they need an Amber there? And they were like, you know what, we are looking for a community person. So second person hired for Open Compute and helped architect and build that ecosystem that you see with the Open Compute project. So if you're familiar with that, and open hardware and data center stuff, that model wasn't even heard of. That's a different membership model than most foundations that you see, because time and talent go into what goes into a membership there. So it's not just how much money can you pay, but how much IP and how much time that you put in to that project. So a lot of projects don't take that piece of it in. It's just, here's this payment, and whoever can pay the most gets the most benefits. But it's a unique model that we came up with for Open Compute. And from Open Compute, went over to, I took a break from technology, actually taught bands and in New Orleans how to build communities around their bands. I was a manager at a bar in New Orleans for about a year. And I said, I won't build your communities for you because I booked the bands and did that stuff, but I will teach you how to build a community around your artistry and your music. So I still kept building communities or helping build communities. I just took a break from technology, because when you see this one slide about what happens when you empower people with, who don't code in your organizations, when I show you what I did my first year in open source, that's how the talk Volunteer Vertigo and High-Tech Hangovers, all about avoiding burnout, came about. And so anyway, I still continue to highlight how to build communities around whatever. It doesn't matter if it's open source. It doesn't matter if it's around a sports team. It doesn't matter if it's around music. You can take the same things that you do in open source and apply them to almost any, I would say every industry out there, the way that we build community and inclusiveness and all of that. So took that break and then went to Corelight. And Corelight is a network security monitoring group. And so they're built on top of a project that's called Zeek. Back in the day, it used to be called Bro. Many of you may have heard of Bro, now Zeek. So helped, build the foundation underneath that community, because Vern Paxson, 26 or 27 years ago, came up with this great tool, back then, again, Bro. But until a company started being built around it, they didn't think, how do you keep the community healthy? So I got to move over there and do that. And now I'm at Aricto. So those of you who were at the Kubeflow talk yesterday are very familiar probably with some of the stuff that we work on at Aricto. So at Aricto, I'm the VP of Community. I handle marketing and I handle our business development side of things. But I'm going to stress that community and marketing, two separate things. I look at marketing more as building the brand and protecting the brand, and community as empowering, and that you keep those separate. Community doesn't belong under marketing. Community belongs on the other side, usually reporting to, at least for me, to your CTO or your engineering side of things, or your CEO. Because if community is part of marketing, sometimes it's not as sincere and trusting as it could be. So that's just my little, if you're thinking about having a community person and where they're going to report and all that, please don't put them under marketing. Because, and then some of the other things that other titles that I've had throughout the years, that I was fortunate enough to do. And because of these things, I also give this talk called You Don't Need Permission to Contribute to Your Own Destiny. Because if I waited for somebody to give me permission to get started in open source, I wouldn't be standing here today. I wouldn't have done any of those things that I've done. If I waited for somebody to give me permission to figure out how to use SLAR data which is side-looking airborne radar, when I was in the military, I wouldn't have a Bronze Star today. I wouldn't have done targeting missions back then. I didn't wait for somebody to say, hey, can you come do this? I said, hey, what are we doing, and can I get involved? I wouldn't be skydiving. I wouldn't be scuba diving. I wouldn't be doing any of those things if I waited for somebody to give me permission. And that's the same way it is in open source too. So if there's somebody in your organization who says, I'm not technical enough, I guarantee you they are technical enough, and they are probably just waiting around for somebody to give them permission to help do something in your organization. But assure them they don't need to. If they're interested in something, encourage them to get involved in whatever it is that you're doing, because there's this huge misconception out there that you have to write code to be successful in this space. And I will say this probably until you're tired of hearing me say it, but I just want to hammer that home, that technical does not equal code. It includes writing code, but does not equal code. So let's talk about some of the myths. You don't have to write code to be technical. That you have to write code to contribute to open source. I would say there's more people who don't write code that contribute to open source than that do write code. Because when you think about how people, think about Ubuntu, think about Fedora, think about Kubernetes, think about any of the CNCF projects, think about all the code is just one piece of it. Without the foundations and all the mechanics that go into running those foundations and marketing that project, or writing that documentation, or testing that, all of those things, there's probably more people involved in every open source project who don't write code than that do. So just kind of think about that for a few minutes. And don't label someone as non-technical. If they self-identify or you self-identify as non-technical, that's one thing. But please don't tell somebody they're non-technical. That's just kind of insulting. But when people like me and others used to say, oh, I'm not technical enough, gently make sure that if they do say that, you remind them that they are technical. And they probably have skills that you don't have. I know some of the amazing developers and engineers who, if I said, hey, can you go live stream this Google Hangout or Google, whatever they call it now, you used to be on air, Hangouts, whatever, chat, whatever. They would be like, what? I don't know how to do that. So depending on where your skills are, or if you said, go on this assembly line, you could write, all kinds of like Linux kernel code, or you could be the greatest developer in whatever project that you're working on. If somebody says to you, hey, go figure out this point of sale system in this retail store, I don't know how to use that. You don't have those technical skills. You have these other technical skills. So, remind people that they do have technical skills. They just have made the assumption, like a lot of folks do, that code equals technical, and it doesn't always do that. So I was at an earlier talk conference, and somebody I respect greatly said, Amber, you can't use the word guru. And I was like, why can't I use the word guru? And they said, well, that has religious terms. And I'm like, well, that's not what I mean. So now we have this slide that I'm pointing out. It is the expert that I talk about. And I said, if you can come up with a word that rhymes with into, that means expert, I will change the title of my talk. And so the whole day they would come up to me like, I'm still thinking. So there we have, I'm just pointing it out. But if anybody in this room can think of a word that means expert that rhymes with into, I will, and that's a better word than guru, I will change the talk title. So, what do I mean? And I think I don't have to read the slide to you about what do I mean about non-technical skills, but they also fall into categories like you hear them referred to as soft skills, or hard skills being technical, soft skills being people skills. So these are skills that don't necessarily relate to your job. Think of the people skills. They relate to every job, and we're going to go through some of those here in just a few minutes. But it's your ability to work with others. It's your ability to be intuitive, and how do you help folks be more productive? And think about all those people skills or soft skills that a lot of folks don't have, but you're grateful that somebody in your organization has, because it keeps everybody kind of moving along and keeps everybody productive and helps with, when you're dealing with difficult people, those skills come in pretty handy. Because I know I had to learn some of those skills at one time, because I would snap back pretty quickly and not be as tactful as maybe I should. My southern roots may show a little bit, and I wouldn't use the words bless your heart. I might use a few other words. But I've learned over the years. I've learned. So you can see, like, those soft skills are super important. So as you're thinking about what they are, and we're going to go through 10 of them here in a minute, how would your job be if you or somebody in your organization didn't possess those skills? So technical or hard skills, when you think about it, it does involve code, but it's not limited to code, right? So, and you think about your languages, and there's some of them that I've listed on the slide, but think about people who use the Google Suites, or Trello, or Slack, or Zapier, or Zoom, or Jira, or Salesforce, and integrate all of those things. They don't write code, but they're integrators, right? And I'll tell you, having now worked on like the marketing side of things and the business development side of things, and having to figure out how to get, your contacts from one system into your Salesforce system so you can qualify those leads and do those things. That integration work is super technical, and like, I will, don't take that for granted. If you've got a great integrator who's integrating your systems and doing all of that, they might not write a single line of code, but I guarantee you they're technical, and they probably understand those systems much better than some of the people who write the code. And then you have industry-specific skills, and these aren't all, but when you think about project management or product management, think about the people who are certified on those, and all those, the agile and different methodologies for being productive. Software development. There's people who run release processes that don't write any of the code for the release, but they handle the whole release process and get that out the door. When you think about design, you think of marketing, healthcare, architecture, the car industry, like all of those very specific industry skills, those are technical skills at some level. So, and those people don't write code, and they're very technical. So I just wanted to, and we had this conversation last night. I don't like the terms hard skills and soft skills. Hard skills implies difficult, soft implies easy. However, when you're looking at these technical skills, there are rules around technical skills. And if you understand those rules, then those skills become easy, right? Kind of like math. Like if you understand the rules of mathematics, you can solve an equation, right? And there's a rule set around that. And once you understand the rules, life becomes simpler. But with soft skills, those are often more difficult. Like communication, cooperation, some of those things, it's difficult sometimes. So hard doesn't necessarily mean difficult, and soft doesn't necessarily mean easy. It's oftentimes quite the opposite. That the hard skills become easy because you understand the rules, and the soft skills are difficult because they're determined by your environment, they're determined by your personality, they're determined by a whole lot of factors that don't have hard and fast rules, and they have implied things that most people ignore a lot of times. And so that's why you need people with those skills. So here's just a little comparison of what is meant by technical and non-technical skills. But and you can see like that those technical skills or hard skills, those are the ones, you have training, you've gained through, you've learned the rules, right? You've learned how to do those things. And the soft skills or those people skills are those interpersonal kind of habits and things and traits really that help you along. So let's go through just a few of examples here, and I just want to make sure that I've got enough time here. Okay, because I want to leave time for questions. Communication. And everybody knows what communication is. It's how you share information and all the forms, Think about how many times if you've reached out to somebody in sales and they've sent you a one-line email back versus the person who sends you the, thank you so much for your email. We really appreciate the opportunity to have your business, blah, blah, blah. They go into like kind of what some people would consider fluff and other people would, versus that one-liner terse thing that got your request, we'll process it. No thank you, no whatever, no greeting. There's a difference in those two, and there's a difference in how you read those. Some people will be like, great, I don't need to read all that other stuff. But other people will be like, no, I needed to be thanked for, because I'm about to give them a couple $1 million worth of business, so they should thank me for doing that. And so depending on, who you're talking to, if you're talking to another developer and you're just emailing back and forth, or you're instant messaging, or you're doing whatever, you know each other's personalities, and you can be a little terse on that front. But if you're talking to somebody else who might not have that same personality, you have to understand, one, who you're communicating with and how they want to communicate. And so think about all the different channels that you gain your information and people communicate with you. So there's the folks on the live stream that we're communicating with today via YouTube, right? So think about, that's one form of communication. Think about your Slack messages. I believe there's a Slack channel that people can ask questions, there. So there's Slack that we're communicating with today. There were email messages that were sent out. There's the website that people found out about OLF on and either emailed or, went through Eventbrite or wherever to get your tickets. And then just think about all the different ways that just the communication around this event alone. And then you can't hear somebody's tone. You can't see their body language. You can't see their facial expressions through an email or a Slack message. So what somebody, which is why we now have the emojis, right? So you can sort of convey tone and feeling correctly, because what I might say is, thanks. Somebody said, well, that's it, But if you put a smiley face, oh, they're happy, like whatever. So think about all the different ways, like your communication could be miscommunicated or misinterpreted if you don't do it correctly. So those communication skills are very important. Cooperation. How many of you guys ever been on a team where you're like, this is not working? This is just not working. And it's all of those other skills. It's not the technical skills that are lacking. It's the soft skills, the people skills that make it difficult, to work as a team, right? Or how many of you guys, or gals, guys, I say guys as everything. It's a habit that I need to break. But how many of you all have, been through a class? Master's programs are notorious for these team building activities, and one person or two people do the work and everybody gets credit for it, right? And you just want to Okay, my violent tendency is about to come out. You just want to strangle somebody, or like if you could reach through the computer, you might throat punch them because they didn't help you, and they still get the same grade, right? Well, that happens on teams too. So how, to have those skills that you can put together a team and you can help work through those issues and you can get the team all moving in the same direction, that cooperation skill and getting people to cooperate as a team is very important too. And think about every open source project that you've ever been on and all the teams that go into working together and making that project successful. Somebody had to have these skills. Somebody had to communicate and drive cooperation. And I bet they had all the other 8 skills too that we're about to talk about. Adaptability. How many? Nothing, no plan ever survives first contact. So how do you process, handle and deal with changes? And in an open source project, because you're dealing with volunteers, I often tell people, you can't fire your volunteers. You got to figure out how to motivate them and get them to work together and understand change and do all those things. And so, you got to have that adaptability skill. You've got to be able to handle it and process and respond to changes correctly and in a positive way. And think about all the times you've been on a team where somebody doesn't handle change well. It can be very difficult. And so adaptability is another one of those great skills that folks who often say I'm not technical have, and it's a very needed skill. Organization. Now, if you look at my desk, they say there's this, you've probably heard the quote, an empty desk is a sign of an empty mind, right? Well, what's my cluttered desk a sign of? Nobody, I just told Mad Dog and Bethlehem earlier, nobody wants to be inside my head, I promise you. But in order for projects and the things that you do at work, even the things that you do at home or your hobbies or whatever, you got to be organized. And I used to tell people I had a hard time getting my ducks in a row because I didn't have ducks. I had squirrels and they were all at a rave. And it was everywhere, all over the place. And then I had to learn how to become organized, especially when you have kids and they're going in all different directions. And then you're working, and then you're trying to manage a house, and you're trying to do all these things. You learn you're either gonna learn to be organized, or your life is just gonna be chaotic. Well, that's the same way with projects and work environments too. You either learn to be organized and gain those skills, or that work environment and that project is just a mess. And so those folks who have extremely amazing organizational skills, if you haven't thanked them for keeping you on track, or maybe it's you and you haven't been thanked, I'm gonna thank you, because those folks that helped me learn how to be organized and do stuff, I wouldn't be able to do 15 things at one time if you don't stay organized. And so those skills are super important. And imagine if you weren't organized and you said, hey, we're going to release on this date, but you slipped by 4 months just because somebody forgot to send out the email, or somebody forgot to update this repo or merge in this pull request, or whatever it happens to be, because they're not organized, they don't have a checklist, they don't have all those things. Where would your project be? It would just be out there in limbo without those organizational skills. Collaboration. How well do you work with others? That kind of gets back to the cooperation, but you can have folks who are all rowing in the same direction, and there's this one person who's, think about, when you see I guess we've all probably seen some of the shows on Vikings, where they're rowing in the ships. Imagine your project is that ship, and you're all rowing in the same direction except 2 people. One of them's in the front, one of them's in the back, and their oars are out of the water, or they're rowing in the opposite direction from you, whatever. Or half the boat decides we're not going to row, and so now you're just going in circles, right? And so how well can your team work and collaborate together? So those folks that can get everybody, put your oar back in the water, we're going this way, so row this way. Or I don't know what you're back here doing, but that's not driving the goal forward. How do you do that? So those folks who can drive collaboration, that's another skill that some people lack. And I bet we've all encountered people who you question their ability to collaborate, to put it nicely. So those collaboration skills are super important. Creativity. How do you view challenges in new ways? Every one of us who's involved in an open source project, every project, I would almost guarantee you, was born out of a need, a challenge, an itch to scratch, if you will, right? And so somebody was creative enough to say, we need to fix this problem. We need to do this thing, and then go find the people to do, whatever thing it happens to be. So if you're designing the latest, greatest whoop-de-doo ladder and you want it to do 15 different things to include, hold your screwdrivers and everything else, then, well, somebody's going to have to test that and stand on it and make sure it works and, put all the different pieces together. Does it hold a paint bucket? Can it hold a paintbrush? Will it hold my weight? Will it hold whatever else I'm trying to stand on here? If I want to stand on one leg and halfway balance on my gutter and then barely touch my roof, is this thing going to hold me? How am I going to do this? And so think about your projects that way too, because people are going to use your projects in ways you never even thought they would use it. I remember I got when I was in the Ubuntu community, and I love the naming of all these projects, right? It doesn't matter if it's Ubuntu or any project. How people come up with the names of projects, I absolutely love. And I love the little icons, and I love all this kind of stuff. And so I said, well, why can't we have, like Apple does with the little apple up in the corner, how come we can't have a little icon with whatever animal it is in the corner? And then I got, why would you ever think that we would need that? Well, I thought it was kind of cute, so it's open source if I can find a designer to do it. And then I realized what goes into designing those little icons and why some of the icons need to be simple and why they can't be why they look great, big on a screen and why they don't look so great little in the upper left-hand corner. So I got to learn a lot about design because I thought that was the best thing ever to put the animal in the corner. I learned not the best thing ever. But think about all the different ways that people come up, to solve challenges or opportunities, right? And think about how whatever project or environment that you're working on now, what problem that it was designed to solve, and that somebody creatively came up with the solution that you are now working on to solve a problem. So that creativity piece of it, somebody could think about how to fix it, understand how to fix it, but might not have, the technical skills to write the code or do that kind of stuff. That's where you all who write code come in. You do that part of it, but somebody else was creative enough to say, this is the solution that we need. So I always think when I go to a new job, I always think, whoever was the creator of that piece of software, in my case now with Aricto, Jeremy Levy and David Aronchek, I had the opportunity to sit down with them a few weeks ago, and I was like, thank you for creating this, because now I have my job. And so, when you think about that, if you get the chance to thank the people who, came up with the solution that you're now working on, just tell them thanks. Time management, oh my goodness, this is a huge one. Like I said, there was one time in my life where I didn't have ducks in a row. I had squirrels at a rave, and time management didn't exist. I didn't really have a schedule. I just did what I wanted to do, how I wanted to do it. It got done, no big deal. But then, as you learn and people start writing paychecks, they expect stuff to be done on their time when they want it done. And so being able to manage your time so that you have that work-life balance and that you have the ability to release on time and meet your goals and all those wonderful business concepts that go into enterprise organizations, your KPIs and all of those things, and getting those things done. You have to have really good time management. Otherwise, you might be told, you're not cutting it. And it's not that you can't do the work, it's that you're not managing your time correctly. And so those folks that help you manage your time and are good at time management and you can learn from them, that's a great opportunity to sit down with somebody, and maybe they have a system for doing things that you haven't thought of that will keep you on track. Prioritization, if everything is a priority, nothing is a priority. So folks who can look at the list of things that need to get done and say, this needs to be done today, this can wait till tomorrow, and can see the big picture, because what you think is number one on your priority list might be number 7 on your boss's priority list. And so the ability to understand where your priority falls into the big picture is huge. A lot of people don't understand that. They're like, but that's my number one goal, and I don't understand why they don't understand that that's my priority. And I often look at them and go, have you seen their priority list? 3 levels above you, do you know really what the goal is? What is the goal of your organization? What's the priorities of your organization? And where does your number one priority fall into that category? But being able to see the big picture and see where you fall into that and being able to prioritize things, that is also a skill that is greatly needed. So imagine you're writing the code, somebody else is saying we need this done by this time. You might not understand why it needs to be done by that time, but if you ask the questions and then you understand why they're prioritizing things the way they are, it actually makes your job a little bit easier because now you understand what you're doing and where it falls into the bigger picture of that. So those folks who can, look at what's most important and help you prioritize, those are great skills to have as well. Enthusiasm. I one time gave a talk when I was just getting started at Open Compute. It was my very first day on the job, and my boss at the time, his name was Cole Crawford, and he said, Amber, I'm double booked. I was supposed to give 2 talks today. I got to go over here to this one place. We're in Austin. This one place and give this talk today, but I'm supposed to go over this hackathon over here and give this talk on Open Compute. Here's my slide deck. Go give the talk. Cool. I can do this. So I get there, and I was like, all right, everybody, today's my first day on the job. I got no idea what this slide deck looks at. We're going to look at it together. I'm super excited about it. And I said, so before we get started, I just want the opportunity to come back in 6 months and represent because we're looking at this deck at the same time together. And I said, I'm either going to confuse the heck out of you so much that you're going to go to the Open Compute website and you're going to look for yourself, or you're going to be so excited about it that you're going to go to the Open Compute website and you're going to look yourself. Either way, you're going to go to the website and you're going to check out Open Compute. And so it was kind of a laugh, but we did it and we got through it. And there was another time I was presenting on Ubuntu and Fedora at the same talk as a retirement community, so limited income, and I was showing folks how they could, use something that wasn't as expensive as your proprietary software systems. And I can remember people going, I don't know what you're talking about, but you're so excited about it, I'm going to go look it up. So enthusiasm goes such a long way. When you're passionate about something, whether it's your job or where you work or the community that you're in, whether that's where you live, physical community, or your online community, or your open source community, whatever industry, if you're excited about it and you're showing energy and you make people around you get excited about whatever it happens to be that you're passionate and enthusiastic about, they're going to be that way. So never underestimate the importance of enthusiasm. So I know lots of developers who are like, can you stop talking now? Because I'm very excited about stuff and I get, just super zealous about things and I'm really excited about it. And they're like, you're hurting my head. Can we just have a break? Can have some quiet time for a few minutes? And I get that. That enthusiasm isn't for everybody. But think about the things that you get excited about. Think about the things that make you want to go look something else up. Think about whether that's a hobby, your work, open source project, whatever it happens to be. When you encounter somebody who's also excited about that, that amps your excitement up because now you're feeding off each other. And imagine when everybody is coming together, and imagine the other 8 skills we've already talked about. Then you overlay the enthusiasm on top of it. So now you've got somebody that knows how to communicate. They know how to cooperate. They know how to drive. Their time management skills. They're organized. They're setting priorities, and they're excited about it. So now they're getting you excited about all of these things too. And so you can start to understand why these soft skills or these people skills are just as important as the technical skills. And emotional intelligence, how well do you understand yourself and how well do you understand others? This one is often, people go, I don't necessarily agree with that. But imagine when you get feedback. I love to ask people for feedback. And it took me a long time to be able to go, give me your honest feedback on that and not take it personally. Because when you understand yourself and you understand why you're getting that and you understand your own motivation, and when you ask somebody for their critique of that or why they got upset about something that maybe you had said or communicated, when you understand yourself and you can lean in a little bit and understand others, and then you overlay all those other skills, you build that layer of trust. You're able to, just like we have the key signing parties and that circle of trust and, with your GPG keys and like all of those type of things, just imagine that these soft skills also build that ring of trust. And somewhere in your world, that your community, again, whether that's in an open source community, your online community, if you've got kids and you're involved in their school, that community, a sports community, whatever community it happens to be, it's a lot of times these folks that have what they consider non-technical or these soft people skills that keep everybody rowing in the same direction and keep the misunderstandings from happening and keep the project moving along. And so imagine in open source, if all you had was developers and you didn't have folks with these skills, where would we be today? We would probably not see the adoption and the billion-dollar industries that we see across, every vertical out there with open source. Open source won a long time ago, and it didn't just win because of the technology and the code and that piece of it. It won because people were able to communicate why that was so important and be able to get people to work together and drive that together. It won because of all the folks who got other people excited about it. Like, what if Mad Dog hadn't given Linus that first computer back in the day to help, develop, the Linux kernel on? What if Mad Dog hadn't, helped out with OLF? Would we be here 20 years later? What if he wasn't that excited about what he believed the future would be? We all stand on the shoulders of giants. And one of those giants just happens to be, and I know he doesn't like when I say this, but one of those giants happens to be sitting in the room. And I think that there we go. So, but for, somebody having both the technical skills and those people or soft skills, we would not, as a whole in open source, be as successful as we are today, as a group, right? So those examples. Now look, I would not ever advise anybody to do everything that I did the first year in open source, but this is what happens when soft skills or people skills are valued. These are all the things that I did my very first year in open source. That's also where my my volunteer vertigo and high-tech hangovers talk about burnout came from, but that's another thing. But you can see, just by, somebody saying the things that you do, you might not write code, but the things that you can offer are important, so do them. That's what happens. And Beth Lynn was one of those folks at my very first Linux Fest. I believe it was Southeast Linux Fest, and it was held at Clemson that year. And I said, I don't know if I should go give a talk this BOF session. She says, you should. You have a voice, go do it. And I haven't shut up since. So if you get tired of hearing me, you can blame Beth Lynn a little bit. But these are the folks that really helped me out my very first year. It was Ricky Ansley, Beth Lynn, Mad Dog, and John O'Bacon. And so just summarizing this, don't label people. Let them label themselves. Value the soft skills. Understand that being technical is a lot more than writing code. And if you want to know if somebody writes code, don't ask, are you technical? Just ask, do you write code? Say what you mean what you say. Have an easy path for all skill levels to contribute to your community, or even at work, your inner community too. Not just your outer source, but your inner source as well. Have an easy path. And if possible, become somebody's mentor. Like, people say, how do you find mentors? Well, I remember one time when I was at Open Compute, Kshagra Vaid was over the Azure server department there, and he was their general manager. And he was on the Open Compute, one of the project managers, and later became part of the board. And I said, I want you to mentor me. And he went, and we're just going to take my whole team to mentor you. You've just got way too much energy. And so, but don't be afraid, like if you admire somebody's skills and you say, how did you get that way? Don't be afraid to ask them, hey, can you tell me how you got those skills? Or can you point me in the right direction? Or do you have time to mentor me? Don't be afraid to go up and ask somebody either. Again, you don't need permission. The answer is always no if you never ask. So don't be afraid to ask folks. Or if you see somebody with potential that's in your project or in your work environment, and you see that they've got potential, tell them, gosh, you've got a lot going for you. Here's some of the things that I've learned. Would you like a mentor? How about the next 6 months we just spend, 1 hour a month or however what your schedule is. I'd like to coach you a little bit. Don't be afraid to go up to somebody that you see has potential either. So here's all the different ways you can contact me. If you want to talk about Ericto and you want to talk about getting involved in the Kubeflow, and I misspelled Kubeflow, I'll have to fix that. I don't know why I did that, but we'll fix that. But anyway, there's all those different ways and some of the references that I use to make this. And also, thank you, but wait, there's more. It's like a commercial. If you want one of these stickers, come find me. And ask me for them, because I really feel like there's a lot of technical people, or if you know somebody that doesn't write code, but they're technical and you want to take one of the stickers to them, yeah. And the other sticker that I have the grayed out box on, that's from 2009, and I forget who originally made the sticker, but I love that sticker so much that I had it remade. So if you want any of those, you can just find me as well. So with that, I'm going to say thank you. I know I've gone a little longer than I intended, but I just think it's super important. So we have a few minutes for questions, if there's any questions. Yes.
Yes, absolutely. Let me run around and get folks.
This isn't a question, but it's a comment on what she said. One time I was at DEC, and there was an engineer who had done a very, very good job on a project. I was not his manager. I was just another peer. And I went up to his cubicle, and I looked in, and I said, I wanted to tell you what a great job you did on that. It was really, really fantastic. And the man broke down in tears. He says, I've worked for DEC for 20 years, and you were the first person who ever came up to me and said you did a great job, and specifically said what I had done. He says, I've gotten great reviews, I've managed to become a senior engineer, but you're the first person who said that. And so that's the type of thing you have to think about. Thank you.
Thank you. And just a quick reminder, if you're watching us online, you can join our Slack. You got a link when you registered for the conference. And if you go into the main stage channel, you can post questions there.
I worked on a special project, and we needed 2 specialties, and I was one and another person was another. So we started the project, and they didn't bring the other person in. I said, what about they're their expert? We'll handle that part, and we'll do that part, because I would cooperate with them, and the other person was very strict and would not cooperate.
So an example of how important that particular skill happens to be, when you need a whole team to be the liaison between that non-cooperative person, that breaks down, it breaks down trust, but also it adds a cost factor that most people don't. That time is, when you think of a whole team that has to liaison, what does each person on that team make per hour, and then how many hours of their life did they lose? I say lose, did I say that? That they never can get back because that other person isn't cooperative. I mean, that's dealing with difficult people, and it's a great skill. And I'll admit that if you'd have known me 30 years ago when I was in the Army, I wasn't always cooperative. I was very terse and to the point. So I had to learn those skills, and I'm glad that I did. Any other questions or comments?
Yeah.
Yes.
Do you have any good recommendations for
Oh.
recommendations for quickly boosting soft skills? Like, is there an apt-get install soft skills?
On the slide that I have 3. The deck has 3 links, and there's one link about how to improve those soft skills. So I do include that reference.
It's relatively easy. Do unto others as you would have them do unto you.
So, anything else? It's funny you said that, Mad Dog. One of the things that somebody told me one time was that, what if I don't like what you like? Why would you do unto me if I don't like what you like done unto you? And so, but that's still a great baseline to start from, right? And then that understanding. But but the slides do have a link to that, and the slides also have a link on there that shows you how to promote the soft skills that you have. It is so easy to put on your resume. Those technical skills, just list them. You're certified and list everything, but explaining those other skills, those people skills, are often a little bit difficult. So there's a link on the slides too to help with anybody who wants to add those to your resume as well. So there's some help on there as well. So I think you all make the slides available after the
Yep.
event, right?
Yeah, we will.
So, and I'll fix that spelling error. So
Any other questions here in the room? All right,
No.
thank you very much, Amber.
thank you. Let me log out here.
Thank you very much, Amber, for everything that you've shared with our audience today. And thank you for being you, because you, ma'am, are very special.
Thank you so much.
I want to welcome to the stage another non-technical end user that I know. I can say that because she's my mom. Okay, can you give me that permission, Amber?
Of course.
Okay,
You know your mom better than I do.
but I am sure that she's somebody else's guru, because she's certainly my guru when it comes to any of the social media stuff. So if you've seen a tweet or a Facebook post or anything else on LinkedIn, it was most definitely my mother, Susan Rose. So give her a hand of applause. It is with much pleasure that I am going to announce that we are going to continue the tradition of a annual raffle, and we are doing this online for the second year in a row with rallyup.com. We will also empower people to participate in the raffle via a kiosk up at the registration table. And also at the registration table, we do have a few t-shirts for sale, and my mother will gladly sell you a t-shirt. But let's introduce the prizes. So what we have here is a very unique piece of art by an artist named Sunshine. Sunshine is an African penguin who lives in the National Aviary. And what she does is she just goes to town walking on a canvas. And you too can own this beautiful piece of art if you win our raffle today. We also have quite a bit of pies here. Quite a bit of pies. So we have a quantity of 2 of these Raspberry Pi 400s, and they are really, quite honestly, a computer in the box. Just add a display, and there you go. There are interface ports for USB, Ethernet in, and looks like IDE. So you can go ahead and boot this up however you choose with any of your favorite Raspberry Pi compatible distributions. And we have 2 of those. And because we also have a bunch of these little Raspberry Pi things. Oh no! Oh no! At least most of them work. At least most of them work. It is a Raspberry Pi Pico produced in the year 2020. And you definitely need to bring your sliding iron, not included, to boot this up however you so choose. But it is a very cute little computer for you to use at any project in which your imagination allows. So the way that we are going to conduct that prize drawing is that the first two winners will each get one of these pies. The subsequent 16 winners will get one of these beautiful Picos. If there is a total of 18 participants, everybody gets a pie! So it's definitely worthwhile to participate in that one because I'm sure that it's going to be a very popular prize. We've got book authors up on our schedule for later today on this very stage. We've got Ben Cotton, who will be not talking about his book. He'll be talking about more along the lines of his experience in the Fedora release cycle. But this is Program Management for Open Source Projects by Ben Cotton, and he will personally inscribe it to your desires at 7 p.m. tonight. New addition to the raffle, very new addition. We also have David Both, who has donated the Linux philosophy for sysadmins, and he will also likewise inscribe it to your desires at 7 p.m. We have some Bose earbuds. They're very snazzy, and it is quite a fashion statement to have some earbuds that are definitely not earbuds. And then what my mother has personally put together is this lovely gift basket. Inside this lovely gift basket, we have a one-of-the-kind tote bag for OLF. We've got a mug. We've got various chocolate candies. We've got sparkling grape juice. Sorry to tease you with the excitement. And we've got two t-shirts. We got an extra large of this year's t-shirt, and then we got a large of a vintage t-shirt for you to definitely enjoy. So it's quite the prize package, and I really hope that it's a popular one.
The chocolate is the prime chocolate of Pittsburgh. It's called Sarah's Chocolate. You guys talk about Jenny's ice cream. Sarah's Chocolate is the high test stuff. So I just wanted to tell you that a box of Sarah's Chocolate is extremely valuable.
Well, thanks for that donation. And Mad Dog, you would like to say a word?
I would just like to add something about the picture. This is a South African penguin. And a few years ago, when Microsoft was rumored to be doing a Linux distribution, they of course needed a penguin mascot. This is back in the days when Steve Ballmer was head of Microsoft. And so I assumed that their penguin that they would pick up would be a South African penguin, because the other name for the South African penguin is the jackass penguin, due to its large baying sound, and fit Steve Ballmer perfectly.
Well, outstanding, outstanding. I see Mr. Warner Moore on stage, our corporate vice president, who will be assisting us in the emceeing of the program moving forward. So everyone, Mr. Werner Moore.
Thanks so much, Beth. Big hand to Beth and the OLF team. A lot of work goes into organizing this throughout the year. So as you see people who are volunteers helping out, be sure to acknowledge all the effort they put forth. We're going to take just a moment here and get Matt set up, and we'll start right on time. You know, it's funny, I was thinking, we probably have more penguin experts in this building than any other technical conference. I hope everyone took note from Amber's presentation earlier. I'll say that many of us are technical experts, and there's something technical experts often overlook in skill development, and that's the soft skills, how to work effectively with people. And those skills are truly what define a career trajectory. If that's something you work on and also have technical skills in a technical role, you will do much better than your peers who do not have those skills. I'm excited for our next presentation. Matt Eland, Eland, I'm sorry. I didn't have the opportunity to talk to you before. Matt Eland is a renowned speaker. For those of you around Columbus, you may have seen him before. Matt's also, a software engineer, but his day job is a technical trainer at Tech Elevator. Tech Elevator is a boot camp that works with aspiring students who are beginning or transitioning their career to technical work. Matt's going to be talking about AI for everyone. Going to be a fun presentation, no doubt. Big hand for Matt.
Thank you. Can you get mic'd up or anything? I'm not sure.
You can use this. Do you prefer the wireless lavalier?
You know, this is fine. Just hold it like this and I'll be good.
Yes.
Okay. We at
Close to.
yeah, we at 10 or are we close to it or?
Oh, yeah, we're like 01.
Okay. Well, all right. Well, I'm going to get started then. Hello, Ohio Linux Fest. I am Matt Eland, and this is my first time here, so thanks for having me. It's good to see y'all. As Warren said, I am a teacher. Before that, I was a software engineer for about 15, 20 years, something like that. I really love technology. I love helping other people learn it. And I'm in an awkward position because my presentation today is actually talking about my mom as a non-technical person. So thank you for giving that out, Amber. I really do appreciate that. So when I am not teaching about software engineering, I'm studying AI and data science. That's my passion, it's my hobby. I like to keep learning, and this is what interests me about tech right now, in addition to the things I teach. So I run a data science blog, I run a YouTube channel, and I'm also a master's student over at Franklin University. So this is a talk about some of the emerging trends in AI over the last 5 years and what they mean for you, and some of the consequences about AI if we're not careful. Okay, so I did mention my mom. I identify my mom as non-technical, and I'm certain that she would identify herself the same way. So while she has 2 sons who love technology and using it to better their communities, my mom fears computers, and even a cell phone is a stretch for her. And I was thinking about, how does AI impact my mom's life? And the more I thought about it, the more I realized that AI is actually everywhere in what my mom does. She interacts with, She Who Shall Not Be Named from Amazon and digital assistants on her phone. She gets the weather forecast routinely. She drives through traffic, which is managed by, traffic lights, which is a form of AI, whether or not we think about it that way or not. She watches YouTube and gets recommendations about new videos to watch through a recommender system.
We're not getting a presentation.
Oh. Well, that is unfortunate.
Can you mirror the screen?
I can. I am on extend. I'm on duplicate now. Should show up, but I don't see it. That's going to be really unfortunate if we can't see it. Can you hold this a second? Thank you. This did work in tech check, so. Oh, come on now. Ah, that's a good sound. I like that sound.
Maybe resize the screen.
Try switching to extend, see if that helps. I have a couple other adapters we can try too. Bag of adapters here to come. So I always travel with a bag full of adapters, just in case the tech gods decide to smile on me in a very frowny way. So, whoopsies. This guy works here, I know for sure. Yeah, USB-C right there. That's a nope.
Display settings.
There we go. Yay. And now I touch nothing. Okay. Thank you very much. I appreciate that. All right. So AI impacts every aspect of my mom's life, whether or not she realizes that. I do apologize for the technical difficulties. So I'm going to talk to you about AI and how far we've come over the last 30 years or so. So if we rewind back to when I was getting into tech, one of the big innovations that we had in artificial intelligence and machine learning was related to image classification. In the 90s, we discovered that we can use recurrent neural networks to classify images. You feed an image to a machine learning algorithm, and it spits out a prediction. So here is a sugar cookie that a student baked for me a year ago or so to make it look like a pizza. And I fed this to an image classification algorithm. It says, oh, yep, that's a pizza for me. That's definitely a pizza. And here are some pizzas it looks similar to. Now, noteworthy, one of these is actually a cake, which is kind of interesting. So it found that association. So image classification was a pretty big deal when it was discovered in the 90s when we invented that. Okay? But since then, what we've seen is we've been able to incrementally improve this. We've been able to take our cloud computing, cloud storage, and all these things to make incremental improvements what we could do with image classification. So we now are able to detect objects within an image. This is my Cairn Terrier Jester. We like to play hockey in the winter. And this is a mock-up of image object detection, actually detecting little objects, or those little street hockey balls in our basement. So with object detection, we're now finding things within images. So I can give it an image and it tells me what's in the image and where in the image it is with a rectangle bounding box. But we can go a little bit deeper. Anybody here seen Squid Game? Okay, so Squid Game is what I like to refer to when thinking about semantic segmentation. That's where we're getting individual meaning from individual pixels. Okay, so we're looking at an image and we're seeing what does this pixel in the image represent. So with semantic segmentation, no spoilers here, but it was actually pretty useful for determining where people are in this image. Okay, so we have innovated on our AI models. We've been able to classify an image. We've been able to say, like, hey, here's what's in it, and here's what it represents, and down to the pixel level if we need to. And we've done that for the last 25 years until we refined it to the point where we can combine all these technologies together to get a solution like a self-driving car. I still view self-driving cars as a prototype, even though people are actually starting to use them for real. But we're taking all of our technologies and we're combining them together to get some sort of value out of them. And it took us about 20 years to get here, but we still got here. Okay, so this is sort of the type of flow that we're seeing with AI. And we haven't seen that many monumental new shifts in technology in AI until about 5 years ago. And 5 years ago, something really interesting happened. Someone produced a paper that I would consider to be a sea change event. They discovered something related to computer language, or to language, to human language. And this is a sea change event because we didn't think that things were possible, and now all of a sudden we see new possibilities with AI. And that was 5 years ago in 2017. Someone wrote a paper called All You Need Is Attention, and it was about something called transformers. And transformers basically are able to find meaning in text that they couldn't before. It's a special flavor of neural network that's able to be trained over larger bodies of text successfully than we could before without losing its effectiveness. So we can train them on really large bodies of text or images or things like that. They also have traits in them that help them understand more of the context. They retain more of the context within a sentence, like the word order, instead of just whether or not a word is present. That lets our trained models make more connections than they could before. And as a result, we use these for language understanding, and we're able to get more insight out of these things. But the really cool thing about these is that these can actually generate new content for us. So I can take a transformer and I can give it some piece of text, and it's going to spit out a new paragraph or a new entire essay or article or whatever. And it feels like magic to me. And what we're seeing is this is coming about more and more commercial products are coming about that feature transformers and the magical things that we're able to see through that. So it's a really exciting time in AI. But the first time we saw this was through BERT, which is one of many Sesame Stream themed AI entities in the world. I don't know why, but there's actually a lot of things out there themed after Sesame Street. So BERT is bidirectional encoder representations from transformers, and Google uses it to help understand what you're searching for and what it's crawling the web. Okay, so that's what Google has been providing value to you through BERT for a while now, since 2018. Now, GPT, or generative pre-trained transformers, have been in development for a while as well, but in 2020 we saw GPT-3 come about. And GPT-3 gave us the ability to really start generating a lot of text in a very effective way. It was the first one of these that was really very effective and broadly useful. So it's a lot more broadly useful than Google's BERT. And so GPT-3 powers a lot of things like GitHub Copilot and other technologies like that. We'll talk more about the applications of this in a minute. So that was a couple years ago. Last year, we got DALL-E. This year, DALL-E was re-released again with version 2. We are now able to give a short description and generate an image from that description. So someone might say, hey, I want a corgi puppy looking at the camera wearing sunglasses. And nobody was putting sunglasses on the dog and taking a picture or drawing that image. But this transformer was able to find the associations between things it knew about, things it had been trained on, and said, oh, I think I can combine those two things together. And it generated this image. And so now all of a sudden we're able to generate these like magical, fantastical things. And it's really kind of cool. Another similar one just came out this year called Stable Diffusion, right? And Stable Diffusion is kind of popularized by this astronaut riding a horse, which I think is just awesome. And it really illustrates how fantastical these technologies can be. Right, and this is how I've been spending my time recently. I've been giving a prompt to something called Midjourney, which is based on Stable Diffusion, and I'm saying, hey, give me a medieval submarine, and it gives me this masterpiece. It's like, oh my gosh, like my art is programmer art, and I technically generated this. Right, nobody painted this. They painted things that look like it, and it was able to combine it, and it's incredible. Like this is just magical. It feels magical to you. So here's a more complex one. Medieval fantasy wizard, programming wizard with a keyboard and staff in a data center. And I love that, right? It might be based on some existing photographs or pictures or whatever, but it's my creativity with existing artists' talent. And there's some ethical concerns about that. We're going to talk about that a little bit more. But it's fantastic. It doesn't even have to be something we have pictures of. So I could say, hey, I want an eldritch space creature. And it says, oh, sure, what color do you want it to be? And it's crazy, right? Like this stuff is really amazing, and honestly, this is where I'm spending my time right now. Right? This is a lot of fun. By the way, if you want to get started with Midjourney, it's like $10 a month. It's really a lot of fun, and there's lesser effective ones that are free, and there's a lot of options for this stuff. So this is transformers. We're able to generate something from a prompt or for a very minimal thing. We don't have that much control over it. It's kind of like unleashing canned lightning and seeing where it goes. But it's incredibly powerful, and it's opening up new possibilities in AI that we are still trying to grapple with and understand. Now, I have some friends who went to FISNA here in town, and they do like 3D architecture and stuff like that. And last week they unveiled a prototype of being able to type in a scene, and it generates a 3D scene using models in their catalog. Okay? Right now, it's pretty rudimentary. It's interesting. Certainly not as attractive as my 3D space creature, but we were able to generate these things. And it's not a stretch of the imagination to imagine describing a 3D model and having it generate that in a few years, right? Generating textures for games, generating music, sound effects. Like, this is a new wave of possibilities that we have. Now, we don't have that much control over it, but we are able to generate stuff from nothing, which is great for prototyping. GitHub Copilot. Anybody here use GitHub Copilot yet? Okay, couple hands. So GitHub Copilot is based on GTP3, I believe, and it analyzes open source code. At least that's the promise. We'll talk more about that later. And it's able to generate new lines of code or even paragraphs or methods from prompts. So here it's actually responding to this validate that the wolf has deferred voting. It's learned my source code and suggesting an entire line of code that actually wound up being exactly what I wanted and free of syntax errors in the C# code base. And it feels a little magical. And honestly, it's a little scary to me as a teacher because I can see that getting in the way of my students actually learning, how to write a for loop if it's just automatically generating for it. But that's another talk. The company doing business as Meta introduced something called Galactica at the beginning of November. And the promise of Galactica was, I'm going to describe some scholarly topic. And Meta, Galactica, is going to generate something from that. It's going to generate maybe lecture notes or Wikipedia articles or whatever it might be. And there's a lot of appeal to that for about a couple days until people started playing with this and they realized, oh, the things it generates actually don't make sense in all the cases. They're not completely accurate. So this thing that's generating scholarly articles, oh yeah, those aren't completely without error because we don't have control of this. This is magical, it feels magical, but it doesn't have a brain. It doesn't have the human's ability to fact check things. It doesn't have the human's ability to catch errors. It's a good starting point, but it's not going to give you completely reliable results because AI doesn't do that. AI and machine learning always has some percentage of error. So this is an image the other day. Someone described a cat or had an AI describe a cat and then plugged that into Midjourney and got something actually very cat-like, but not cat-like. And I've been noticing something with my own images as well. So when I generate something, it might be a fantastic image, and it looks fine until I look at the hands, because dear God, it looks like something from John Carpenter's The Thing, right? Like, it's having a lot of issues with hands, it's having issues with faces. These technologies are not perfect, and that's okay. They're evolving. All this stuff evolves over time. This is very natural. Okay, we're in the early stages of Transformers, 5 years in, and it's frankly astonishing what we can do at 5 years in on this. So let's talk about how this is impacting our industries, because it already is. So a while ago, we discovered the ability to generate new articles about, like, say, a sports score. So here's an example of the Bulls playing the Magic, right? So with this, we're saying, hey, here's the results of this game, and it auto-generates a story based on these teams, their histories, who played, who scored the baskets, etc. And that's kind of cool, but I don't think the Bulls versus the Magic is the right application. I think my nephew's basketball game in high school a week ago is the right application, because no reporter would be attending that. And grandma wants to be able to see how her nephew did, right? She doesn't want to sit in the bleachers and maybe catch COVID, but she wants to keep up with her nephew. And so being able to generate scores from community events in real time is really interesting, generate stories like that. It's also terrifying for me. I teach coders, so when I'm grading their assignments, I'm using unit tests. I have it easy. My brother-in-law is a high school teacher. He grades essays. Those essays are often plagiarized. And there's tools that have been available for a while that will substitute words and phrases with synonyms. But now we're starting to see tools that actually generate essays for you from a prompt, paragraphs, sentences, entire articles, and essays. And these things don't get caught by any sort of a plagiarism checker. And so the next time somebody says, hey, I want you to write an essay about Macbeth, type it into a generator, click generate, submit that as your essay. Even if the teacher is 100% sure that you cheated, they can't prove it. And as a result, they can't really go after you to help you learn. And so you are not developing the things that you were supposed to learn, such as being able to synthesize new thought, being able to think about things in a written way. You're not developing those skills that you're going to need in college. So this scares me, frankly. So there's already some impacts of this, and I think we're going to see some more impacts of this as years go on and it becomes more popular. In early September this year, there was an art competition that was won by this image. This image was generated by Midjourney, transformer-based art tool. Okay, so the other artists realized this, and they said, "Well, that's not fair. I spent all my years developing my painting skills or my Photoshop skills or whatever it is. I spent a lot of time refining my submission, and this person just typed in a paragraph into Midjourney, clicked submit, and sent it on, and he won. That's not fair." And yeah, I guess it's not, but it didn't violate any rules either. And so that raised some ire, and of course it changed some rules for these contests. But the maybe more concerning issue is, what are these transformers based on? Because I've been noticing something in my own images. A lot of these images have these little things in the lower corners that look a lot like artist signatures, right? So these transformers are being trained on actual artwork or actual code in the form of like GitHub Copilot, right? They're being trained on existing things. And the artist who drew the existing painting, they're not getting any sort of attribution. In fact, if I wanted to attribute them, I can't. I don't know how it generated this article, this image. I don't know what sources it used. I don't know what's what. And the only reason it actually kept these signatures in there is because it thought it was part of the artwork. It thought it was a trait of the artwork. And so it was, okay, I'm gonna try to mimic the signature. Very interesting to me. But a lot of artists are getting very concerned and worse because they're like, hey, nobody paid me for my art. I put it online so people could see it. I didn't say you could train a transformer based on it, and now you're generating other art that competes with me in my own style. How is that fair? And frankly, it's not. But our laws haven't caught up with this stuff yet. And there's no way of seeing the transparency of your transformer yet. I think we're going to get there, but right now I can't see how my transformer works and how it's generating what it's generating. This is important when it comes to GitHub Copilot. I program chatbots as one of the many uses of my time. I do weird things. And I was teaching a chatbot how to respond to a user trying to say, hey, I want a hug. And I was typing in, and GitHub Copilot suggests the other half of my sentence using my own, a very similar sense of humor to myself. I was talking about like creating an army of hug bots to go hug people. And like, okay, that sounds like something I would say. I've never said that before. So either it's internalized my own sense of humor, which is terrifying, or it has found somebody else out there on the internet who has about the same sort of hobbies and sense of humor as I do, which honestly makes me feel a little small. So if I accept this string that I would share to a user, well, that's maybe not the best thing, because I have no idea of who I might be plagiarizing with this. I have no idea who I am ripping the code off of. It might be MIT license, something permissible, but I don't even know who to thank, right? So this is really concerning. And a lot of people have been complaining in the last year or so that they've seen code out there suggested by GitHub Copilot that they recognize and that shouldn't be suggested. So there's some ongoing investigations into this and how these transformers have been trained and whether or not they're ethical to use going forward. I think we're going to see laws kind of catch up with that. I'm going to skip over this one for time, but we can actually generate stories with like a cohesive narrative structure. Something I played around with earlier this week, and it was actually really cool. Game content generation. We've been able to generate levels for Super Mario Brothers for a while now, but you can see this being used to like, hey, I want a circular level layout with high and low areas. In a few years, I think we're going to have some level generators that will work with just transformer-based approaches. Right? And so this is going to empower indie developers, I feel like. Texture generation, sound effect generation, music generation. These are all things I think is coming. Right? It's going to disrupt some industries by giving people new tools to work with, but maybe also endangering some jobs. Games have been able to use reinforcement learning for a while to teach a machine how to play the game. So the machine might say, hey, I know I've got an up button and a right button and a jump button and things like that, and I'm going to see the things around my character. And I'm going to experiment with stuff. And give me a score at how well I do. And the first AI might run into the Goomba and die on Super Mario. And it learns not to do that through reinforcement learning. And it kind of rewards good behavior with higher and higher scores until it learns how to play as well as a human player would or better. And it might even find strategies that a human might not. This is reinforcement learning. We're using it for Go, we're using it for chess, we're using it for tic-tac-toe, all these things, right? There's a lot of different applications of reinforcement learning. It's very exciting stuff. We're also using it for robotics. So Boston Dynamics has these terrifying Terminator-like robots that they promised never to arm, that are getting better and better every year. They've been bulky for a few years now, but they're getting more and more refined, and this is impressive, and it's also horrifying, because I don't want to know how much that weighs and what it would do if it hit me. But they use reinforcement learning for balance and learning to move with their own unique weights. Now, inevitably, you build something like this, somebody is going to do something like this with it, right? We built these balancing robot dogs a while ago to carry cargo in an automated way. Well, somebody bought one and strapped a submachine gun on top of it and a remote trigger mechanism and used it to fire at things at a targeting range. A lot of security companies are interested in drones. A lot of militaries are interested in drones. We've been seeing drones used in UK to, fight off the Russians, right? It's not a stretch to see that this could go in some bad places. And we see that, things like law enforcement agencies, there's a story recently about San Francisco getting approval from a board to use lethal force via robot if they needed to. Still a human intervening, but we are starting to see these barriers between, robots and combat kind of eroding. And so pretty soon, this is how you get combat robots. This is how you get Terminators, right? And this is stuff that's very hard to fight the erosion of and turn back the clock on. I'm not saying we're going to have this next year, but maybe in the year after that we could have giant combat robots. But on a more positive note, this stuff can also save lives. I lost my father and my father-in-law to cancer, and cancer claims many lives. And one of the things that we're seeing with machine learning is that the accuracy of our systems for detecting cancer and other things like that benefit significantly from having both a human and a machine learning model look at it. So humans going to catch a lot of stuff, but they might miss some things that might be subtle. Models are going to be trained to find a lot of common things even in small areas, but they might miss obvious things that a human might see. So these things working in tandem, humans and AI, can spot a higher degree of cancers. So it's better treatment. We're also seeing some experiments being done about AI in surgery. So looking at a vast array of people who've had surgeries, looking at cameras during surgeries, and looking at metrics from vitals after surgeries, people can now predict mortality rates before surgery, identify complications during surgery, and if they're monitoring you after surgery, they can say, oh, okay, your metrics look a lot like somebody, your vitals look a lot like somebody who's got an infection. We should get the doctor in here soon, right? So this is really exciting. But it does make me nervous because that whole pre-operation thing, I don't ever want an AI saying, I'm sorry, Matt, you need the surgery, but you can't have the surgery. We decided that you can't because an AI said you can't. Like, there's some ethical issues there. But everything else about this I really like. So let's talk about responsible AI, because AI can be used irresponsibly easily without even thinking about it. There's a study in 2020 about racial discrimination in our facial analysis models. So facial recognition models work pretty well if your face looks like mine. If you're a white male, all 5 of these major vendors do really well at predicting, is that you or is that not you? If you're a darker female, all 5 of these vendors are significantly worse at predicting that you are who you say you are. And why is this? Because people like me, or who look like me, have built and tested and designed these systems. And they've trained them on other people that look like me. And they've added in other races and ethnicities and genders as almost an afterthought. And as a result, the training data is not as diverse as it should be. Right? So we have this racial bias where AI is great if you're me, but maybe not as great if you're somebody else. And that's not right. I've noticed this with Midjourney and generating images. I've noticed that it's like, hey, give me a medieval apprentice, give me a tinker, give me a data scientist. White males, most of the time. 20% of the time, it's a white female. I've never seen it generate a dark face without me telling it to, right? This is a result of the training data here. Most of our art galleries are Caucasian faces, right? That's just the nature of art. And we're training this on art, so it's going to mimic what it's seen. There's a problem. We need to make sure that we are fully representing everyone in society in our artwork, in our machine learning models, in our testing, in our training, in our development teams. We're working on this, but it's a problem because we have historical data. Microsoft has 6 principles for responsible AI that I absolutely adore. I'm going to share each one of them briefly with you. The first one is fairness. Fairness is that AI should not discriminate on anyone based on racial, ethnic, gender, identity, any other factor. All groups of people should be treated equally. This is hard because it's very easy to do this accidentally, as we saw with the facial recognition example. A library that I adore for this is called FairLearn. This plugs into scikit-learn, which is a machine learning training library in Python. And you can say, hey, I want you to take my metrics and generate metrics per gender, generate metrics per race, per age, whatever it might be, so I can see the differences between metrics, so lower accuracy, lower false positive rate, or whatever it might be, so I can understand the weaknesses of my trained models. So I know if I have a racist AI, because racist AIs are a thing, and you can get them accidentally. But FairLearn goes even farther than that. You can actually say, I want to mitigate this. As you're training my model, I want to make sure that all of these groups are treated equally in the metrics. And it kind of puts its thumb on the scales. It might hinder the overall high-level accuracy metrics, but the benefit you get out of that is everybody's treated equally. It might be slightly less effective overall on average, but everybody is treated equally. There are no weak points of it. So this is really exciting stuff. Frankly, it's my go-to when I'm training something, because I don't trust myself to be able to accurately test it, be able to accurately represent people. FairLearn is fantastic. Reliability and safety, this is basically saying, hey, if I'm training a self-driving car, it needs to perform well not just in daylight in San Francisco, it needs to do okay in a blizzard in Alaska. It needs to be okay in a forest fire. It needs to perform adequately in all of these situations that I've deployed it in, even the ones that are rare. Okay, so we need to test this stuff, and if it breaks, there needs to be a very good, easy way of recovering. Right, we need to be able to recover very easily with maybe a human driver being able to intervene with a self-driving car, that kind of thing. Privacy and security. Person should know where their data is. Ideally, your data should stay on your device. We see a lot of on-device machine learning training processes nowadays. Right? If your data has to go somewhere else, we need to make sure it's encrypted at rest and in transit. We need to reduce any personal identifying information that might be sent over, and a user might need the ability to request their own data or to expunge their own data. Right? This is all about privacy and security. Inclusiveness. I was paralyzed. I was paralyzed 7 years ago. I couldn't walk, couldn't get out of bed. Got better, thankfully. But I discovered pretty quickly that the world was not built for people who needed a walker or a cane or a wheelchair. Right? The world was not inclusive for me, even though they tried. In the same way, we need to make sure our machine learning models, our applications, all of our systems include people who have the least advantages. That might be people who have vision issues, hearing issues, maybe even cognitive issues, maybe even people who speak English as a second language. Right? We need to be inclusive by default. That's this principle. Okay? So include the least of people so that everyone can benefit. That is the guiding principle here. Transparency. Transparency is all about understanding why a model made a decision. If I trained a classification model to say, should someone get a loan or not? Should someone get into college or not? Should someone get the surgery or not? And it says no, I should know why. I should know why my model behaves the way it does generally. But in these extreme cases where it could really impact somebody's life, I should be able to say, why didn't you get that surgery? Why didn't you get admitted to that college? Why didn't you get that loan? Right? There's some things out there. This is part of Azure Machine Learning Studio, where we can actually get individual feature importance. So if I was rejected to a college, I might say, hey, why was I rejected? Is it because I'm 42 years old and going back to college for the first time in a while? Like, oh, no, actually, it wasn't that. I plugged it into the inclusiveness, and it turns out that your GPA in undergrad was -6. We didn't even think that was possible, but that's why we rejected you. So a little bit of a whimsical example there, but you need to be able to tell somebody why the model's behaving why it did. Because models are going to get it wrong sometimes, and a human might need to be intervene. And if it really impacts somebody, you need to be able to tell them why. Why couldn't we save your life with this surgery? Why was it too risky? That kind of thing. Accountability. This is a scary one. Saying that the creators, including the developers, data scientists, and executives who are developing these AI solutions, need to be accountable to their local and federal law enforcement agencies and laws, and that people inside of organizations should also be accountable to the leadership of the organization for those AIs they trained. So if I made a racist AI using an imbalanced set of data, well, I should be accountable for that to some degree or another. And lest you think that laws are not going to come around this, I think as people see more and more the impact and potential of transformers, the more we're going to see laws about them. The Biden administration came out with a blueprint set of AI Bill of Rights. This is a non-binding kind of thing that they came up with just a while ago, and it really kind of follows the line with the 6 principles of responsible AI. By the way, that's an awesome Lego set to put together. Just aside. So let's talk about some closing thoughts about where we're going as a society, what this means for you as a worker, and how you can cope with the world that's changing, because the world is absolutely changing from this stuff. Where will AI be in 5 years? I don't know. I mean, I'm kind of up here giving a talk on futurism, but I had no idea. I had no idea how much things would change this year from these transformer technologies. 5 years ago, this paper came out, and it significantly changed what we thought was possible. We don't know what's going to come out in 5 years. We don't know how people are going to start applying what we have discovered in 5 years. Remember, it took us 25 years to get self-driving cars from image classification. Right? This stuff takes some time. We can't know where it's going. That's okay. But we know that people are going to refine it. This stuff has plateaus. We have sudden peaks of innovation and new ideas. And then we have refinement and improvement and adding new capabilities such as transparency, which we desperately need in these transformers, being able to understand why they're doing what they're doing and what they're referencing and things like that, being able to control them more. Like, this is all kinds of things that's natural in the development of these things. So we're going to see plateaus occasionally, and that's okay. And then we're going to see another breakthrough. I don't know when it's going to come. Nobody knows when it's going to come. But new things that we didn't think were possible are going to be possible again. And it's going to be really exciting, and it's going to mature. This is kind of the cycle that we see with this stuff. So the big question folks have is AI going to take my job? Well, I guess that depends. Is your job easily reducible to a list of tasks and rules and responsibilities? Is it something that an AI might be able to do better than you? In that case, maybe. Robotics are getting better. AI is getting better. It can generate content now. It can even be somewhat creative. It might take your job. It might not. AI is definitely bad at some stuff, though. Right? Like, oh my gosh, the hands. I'm going to have nightmares about these hands. AI is bad at hands, it's bad at faces, but it's also bad at empathy. It's bad at understanding things. In fact, if I looked at the list of 10 things that Amber shared with us this morning, I suspect that AI is fairly bad at all 10 of them, honestly. So the more you can get better at the compassion and empathy types of things, the more you're going to be in a career that's going to help you. The more you can think about the high level what you're doing and add value to your organization through that way, the more your job is going to be safer from the AI impact on things. So jobs that work with people, jobs that help people understand, cope, survive, move on, get better, improve. These are jobs that are going to be a lot more safe from the impact of AI. Pardon my grammar there. I'm not saying these won't be impacted, these won't change, but they're less likely to be drastically impacted. Now note that I don't have creative workers on here. I might have had that a year ago. I might have had writers, I might have had artists on here. I don't anymore. That's a little scary, right? And even aspects of programming are creative, right? Generating source code, that's something that AI is getting better at, as we are clearly seeing, and it's going to keep getting better over time. But it doesn't understand the larger context. It can't understand the larger context. It can't understand your concerns. And so what we're going to see, hopefully, is that in 5 years, we're going to move from this, separate mentality to a human and AI kind of partnership, where we are looking at AI as a tool that we can employ to build quality software, to develop reliable software, to test our networks, to deploy software reliably, to automate the things that we are doing right now, to make us better at what we do. These solutions aren't perfect, but like the surgeons who have a better chance of spotting cancer with the assistance of an AI, they're going to make us more capable of doing our jobs. They're going to make us less likely to have errors. Definitely not going to be perfect, because nothing in tech ever is. But I think it's a really interesting promise. I'm excited to see where it goes. So if you want to get into AI, I do have some suggestions. I don't have time for all my suggestions, but I do have some suggestions. The first thing you might want to do is start understanding transformers. Start playing with them. People have made things out there like Crayon. That's Craiyon, because of course it is, where you can just go onto the website and type in a prompt and get some images back. It's not as good as Midjourney, but you can also install Midjourney. They have like a Discord bot, and you can play with it like 25 images for free, and then give them $10 a month and cancel anytime you want. You can also find a lot of other code out there to do it. I don't know of any any ways of using local compute yet for this, but I'm sure there are some out there. You can follow me on Twitter, and I'm happy to connect with you and help you on your journey. If you're interested in getting more into data science, I do a lot of talks and writing in the community about Azure machine learning. One of the nice things I like about Azure machine learning is that it gives us an automated ML solution, which lets us say, hey, I'm trying to predict a categorical value. Here's my data. Go train a model. Go train a bunch of models. Tell me which one's best. I don't have to learn a lot about data science in order to train and deploy models. Now, I should before customers start using them. But as a journeyman getting into data science, it really helped my own journey in understanding these concepts and helping me know what I needed to learn, because I didn't know. If you're more interested in just using pre-trained models, Azure Cognitive Services has a lot of AI as a service offerings that let you do a lot of things with speech, image, and language. They are looking at adding OpenAI to their roster with GPT-3 transformers and things like that. So DALL-E. So you can expect that probably in the new year, as well as some improvements with responsible AI. This is an area Microsoft is investing very heavily in. And of course, there's other cloud providers. I just drink the Microsoft Kool-Aid because, go Microsoft. Sorry, I own my bias. I also produce a lot of content out there on my blog and YouTube channel on data science and artificial intelligence, machine learning, and I'm starting to put more and more weird pictures out there every day on Twitter that were generated by AI. So that's @IntegerMan if you want to follow me until Twitter just falls over on itself. If you really want a good exposure to AI in general, Microsoft has an AI 900 Fundamentals certification. It takes you about a week to study for, and that certification doesn't expire. It's a really great way of getting a survey into AI. So my final words for you: be responsible with AI and machine learning, because we want to make sure that AI really does serve everyone and betters everyone's lives. Thank you, Ohio Linux Fest, for having me. This is a blast, and enjoy the rest of your conference.
Does anyone have any questions for Matt? Wow, no questions. Well, thanks so much, Matt. We have a little bit of time until the next speaker. We will start right on time. Until then, check out the expo, say hi to your fellow colleagues, and our other presenter might still be going as well. Thank you all. Hey, Steven, if you want to get a head start on getting set up, come on up. Hello, everyone. Welcome back to OLF Conference. I thank you all for being here today. My name is Warner Moore. I am your MC for the day. I am pleased and excited to introduce our next speaker. Stephen Pritchard has been a longtime attendee, a supporter, a speaker, trainer at OLF Conference, and we always appreciate Stephen being part of our program. Stephen is a VP of Infrastructure and Security at Secura. For the last several years, he's been focusing on compliance, automation, and all things DevOps, including container-based GitLab CI workflows. Today, Stephen is going to be talking about containers made easy with GitLab. Containers are great, but if you're not just consuming third-party containers on public registries, well, it can be a bit different. I know Stephen's put a lot of work into preparing this demo for you today, and one of the big things we're looking for is audience participation. So please consider questions, thoughts you have. We'll have plenty of time for Q&A later. Big hand for Stephen.
Thank you for that. All right. So let's get started here. Like I said, my name is Stephen Pritchard. I have been running Linux users groups since 1994, so I've been at this forever. Some of you may have come to my BOF last night on Vim. One of my hobbies is learning Vim and being really good at it, and so I have a little users group called Vim Geeks that I started up with a friend of mine. So that's, again, this is what I do for fun, right? For my day job, I am a newly minted vice president of infrastructure and security at a little company called Secura. We do compliance automation software, mostly for making servers compliant. So if that jumps out to anybody as a thing that you want, come talk to me later. But over the years, I've been a consultant, a trainer, an author, and I've been here in like all of those roles at some point or another. I think we've figured out this is my 17th OLF that I've been at. So yeah, so this is always fun. And for what I'm speaking about today, I'm a fan of GitLab, okay? When I started at the company that Secura spun out of, they were GitLab users. And I had looked at GitLab previously and thought it looked interesting, but I had gone a different direction personally, and I'd used other tools, and and several years had passed since I'd looked at GitLab, and when I started messing with it, I'm like, man, this is nice. I like this, And last year I did a talk. It's on YouTube, and I believe it was titled "I Like GitLab, and So Should You." So if you want a little more about why specifically I like GitLab, go look at last year's talk. But I am going to get into a little bit of that. And I really am just a fan of GitLab. They've got a program called GitLab Heroes. They added me to a little while back because apparently I evangelize for them and they like that. And but that's my only my only official connection to GitLab, other than I am a paying customer at my day job. But as a fan of GitLab, I want to give them a little bit of a free sales plug here. So this text is from their website, from their press kit. And I'm just going to read this, okay? GitLab is the one DevOps platform for software innovation. As the one DevOps platform, GitLab provides one interface, one data store, one permissions model, one value stream, one set of reports, one spot to secure code, one location to deploy to any cloud, and one place for everyone to contribute. The platform is the only true cloud-agnostic end-to-end DevOps platform that brings together all DevOps capabilities in one place. And I think I'm going to skip the second paragraph because that's a lot of that's too much marketing speak for me. The point of this is GitLab is a one-stop shop for kind of everything that you need to do from a software development standpoint. Okay. I stole this from their website, just a little clip from their website. This is all of the stuff that GitLab does. Okay, we've got everything from they've got a service desk component. Obviously they do source code management. I mean that's the obvious thing, right? That's what everybody thinks of. They've got code review built in, wikis and snippets, and a web IDE, and then all the continuous integration, scanning. They've got static and dynamic application scanning. They've got secret detection. They've got a package registry and a container registry and a Helm registry. I mean, there's a lot here, right? So you kind of get the idea. There's just all this stuff built in. That makes it really awesome to use. Specifically today, though, I want to talk about how we use GitLab with containers. Okay, so at Secura, we're doing a lot with containers. I mean, I actually had another talk that I kind of put together that ended up not doing. That was going to be stupid container tricks, because it was going to be about the way I personally use containers, which I do some goofy stuff with containers, and I really like containers. Containers are awesome, but at work, we're a little less goofy about the things we do with containers. We use containers, though, for local development and testing. So we do a lot of spinning up containers locally in order to have a known environment that where we can test our software, right? We do and we do things like spinning up PostgreSQL containers locally, so that we don't have to worry about trying to manage installing that and whatever. And so we can just tear it all down when we're done testing. If you are a VS Code user, there is a really cool thing that VS Code does called dev containers, where basically as part of a project, when you open it up in VS Code, you can have this, there's like a .vs code directory, and you can define this dev container. So basically whenever you open the project, you hit a button, it opens up that project in a container that you've defined. So if you need for one project you need a Java development environment, well, you can have all the Java stuff. And in another project you need Go, you can have all your Go tooling. You have your Ruby tooling, whatever. Just each project can have their own tooling, and that's super convenient for bootstrapping like new developers and stuff. It's like, here, install VS Code, and go to GitLab, clone this project, and you're done. There it is. Everything's there. So that's pretty cool. Another thing that we use containers for extensively is our CI pipelines. So I'm going to talk more about CI pipelines in GitLab in a little bit, but the short version is your continuous integration in GitLab basically is defined in a file in your project. Your pipeline can have multiple jobs. Each job can be executed in a container that you define, right? And all it really does is just run a little script in that container, right? So again, same situation. I need to run the Go linters, I can do that in a Go container. I need to build, I need to Go build. I can pull down a Go container to do that. I need Ruby tooling to run RSpec. I can just grab the Ruby container and then run my stuff, and I don't have to worry about like trying to install things as part of the pipeline. I don't have to worry about whether this thing's going to clean up after itself or not, because when the job's done and the container goes away, all that goes away, right? So that's great. So as far as the jobs and CI pipelines go, we've got everything from syntax checkers and linters, a lot of that, unit and acceptance testing. Some of our acceptance tests, we have to actually spin up real VMs to do them, but a lot of stuff we can do just in a container. We want to see how the software runs and whether it responds to, API requests properly and things like that, right? And unit tests are a lot easier to do in the containers. And then we do all of our build and release in containers because, as part of the job, you can specify a directory that is artifacts. So you run your Go build and say, and this directory is going to have artifacts, and that'll just get all zipped up and shipped back into GitLab, and GitLab will store that for you. So that's pretty cool. And one of the funnier things we do is we actually build containers in containers. So if you've ever tried that before, that has some complications. So I'll talk about that more in a minute when I get to the demo. We also run internal applications and infrastructure in containers. We are moving more and more to Kubernetes. Kubernetes pretty much is containers, right? So we do a lot of that. And our product delivery to customers, we're starting to have more and more customers that just want to consume a container of the software that we build. So we're doing more and more of that. All right, so let's talk a little bit about why we use containers. So as a small, entirely remote company, we don't really have the option of having like physical infrastructure, right? So we want to have things out in the cloud, but we don't really want to have to manage cloud instances either, right? So this is one of the reasons why we've moved more and more to Kubernetes, because then we're just kind of defining what we want running and letting the cloud vendor handle the details of making sure that the right instances and whatever else. We just say, yeah, we need this much CPU and RAM, and the right thing happens. So the big reason for using containers, period, is consistent, reproducible, immutable environments, right? So the container that I run in Docker on my MacBook Air is going to look just like the container that I run on my Fedora box running in Podman, that looks just like the container that's running in our production Kubernetes cluster, right? It's the same bits, it doesn't matter, right? So that also means it's reproducible, right? The worst thing you can have is, well, yeah, but I installed this thing from here, and I installed that thing. Oh, I built this myself, and and I don't remember which. My checked out copy was old when I built it, and I was on the wrong branch when I built this thing, and blah blah, right? That stuff happens all the time, so we don't want that. And then immutable, really that's a huge benefit in the cloud, right? We don't want things to be writable and permanent unless we mean for them to be, right? So we like that containers just, again, if you don't have a volume mapped to a container, when the container goes away, anything inside that container just goes away, right? And it gets recreated, and it's just like nothing ever happened, which is great. So another reason is application isolation. Containers are separated from each other in every way that the Linux kernel knows how to do. Containers are abstracted from the system. Again, like I said, if I've got a container, it could be that I'm running it on, on a Mac that's got a little, got some virtualization going with a little Linux kernel, and that's the way I'm running it. It could be that I'm running on a real recent kernel on my Fedora box here, whatever. It doesn't matter. The container just works. The only problem is if you when you start throwing like ARM systems into the mix, and then you got to figure that out, and that's That's a problem we've started having recently as people have started deciding they want M1, M2 Max as development systems. So I don't have good answers for that yet. So if you were thinking about asking, well, you can ask, but I'm not going to have a good answer. And then, of course, like say, allowed resources and containers are clearly defined and controlled. Now, you don't usually mess with that on your laptop or whatever, but you can. You can specify that, I only want this much CPU, I only want this much RAM, et cetera, et cetera. Now, you really do that when you're running things in Kubernetes. That's a big thing. You request a certain amount of CPU, a certain amount of RAM, that sort of thing. Network isolation. So containers, even if you're running as what it thinks is root inside the container, it can listen on the network, it can do all the things, but unless you forward a port to the container, then that's not internet accessible, and you don't have to worry about things randomly starting to listen on random ports or whatever. In Kubernetes, all your incoming traffic goes through a known ingress. Now, things inside the cluster can talk to one another on the random ports and whatnot, but as far as the internet goes, you completely isolate the traffic coming in. And then, of course, we want to automate all the things. I have a small team, and we really want minimal management and patching overhead. Even just having instances like, running we used to have like a random instance that ran our GitLab, and so I had to patch that thing, and I had to do, I had to watch to make sure it didn't run out of disk space, and I had to do just all those things, right? And it was, it wasn't a huge burden for that one box, but it was more than, than I really wanted to do in my spare time at work, because there were other things they were paying me to do. And then running things in Kubernetes with tools like Helm and being able to do, Kubernetes deployments and things like that, we can really automate all the pieces of the applications that we want to have available. All right, so now all that said, why are we using GitLab? Now, part of this applies to work. Part of this is just for my demo here, what I kind of want to talk about. So that page that I showed you earlier from their website that had all those tools. Well, we're going to ignore most of those, but I want to show you the source code management. I want to show you how you do code review in GitLab. We're going to talk a little bit about the CI/CD tools, the container registry, and the Kubernetes management that's built in to GitLab. All right, so all that was just so that I can switch over here and do a demo. Whoops, I'm going to put do not disturb on so I stop getting notifications. Go away. Forgot to do that before I started. So I have a GitLab instance. This is running on my laptop, okay? Actually, if you'll excuse me for just a moment, I just remembered that I made myself notes of things that I wanted to mention so I didn't forget them, and I completely forgot to open that up before I started. All right. Whoops. Okay, so I do want to note here, everything that I'm going to show you, this is GitLab CE, Community Edition, okay? So GitLab has, they've got basically 3 different versions, well, actually 6. They've got GitLab Community Edition, and then they've got GitLab Enterprise Edition. Enterprise Edition has some stuff that you have to pay for. Now these are the on-prem versions. Like this is the stuff that you can just grab a package and install locally. Community Edition is entirely open source, entirely free. So that's what I'm showing you here. There are other cool tools that you can give them money and they will give you. And the Enterprise Edition has like a premium and an ultimate. And the premium is actually pretty reasonably priced. Ultimate, it's a little pricey for my taste, but and then they have corresponding tiers on GitLab.com. If you just don't even want to mess with all this, you can do all the same stuff on GitLab.com. You don't have to run any infrastructure locally, right? And you can just let them manage it, and they'll just charge you per user, right? Or again, you can use GitLab.com the same way you would use GitHub, and just go sign up for an account, and you can do all the stuff that I'm going to show you on GitLab.com and not run anything locally. The only thing that you're going to get caught on is if you've got a lot of CI jobs, they cap you on the number of minutes of CI jobs that you can run for free. But it's still a decent amount, and you could probably pull off all the stuff that I'm showing you here without having to actually spend money. Anyway, so this is a very simple GitLab instance that's running here on my laptop. So, let's all give thanks to the demo gods that they let this go off without a hitch here, right? Anyway, I do want to note that the stuff I'm going to show you is kind of glorified proof of concept here. Some of it's pulled from stuff that I actually do, but I don't mean for this to be best practices. If you've got questions about that, feel free to throw them at me. But most of this is just I wanted it to run and I wanted to be able to show it to everybody. So if you see stuff that looks a little weird, it's probably a little weird. Please forgive me for that. All right, I have my project here. So this is, let's see here, we go over here, we've got our sidebar that's got, if I made this a little smaller, you'd be able to see the full sidebar with all the things over here, but we've got our, all of our CI/CD and our merge requests and yada, yada, yada. But I'm gonna open this project up in the Web IDE. So this is all built into GitLab, okay? They have a little IDE built in, so you can just go in here, you can do all your editing and whatnot. I want to go in, and this project is actually just running it's an Nginx container that's deployed via Kubernetes, and it's what's causing this little web page down here at the bottom. So what I'm going to do is I'm going to go in and I'm just going to edit this very simple HTML file. And I'm going to say OLF. I'm going to create a commit. And we'll go with the branch that they came up with, and we're going to start a new merge request. And so we create a new merge request. We can go down here in the merge request and say, we can delete the source branch. We can squash commits when we're done. We can go down here, see the changes. If we scroll down, we made one change, right? So anyway, I'm gonna create the merge request. As a reviewer, I go in here. Again, I can go down. I can see all the activity. We can put comments in here. We can add labels. We can do all the fun stuff. When I'm all done, I can approve the thing, and I can merge. So as soon as I merge that, you see it says it changed and said that the changes have been merged into the main branch. It deleted the source branch, and it started up this pipeline. Okay, so over here on the side, we can see the stages of this pipeline. I'm going to pull up the pipeline view. So we've got all of our stages of this pipeline here. So one of the things that I do in pretty much every project that I work on, I have a YAML lint stage, and this is pretty simple. This just starts up and runs YAML lint dot, and the reason I do this is because at the very least, basically every project has a definition for the CI pipeline, right? So pretty much everything I'm going to want to do that. I've got another job here called Hadolint. This one's still running. So this one just finished. So what this one does is it actually scans the Docker file for this project and tells you if there's any problems with that. So I'm going to open the project back up, and I'm going to show you actually, I want to show you the GitLab CI.yaml. So this is what the pipeline that I've built here looks like. So we've got stages. So this is kind of the old way of doing GitLab CI. This is what you usually see. But the way this, you notice I had like various stages, and there was like some number of jobs per stage, right? And that was kind of the way you used to do it. you define a stage, and every job in that stage would have to pass before the next stage would start, right? One of the things that you can do with GitLab now is you can actually define direct dependencies between jobs. So, you know, if, you know, like say you've got a mixed code base and you've got some, you know, some Go and some Ruby, right? And you wanna run, man, I blanked on the linter for Go. You want to run the Go linter, and then you want to start running the unit tests as soon as that's done, and you don't want to wait for the Ruby linters to finish and the RSpec tests to start. You know, like you can just do direct dependencies between these things. But most of the stuff that I do, it's not that complicated. The stages and stuff work fine. So for my test stage, I've got the YAML int, and you'll note the image here is actually pulling from $CI registry, which is actually the built-in GitLab registry. So I've got a container registry built in here. And it's in the same namespace as the current project, and it's YAML int, and I grab the tag latest. And all I'm doing is in that, I'm just running YAML int dot. And then I've got hadl int here. I'm pulling that one from the internet. And I do a little bit of setup, and I run hadl int with some arguments that actually lets me see a report in GitLab of any problems, like it shows up in the UI, and it uploads that as artifacts. So if we go back here, let me hit reload. Yeah, this is all this whole pipeline has passed. So the way that I'm doing the build on this one is when I'm on the main branch, it runs a job that tries to generate a unique ID to use as a tag for both the repo and the container that it generates. So it does that, uploads that as an artifact. On the next stage, it actually does a release, which is in GitLab. A release causes it to have there's like a little releases page that has a zip of that particular moment in time, and whatever you can have release notes and whatnot. But it also generates a tag, and it happens to be the easiest way in a pipeline to generate a tag. That's really all I'm trying to do here. And then actually, what happens is a separate pipeline gets triggered when the tag gets created that then does a build. The build uses a tool. I've heard it called Kaneko and Kaneko. I actually don't know what the correct pronunciation is, but think of it as a Docker build or Podman build a kind of a replacement. The thing is, I mentioned before that building containers inside of containers is difficult, and a lot of that's because the building a container inside of a container, it wants to talk to the local storage for the containers. So you have to run privileged containers in order to do that, and this is a way to work around that. So it works great. I use it all over the place, and again, the only problem is it only builds for the current architecture, and that's where I'm starting to try to think through how can I continue to use this but also generate ARM64 builds of things and whatnot. And anyway, that's a whole different conversation. So after when it does the build, it actually pushes it to the local registry using the commit tag that I created earlier, and also then to :latest. And then in this one, I also have a little deployment job that goes and says to update. And you'll notice the page down at the bottom says hello OLF now instead of hello $conference, right? So yeah, that's what that was all about. All right, so let's see, what else did I want to show you? Let's go in and look at the Docker file. I actually skipped right over that part. Let's go to the Nginx demo, Docker file. This is like a crazy simple container, right? I mean, we're literally just pulling in Nginx stable and copying a directory into user share Nginx HTML, right? Couldn't get much simpler than this. and Hadalint was perfectly fine with this. I'm not doing anything that it doesn't like. I have another container on here, YAMLint, the thing that I was running earlier. So in my YAMLint, so I've got a slightly more complicated Docker file here, and one of the things that Hadalint made me do was put version constraints on what version of YAMLint I was pulling in. So I was just grabbing a Python container, doing a pip install YAMLint, and yeah, it was very specific about wanting me to add some extra flags to the pip install and also to add version constraints. So yeah, all of that. The reason why all of that is there is simply because I started playing around with Hadalint. So yeah, if you learn nothing else, if you're building containers, Hadalint is awesome for checking out your Docker files. So so this one of the things that I do with containers that I build that I end up consuming in CI pipelines. So here, I'm doing from Python : 3-Alpine, right? So that's not their latest, but it's the latest version 3, which essentially is latest, and it's the Alpine-based container, right? Well, that thing gets updated fairly regularly, right? And I want to make sure that my YAMLint container gets updated, because if there's been security problems or whatever, I want to make sure, basically I want to patch these things, right? So what I do, if I go over to CI/CD schedules, I have a monthly rebuild. So just automatically, once a month, I have a job that just basically just triggers a pipeline on the main branch, master branch, whatever, and the time for it you can set, the intervals, you can do the checkboxes, or you can basically just do cron syntax. And in this case, I actually randomly generated the cron syntax as part of the script that added all this into GitLab. So I couldn't have even told you when it was running. But once a month, it'll go fetch the latest container from upstream, rebuild on top of that, push that into container registry, and I don't even have to think about it, right? So I do this sort of thing on every container that I use like this. So I've talked a lot about the container registry. The GitLab actually has several ways to store artifacts. They've got a package registry. Right now, I think it still only really supports like Maven and NPM, I think, but they've got like on the roadmap to support a bunch of other stuff, Debian packages and RPMs and all sorts of things like that. But they've got this infrastructure registry, which is, if I remember right, is Helm and Terraform, and then this container registry, which this is YAMLint, and I have a whole whopping 2 tags, basically from the first pipeline that ran and generated results here. At any point, I can go into CI/CD pipelines, and oops, looks like I had a build fail. I can run a pipeline, hit run pipeline, and that will do a rebuild of that container and push it into the container registry. Actually, though, this is going to tag it, and then the other pipeline that gets triggered will actually do the build and push it. But that's all it takes to do a rebuild. So if for some reason, like the monthly rebuild thing wasn't good enough, and you just you knew there was a security problem, you wanted to do an update right now, there you go. And of course, anytime, and the way I've got this set up is anytime something gets merged into the main branch, it triggers a build. And it triggers a tag and triggers a build. So I mean, that's sort of aggressive, like every single time something gets merged in, it gets updated. You don't necessarily have to work like that. But I decided that was, for little trivial things like this, that was what I wanted. Let's see here. What have I forgotten? Oh, the Kubernetes manifest. So going back to, let's see, let's go back to this other tab here. So my Nginx demo, I have very simple Kubernetes manifest here where I'm defining a deployment which has this one container pulling from the local container registry, right? Called Nginx demo, listening on port 80, and then registering with the ingress with HTTPS, right? I know HTTPS is a new. Oh, TLS down at the bottom. So anyway, that's how the app, the silly little app that I've got running down there at the bottom is defined. I definitely wouldn't take this as best practices. I'm running everything in one namespace and whatever else. It's horrible. But I wanted to get it all working. Anyway, anytime this changes, that'll also cause a redeployment. And the way that's done, we can go over here to infrastructure Kubernetes clusters. And they have a GitOps tool built into GitLab. Basically, what you do is you can, there's another file you create in a repository that defines what project you're wanting to manage. It can be itself, it could be a different project. Then you add that in this page, connect to cluster, right? And you hit connect to cluster, you pick what project you want to manage or what group you want to manage. And then you run a thing that actually installs an agent into your cluster, the GitOps agent, right? Works the same way that something like Flux or something like that would work. And then basically it just watches for changes, and anytime you make a change, deploys it to the cluster. So it's actually pretty simple to set up. And again, it's all built in. I don't have to have any extra tools to do this. So this is pretty cool. Let's see here. What else? I think that's about it. And I am getting low on time. So I'm going to switch back over and just ask if anyone has any questions.
Big hand for Stephen. Who here has questions? Not seeing any on Slack right now. I know Stephen was excited to share more about his demo here. So if there's anything you're wondering, he's ready to talk about it. Please share your name and then ask the question.
Sure. James. And so how is it actually deploying? So I know you were using Kubernetes, but how is it actually sending it over to that Kubernetes to get the website up and going?
That was that last YAML file that I had open up. That was basically defining the deployment in Kubernetes, and then the Kubernetes agent is watching that particular repo, and it anytime there's a change, it pulls the pulls the new version or whatever, and deploys it. Now, the way that I'm triggering it to know to do that is actually something a little funky. I don't actually know if I'm doing this right or not, but it works. What I'm doing is when I do a build, I get a new tag. So I tell the Kubernetes cluster to update the deployment and use the new tag. The thing is, the Kubernetes agent sees that's changed, and it's like, no, you said latest, so I'm gonna deploy latest. The thing is, by default, Kubernetes pulls the new container every time. Like the pull policy is set to always by default, right? So what I'm doing is I'm basically telling it, hey, change this. No, wait, change it back, you know. But that causes a restart of the pod, and so the new thing deploys, and it works. And I'm pretty sure that's not how you're supposed to do that, but boy, it worked in this case, and I decided to roll with it. So my resident Kubernetes expert and I have had conversations about this, and he's like, yeah, that's not how you're supposed to do that. And he's like, hasn't been able to come up with a great way to do it otherwise. That's another thing. Because I've got the Kubernetes agent associated with the same project where it's defined, like I by default get access from CI jobs to basically run kubectl and do stuff in the cluster using the context of that agent. Let me show you that real fast. That was a thing that took me a minute to figure out. So this is the config for the the GitOps tool, right? I'm telling it what project, I give it an ID, I tell it the namespace, and I basically tell it the path to the Kubernetes manifests, right? So then in, whoops, that was not what I wanted to do. Let's go back up here. In the .gitlab ci.yaml, down in this deployment job, I can run, so I'm grabbing Bitnami kubectl latest, and I can do kubectl config get context, use context, and basically it's the project name, right? And then I'm allowed to do things like, in this case, set image, which overrides the image tag to use for the deployment, which again, like I said, just gets reverted right back, but it causes a restart of the pod, so that's okay. That's all I really wanted. So yeah, that's how all that's plugged together, which probably makes no sense if you've seen this before, but you feel free to grab me later, and I can try to run you through this as best I can. I'm not an expert at a lot of this. A lot of this demo was my excuse to figure all this out. So yeah. Anyway.
There's a question in Slack from Zach Villers. I think your presentation might have answered this, but I'll ask it for Zach anyway. What did you learn when rolling out GitLab at work? Tips appreciated. Good talk.
So using GitLab at work, I will tell you, if you're running the omnibus version on a single node, it can be kind of heavy, and you really got to watch for like the amount of disk space it uses, because projects use disk space, and the registries use disk space, and the backend database uses disk space, and so you can end up doing that thing where you're chasing the space that you're using. It does help to move a lot of that into if you're running it in a cloud hosted environment, move a lot of that to like buckets on whatever your cloud provider is. That handles a lot of the just miscellaneous space expanding. Once you've done that, the moving entirely over to Kubernetes for GitLab is actually pretty easy. They publish Helm charts. It's not that hard to get running. That's how all this is deployed. I just ran the Helm chart. Now I'm using all the defaults, and it's I doubt it would scale very well. But it's not that hard to add in bump up the reservations for CPU and memory and whatnot. And so yeah, it's. It depends on how big the team is, how much management it is. For a small team, you can probably just, have a relatively small instance, like 4 8 gigabytes of RAM, something like that. Probably 40 to 100 gigabytes of storage, and you can probably run on that for a long time. If you've got a large team, you have to plan a little better, but. It's not that bad. And if you got specific questions, feel free to contact me. Which, by the way, I'm going to switch over to this. I'll leave that up there. So that's the company I work for, and the other one's the other QR code there is my LinkedIn profile. So you feel free to message me if you got stuff more in depth.
We have another question back here, Stephen.
Yeah.
Yeah, Tom Featherston. You may have covered this. I missed the beginning. What's their monetization model / concessions to open source?
Well, now I'll tell you that I don't work for GitLab, right? I'm just a fan, but GitLab does they have their enterprise edition that they charge for. I think it's like $19 per user per month, I think, or is it? Yeah. Anyway, I don't even remember. And then it's like $99 for the ultimate version that has a lot of extra enterprisey features. And then it's a similar pricing model for for GitLab.com. But you can use GitLab.com for free projects. You can use GitLab Community Edition for whatever you want. Right? There's just some extra features that they add, and they're really around like some more of the team management kind of things, and it's just the stuff that larger enterprises are going to want. It's I'm a premium customer at work, and it's well worth what we're paying for it. I know that. So.
Yeah, lots of positive feedback on Slack, Stephen. Nice job. GitLab's an interesting company, too. They're an international 100% remote company, and they publish all this stuff, their management, their culture, their policies on their website. So they were doing this long before, well, we had a pandemic, and it trended. Really interesting company.
Since 2011 was it? I think is when they started. And yeah, they were kind of making a big thing of that, but like you said, before the pandemic ever hit, and then when the pandemic ever hit, it's like, hey guys, just do what we've been doing for ages now, you know. And yeah,
welcome to the party.
Yeah, right, exactly.
Hey, good morning. I'm Andrew. I had a question. You mentioned your pull-based approach to pull in the latest containers when a merge is committed or you build a container or something like that. Is there more of a push-based? I mean, is there a way where you can get, like, let's say one of your dependencies gets updated because it has a security vulnerability? Is there a way that you would know before you do a merge or before you kick off a pipeline or something along those lines?
I don't have a great answer for that. I will tell you that they do support with the Kubernetes agent the built-in stuff, and you don't have to use their built-in stuff. You could use Flux, you could use some other GitOps tool, but the built-in thing is not bad, and it does do pull and push. Generally speaking, people seem to think that pull is the more secure way of handling that. I don't have strong feelings in the matter, but you do get a limited amount of push capabilities just by default. Also, which is how I was doing the kubectl stuff in a pipeline here. Dependency scanning and stuff like that, I think, is actually like an ultimate thing that they have now. And a lot of that, they're just using stuff that's they're bundling up a lot of open source tools. You can build the pipelines and stuff yourself to do all the same stuff. You can trigger, like a pipeline in one job can trigger a pipeline in another job, and so you can do a lot of stuff without needing Ultimate Edition. But it's more work for you, right? Yeah, I don't have a great answer for you, but I am sure there is a way to do whatever it is that you're trying to do. I will say this: I was sitting here, I got the demo already, and I was like, oh, now I can go in and make these pipelines better. I'm gonna start like making them look nicer and everything else. And then as I started working on this, I'm like, I need my whiteboards. Like, I got to draw this out. Like, this is like, handling all the conditions, because you can trigger a pipeline on a commit or a merge request or a tag or, via a schedule or via the API and it actually handles those. Like, you have the capability of handling each of those separately, right? And so I'm like, the reason why I've got this two-stage thing where I have one pipeline that tags and another pipeline that builds is I wanted to be able to just trigger a the build by just tagging. If I just go in here, create a tag, I wanted it to just happen, right? And so I did it like that. I'm like, well, but it'd be kind of cool if you could see all the way to the end just in one pipeline. So I started trying to figure out how to redo it. Man, it got complicated fast. So there's no end to what you can do. It just might get super complicated in the meantime. Anyway.
Any other questions? All right, big hand for Stephen. Thanks so much, Stephen.
Thanks, everybody.
Crazy that we've been doing this for 20 years, huh? How awesome is that? 20 years OLF has been happening. Well, this concludes our last presentation for this stage before lunch. For those of you who financially supported us, thank you. We would not be able to do this without those who paid for OLFI and Supporter. It's a very important part for the success of our conference. We will be providing lunch for you at noon. For those of you who didn't support us, thank you for being here. Across the street is a place called North Market. All sorts of interesting food. Or if you want any specific recommendations, it's my city. I'm happy to point you in the right direction. We'll resume the program at 1, but before that, our fine conference chair, Vance, has some announcements for you. Big hand for Vance.
Thank you so much, Warner. Yeah, as Warner noted, we've got some restaurants and such around. We do have some maps at the registration desk if you want to look around there. I do have a couple of things. First of all, if you bought a package that included a t-shirt, that would be the supporter pass or the OLFI pass before November 17th, which was the printing cutoff. Please make sure you collect your shirts. I think there are about 10 that we have up there. At 3 o'clock this afternoon, if they're not picked up, we're going to sell them. We've got a few also other ones for sale this year and some from previous years. If you didn't get in before that deadline and if you want to buy a shirt, there are a small selection that are up there. Also, the raffle is going on. You can see some of the prizes up at the registration desk. That drawing will be at 7 p.m. tonight. If you're here, you can pick up the prize. If you're not going to be here, you can still enter and win. You'll just have to pay to have the items shipped to you. Again, thanks a lot, and we'll see you back here at 1 o'clock.
Hello, OLF Conference. Hope everyone had a fantastic lunch. My name is Warner Moore. I'm glad to be here with you today. 20 years of OLF. Big team through this for you today. A hand to the team of about 10 folks who made this happen. Muted after lunch coma applause. I'd rather be taking a nap. Not really. Good lunch. Well, now I'm excited to introduce our next speaker. John Aaron has been a recurring speaker here at OLF over the years. John's an entrepreneur and technology professional with a background in tech and cybersecurity starting from 1999. His company, Aeronetics, helps companies with cybersecurity through an embedded Linux kernel module that monitors for security issues. Today, John's going to be sharing a bit about his product, his company, and what they do. Please welcome John to the stage.
Thank you, Warner. Can everyone hear me? This all works? Cool. Thank you. So this is a mashed presentation that I've delivered to OLF, to B-sides in San Diego and Columbus and places in DC. So if you take nothing away from this, realize that in Cleveland, Ohio, I use deionized water in my water receptacle to clean my windshields because cleaning glass is a pain in the butt. It's just what it is. I don't trust the windshield washer fluid anymore. So when I was off-site in Tampa at a SoftWorks meeting, this is a screenshot from my phone of my server that recognized these two file changes. And to anyone in the community, those are kind of important files, right? Like you want to know what happened there. And so I don't know what happened there, because when I came in, I could sudo to the machine, but I couldn't actually log into root. The other environmental settings weren't not available. And I have to be compliant too, because Aeronetics is a DoD defense contractor. The average NIST score on compliance is 52 to 56 out of 110. I would like to think I'm a solid 104 based on my InfoSec security posture. But when I report this, I don't know if the NIST checklists really align to that issue. So what do we do to remain in control, right? So what do you guys do to mitigate issues like that? Are you aware of issues like that? Thank you. It's a ghost, right? I don't know. So what we have here is the impetus from the White House saying we need to find out these issues. That deterrence, and it's critical to the whole Western societies, right? We had the 2018 hack of China in our hardware. We had a lot of other issues. And so the first line of this is that the United States is increasingly persistent facing malicious cyber campaigns that threaten the public and private sectors and ultimately our security and way of life. We must improve our efforts to identify, deter, protect, detect, and respond to these actions. It's pretty lofty. And that's all lovely, but 1/5 of our CISOs, our CTOs, actually believe their controls are adequate. It's a pretty winning game. I'm not going to go on LinkedIn and say who's going to give their resume to a ransomware provider because they're kind of winning, right? But I don't know if any of you folks know Dr. Chase Cunningham. He's a former Forrester person, analyst, that also recognizes as Gartner that 9 out of 10 fully compliant are breached. That the average time is 207 days plus the 70-some days to mitigate the solution. And I usually travel a lot, and I stay here too. Does anyone know offhand the average time a lurker was in the Marriott system? Pop quiz, anyone? More. 1,460 days. That's a while that you just had someone roaming around your network. So from the ransomware website on how to mitigate these things, it's usually contact CISA or contact the FBI and report this, and contact your insurance agency and contact your law firm. But this summer, an anonymous provider shared that 83% of their payouts were due to a breach. So really, like, why not go work at a ransomware provider? Right? They're making money. You have to eat too. So it's interesting. If you let that soak in, it's interesting that we're in this peril paradigm. And so a slide that was shared at OLF in 2019 is the concept of zero trust. I imagine everyone here has heard about. It's a hip thing. It's pretty hip. And I just see that it's kind of broken. It's a real Friends carabiner that actually broke that. And it's supposed to be a secure system. I mean, I've been climbing for 25, 30 years. That shouldn't break. But that broke, just like the current paradigm we're in. Because I imagine everyone here, including me, don't hop on your own private Wi-Fi. You use the hotel's Wi-Fi. And you like to think the hotel's Wi-Fi is all safe and secure, right? But you don't know. I wish people did know. But the perimeter has become the person. Okta's chief recognizes that you are the perimeter. It's give access where you can give access. And so a worldwide provider to security within the US government with 2,000 active directory servers cannot clean their network. It should be concerning to everyone here. And so how did I clean my network? As a Red Hat partner, I used a tool called ddiskit, and that's the GitHub for ddiskit. It really is, you could just git clone and away you go. Except it's kind of confusing. It hasn't been managed in 4 to 6 years. It's not a ghost project, it hasn't been forgotten about or defunded, but no one's actually maintaining it. Part of the presentation here and otherwise is if you use ddiskit to build a kernel module, you need to specify and change the major number. That's your actual rel 9 or rel 8 actual spec. You need to also then add things below this. The whole file is kind of large, maybe 300 lines, but at least you need to change the major and minor, which that could be scary in and of itself, because when you change the module config, which is the other file you have to change, you have the kernel distribution release string and the kernel flex string, the kernel release string, and the kernel string. And so while you specify this for rel 9, it could work on rel 8, even though it's not built for the rel 8. So it's what type of ghost is in your machine? It shouldn't do that. But you have to at least modify those few things so this will work. And this file itself is probably 500 lines. Not exactly accessible to print everything here. So when you use ddiskit and you modify the module config and the other file, like there's files everywhere, there's the primary two. You really run prepare sources, generate spec, and build the RPM. It really is 3 things. You have to specify that, and out comes, as you may have guessed it, from your source, a fully fledged built RPM. You can assign it, and you can distribute it like an RPM. You can do everything you want with it. So when you've done that, you can also build ISO. It's a command, and it'll output an ISO. Except there's another 3 that you have to do. And you have to make sure you have OpenSSL mock utils and key utils so you can interface with your UEFI. There was a conversation I had with another person at the OLF conference that's a known person in the industry for like, I don't know, 50, 60 years that doesn't use the UEFI. But if you do, you have to use these things. You have to ensure that actually your key that you built is imported into the mock. And when you type that password twice, you can enroll it into the mock and you reboot. Do we have any questions on any of this? It's kind of out there, I think. No? So when you get into the mock, you can choose enroll your key. And when you've done typing your password there just once, you're presented to a screen like that. That's digitally signed in the UEFI. That key is something you already specified and tied to your kernel module. So if your kernel module is altered, that key doesn't get altered. It won't load. It'll error out, you'll know. So if your UEFI changes or your TPM module changes, at least you know something's up. It's not immutable software, but our software lives on the CPU architecture. Not to go deep on your north bridge and your south bridge and your memory channels and other stuff, but we're on top of the firmware. And what we built using that ddisket tool is a kernel module that speaks JSON about your whole environment. That goes anywhere. We can speak to your phone. We can speak to your other tools you have to use. We can do a lot more with it. The commonly understood thing about what we've built is idling a Fort Knox. Fort Knox is in Kentucky, I think, yeah? Have anyone seen this thing? Anyone? You have. And so it's surrounded by... Fair, thank you. It's surrounded by four granite pillars. And then you've got everything else on the inside and on the inside and on the inside. And then you have the 4 keys you need to unlock the safe. I don't know. I don't ask questions too much. But it's a good analogy for what we've built and the whole industry. Because most applications are at ring 3, which is your sentries outside, your granite pillars. And then I don't know why people don't use ring 2. I don't know. I don't ask that question. We commonly use ring 1. It's a driver level spec of where it can live in the system. So if you are on Windows or on Linux and you go to super user or super user or root or admin, that's operating in like ring 1. Sometimes you have tools like the NVIDIA driver or what I've built or SE Linux that live at ring 0. And so what this is and what it provides is actual intrinsic security of the entire machine. That I've had meetings that your TPM module, while it's immutable, isn't always the case. It's a nice goal. The UEFI, there's an open initiative for the open UEFI. But the fact is that Dell's not going to ship the open one. They're going to ship the Intel-based one. The industry's kind of stuck still on, we keep on pushing for open source stuff, but it's still a UEFI system built from Intel. And so of that, we live down there as well as the NSA. But our technology isn't NSA made. We're after the cut. So I don't know if you know, does anyone here know what that means? So there was an old hack, probably in the mid-90s. You could hit Control-D at the cut and be dropped to a shell. I didn't build it, but I didn't exploit it either. I'm just aware of it. We're there. Other tools like Halcyon. Does anyone know Halcyon? It's an upcoming malware tool. And then we have all the other ones you may have heard of, Sentinel-1 and Lacework, and a lot of these other providers. And so you need everything else. You just do. To guard a system nowadays, you just do. What we've done further to that, to guard and how we actually ensure and control security, is shifting our posture every 7 minutes. So if you Nmap scan my machine or you ping my machine, it'll report that it's Ubuntu, or it's Windows, or it's IRIX, or HPUX, DEC Unix. There was a tool built from an Irishman that took attempts to SSH and piped that to Google Analytics. Has anyone heard of that or tried that or even thought about piping that? Because you can take SSH attempts and put it on a spreadsheet. This isn't online anymore. When I presented this in 2019 at the OLF in 19, it was online. His website now is gone. It's now on the web archive. And really, it's that easy. You just pipe in your TID of where you want to put it, your host, and hit go. Put it on your website. Put it in the server. So what I've done is I track the trackers. Like, who's coming here commonly? Who's airing out? Who's submitting your form on your page? Like, what do you guys do to, if you have a 404 on repeat, what do you guys do about that? You do what? I can't hear you. You block it? And you block it with IP set or IP tables or? Yeah, that's likely a good deterrence, right? But nowadays there's no network perimeter anymore. So if you block China, all they do is get in a Washington state IP address. What are you gonna, like, how do you mitigate that? So part of the presentation is how we actually have integrated deterrence. I was at a meeting of such name in the DoD 2-3 weeks ago on integrated deterrence and how to actually stop provoking our adversaries to, if the wrong word, play with us. Does anyone here know what either of those two things are? The right one is toxaferine. It's a curare molecule that the South American tribes would use to paralyze their prey. And the left one is 42.zip. Does anyone know what that is? It says what it does. Further conversations of what we do, we can take after the conference. But we live down there and speak JSON and all these Google Analytics to actually do some little bit of magic stuff. So we gave the computer a job. So when you're actually here presenting or you're at the coffee shop working, you can be assured that you own your own data, that data privacy is something that you want. That if you're on SUSE or CentOS or Alma or Rocky, you can actually be assured your data is not tampered with. I don't know the quick hotkey on PowerPoint to go back to the second slide, but my group and password file changed. And that hasn't been seen again. That was in June. You can find on YouTube other related links on the 2013 EU Linux conversations, shall we say. But what's actually in your machine? You can't actually know. There is no solution because, like everyone, like me, like you, I'm just a human. I can take control of things about 7 minutes. I'm pretty good. I can concentrate in that time period. But to do a whole 24 hours a day, to be aware of all these changes, you can't. Part of my Red Hat partnership is a good joke on my 6th podcast on how zero trust is equivalent to Marxism. It's nice on paper, but to actually, how do you do that? I mean, it's not something you can walk into on Fort Knox. You can't actually do that. And so if you go to your bank and try and make a new bank account, they know a lot more about you than you do about them. Every time. It's that manner of recognition, deterrence. So I built Aeronetics. I came back online in 2013. I proverbially turned off my laptop in 2007. I was a systems administrator at Ohio Healthcare Managed Company. I don't know if you caught my comments last night at the Birds of a Feather, where I mentioned I was in charge of all these little offices with proprietary T1s all around Ohio that are point-to-point, and unless you have a business going point-to-point too, that's dormant technology. Sorry, no one removed that. So it's a DoD defense contractor company that we built a digital hammer to mitigate these issues. And so we built a thing we call Thor, like Thor's hammer. It's a pretty powerful little tool. It's a Red Hat certified computer module that mitigates my issues, where I don't have to really pay attention to the NIST controls anymore, even though I still report them. As a Red Hat partner, it's on their ecosystem. We'll be working with SUSE Enterprise to be on the SUSE Enterprise ecosystem. And it's important because for what we've built, unless a major company, enterprise, is going to adopt and certify your technology, there's no point, because you live down there in the kernel stack. It doesn't alter the machine, but it's dangerous. It's at ring 0, right? You can do what you want at ring 0. Part of the after conversation is how we do integrated deterrence. This is a defensive tool on their catalog. So who I really am is really a joke, so to speak, but on the West Coast, I'm much more of a climber, a cyclist, a runner, a swimmer. On the East Coast, a computer geek. I wasn't so good at school, like a few other people that built companies, and my degree's in IR, Poli-Sci, and French. So some ideas and tools do belong open sourced. And there was a conversation I had 2 nights ago on this tool, whether or not if someone embodied this idea when they were 18, 20 years old, would they open source this tool? It's export controlled. It's not on the ITAR, it's on the ear. But some tools, like some aspects of Linux, are closed sourced. You don't get to play with parts of gparted. You can't modify those things. You can't share those things. If you want to stay in contact or talk to me afterwards, I appreciate it. That's how to contact me. If you're going to build anything with yourself with ddiskit, you can also contact me. It's murky. So if you're going to sign things, do you guys actually sign your RPMs? No? You just say, there you go. And so if you're going to sign them, you need to remove, with ddiscit at least, that passphrase F file descriptor 3. It'll choke. I don't know why. They haven't maintained it in 4 to 6 years. I don't work there. It'll choke. You have to remove that. Part of the ASLR, the address serialization random loop, that's okay too. You can keep your memory addresses being randomized. It's secure that way. It's better that way. But you have to make an RPM macro file similar to that whole thing. And the full tool that Magnus built is that tool. You can find it on the web archive. It's not that complex, but you see that he actually logs all the bye-byes, the connection closed, normal, and possible break-ins. And if you can apply that to other things at ring 0, full of insider threats and external threats, at ring 0, you can actually deter and perhaps lock your machine. So if you're doing weird stuff, there's no more Snowden. There's no more other adversarial tools we don't mention on YouTube. It's an end. It's a deterrence that you actually can say, huh, please don't do that. Because currently, what you can do is for after discussion of not necessarily shut them down, but you can say, hey, please give me a second. And that's pretty much how we did it. It's a Red Hat certified module. You build all your C code however you want to. Use ddiscit, and bam, you have a kernel module you can build. You can install. Ddiscit is only used for kernel modules. It's not built for everything in userland. DKMS is the Ubuntu variety of the dynamic kernel module system. That's the Ubuntu one. This is the Red Hat one. Does anyone have any questions? We'll take them after if you have any questions. I appreciate the opportunity.
Well, thanks so much, John. Did you get through questions, or any questions from the audience?
We can take them after the fact. But yeah, any questions here?
I'll check Slack while I'm staring at you awkwardly. Well, tell you what, let's check Slack separately. Our next presentation is going to be at 2 p.m. in this room. I'm sure if you have any questions about aeronautics, John will be around. Will you be around the rest of the day, John?
Yeah.
So, great conversations over a beer at the party later, I'm sure. Thank you all. See you again at 2.
Thank you.
Hello, OLF Conference. Well, it looks like everyone's recovered from lunch. The room is full again. Glad to be continuing the program now. We have our next speaker, Matt Williams. You know that meme, the most interesting guy in the world? He's associated with some sort of alcoholic beverages. Well, that's Matt Williams. He's a bit of a journeyman. In fact, his skill set is so multifaceted and interesting, you could talk to him forever. So in addition to being the most interesting guy in the world, he's also a technologist. Very experienced speaker. He's spoken at OLF in the past. He was one of our first speakers at DevOps Days Columbus when we founded that organization. And not coincidentally, he's going to be speaking about DevOps today. More importantly, what DevOps isn't. Please welcome Matt Williams to the stage.
Okay, yeah, thanks. Thank you. Okay, so I'm a little embarrassed now and feel like I have a lot to live up to. But thank you, Warner. So we're going to talk today a little bit about 10 things that DevOps is and 10 things that DevOps isn't. There's a lot of talk about DevOps. The first actually research and papers and such that people were doing about DevOps go back to about 2012-ish, 2014. And interestingly enough, right about that time, I was doing some investigation into, well, I called it ops for devs. We see which one caught on. So as Werner says, I do a bit of everything, and that's partially by choice and partially by desire. But let's, over the next hour-ish, let's take a journey together. Let's look at the world that is and misconceptions that we have. And let's also look at the world as it could be. You know, if everything were perfect, you know, we're going to spin a vision of DevOps done right. So let's talk about what is and people's preconceptions to start with. Well, right now, in a lot of organizations, there are very long and costly delivery cycles. I've seen more than one organizations where, you know, they push code once a month, every 3 months, every 6 months, every year. And if for some reason you're not ready, well, you can then hop on the next train. Of course, all of these changes require lots of coordination. People don't know what's going to break. And so you have to get all the stakeholders together to make sure that everybody's on board. Also, there's slow feedback. Anybody ever work on a waterfall project? Yeah, you know how, you know, the devs write their code, they push their code. 6 months later, if you're lucky, a tester might look at it. Oh, wait, we've got development that's taking longer than we expected. Okay, testers, you have 2 weeks to test everything and then send it back to the developers who haven't looked at it for 6 months or longer. Even with Agile, a lot of times you don't have fast feedback. You'll get some of it. You might know that, okay, this function and this story card that I wrote for works the way we expect it to in isolation, but you still don't have feedback of it across the entire system. And then rigid blame. You know, who broke it? Whose code is at fault? Who did this? Anybody ever be at one of those postmortems that turned into a circular firing squad? Yeah, we got to do something. We got to fix this. X is something, therefore we must do X. You know, the thing is, you really need to fix the problem, don't fix blame. So let's talk about what could be. How about a world where we can develop and deliver value to our customers quickly? We don't have to wait for months and months and months. We do this by removing barriers. What is it that's keeping us from delivering value? So you fix that, you find the next thing that's preventing you from delivering value, and go from there. Fast feedback. If you're deploying on a regular basis, well, you're going to know if your code worked or not. Sometimes the hard way, but there are ways to mitigate that. The sooner a developer can get feedback on their code, the better. It's going to be in their head. How many people know exactly what they wrote 6 months ago? Anybody? How many people know what they wrote yesterday? Sometimes, yeah, sometimes. There's those times where I've stayed up in the middle of the night and everything seems like perfect. Oh, wow, this is the greatest solution ever. Next morning, what did I write? What was I thinking? So the sooner you get feedback, the better. And we can also have an environment that encourages us to play, to experiment, to improve our processes, learn new things, learn new ways. Say, this tool isn't quite working for us. Let's try something different. So this is a world that we could live in if, we implement DevOps and do it right. So most of us work at disorganizations where some of them, they'll have the ping pong tables and everything, and they try to put the fun back into dysfunction. So one of the things that I've done over the years is occasionally I'll mine Dice or Indeed or some of the other job boards. And, DevOps X, DevOps Y. There's thousands and thousands of, job listings that DevOps. And then the first thing that they say in the job rec is, as a DevOps engineer, you will use tool X. So DevOps is not a title. DevOps is a methodology or set of methodologies. It's a philosophy. It's ways of thinking. It definitely isn't a job title. Anybody who is within the entire stream of code from inception to support, or support, inception, and so forth, can do DevOps. DevOps is not a checkbox for a resume. Yes, it might be hot. It might be something that looks good. But don't just put it on your resume to check a box. The good recruiters are not going to be necessarily doing the, hey, you've got this skill, this skill, this skill, this skill, this skill, therefore you're a good fit. Now, let me suggest that people actually find a recruiter that they like, develop a relationship with them, and they'll look out for you and you look out for them, and it's going to work a lot better than just blindly submitting out to job sites. Another anti-pattern that happens pretty much everywhere, they have a DevOps team. We want to do DevOps. So we're going to have a team for it. Just like we have a database team, just like we have sysadmin team, just like we have a development team. DevOps is not a team. It's something that needs to be implemented. It needs to be part of your culture. And DevOps isn't done alone. You can't have on your project the sole DevOps person that all they do is DevOps. DevOps 24/7, 365. Yes, that is you. Oh, that's a DevOps problem. That's not a problem with my code. Yes, DevOps is not done alone. It's not done in a vacuum. And, I'm talking about all the great things about DevOps and so forth, but don't fall into the trap like a lot of people are. An executive will go to a conference and they'll hear, oh, DevOps. Oh, this is the best thing ever. We have to have DevOps. Okay, do you know what it is? Do you know why you're doing this? Do you even have some idea of the purpose of it? Oh, everybody's doing it. Therefore, in order to be the hip, cool company, we have to do it too. Yeah, no, don't jump on the bandwagon. So if you're doing DevOps right, what are some of the things that you might do? DevOps is a culture. I've mentioned that once already. It's a paradigm. And like most cultures, you need the proper environment in which for it to grow. So if you've ever tried baking bread or making yeast, if you have the temperature and humidity wrong, it's not going to grow. Same thing for DevOps. If you do not have your DevOps in a good environment, then it won't work. And paradigm, going from a current paradigm to a future paradigm means you have change. And what is change? Change hurts. DevOps of practice. I've been involved in DevOps for almost a decade now. And I still don't get it right. I'm practicing. And as I practice, I learn stuff, and I go from there. And it's a journey. Don't expect that in a year, in 2 years, what have you, that your organization, your project, your team is done with DevOps or has, okay, we've deployed Project X with DevOps. We are done. We don't need it anymore. Of course, that doesn't take into account the SRE role, but that's a topic for another day. And DevOps is a partnership. Anybody ever work on a project where the devs write the code, code's written, they throw it over the wall to ops? It's your problem now. Anybody ever have that happen? Yeah. DevOps is a partnership. DevOps is taking all of the people who are involved in a product, in a feature, in something that's delivered to customers, and making that whole entire flow, that whole entire process as smooth as possible. So there's some technology ideas about DevOps. The first misconception is DevOps is all about a technology. You might hear CI/CD thrown out. We're doing DevOps. We have a CI/CD pipeline. No. You might be doing DevOps. But if you've totally focused on the fact that because you have CI/CD, continuous development, continuous integration, that you are doing DevOps, no, you've missed the point. I mentioned before that a lot of the recruiters are like, as a DevOps engineer, you're going to be using tool X, tool Y, and tool Z. No. DevOps, again, is about removing barriers to delivery of value. DevOps is about getting fast feedback and so forth. It's not about the tools. Yes, you will use tools, but if you focus on the tools, you're going to be seeing the trees and not seeing the forest. So what should the role of technology be? Well, for starters, even though there's technology, DevOps is really about people, really about communication. So when I was younger, and less wise than I am now, although how wise I am is debatable, I used to be the dev that they would keep chained up in the corner. And I kind of outgrew that with time. They don't chain me up in the corner anymore. And yeah, he's good, but don't let him near anybody. So, I've kind of outgrown most of that. I still have my days where I'm a throwback. But, I've learned over the decades that I've been working that, technology's easy. People problems can be hard. And everything that we solve in IT, at its root, is a people problem. Somebody has a problem. Somebody has a need. So we're going to solve it by making it easier to solve their problems. It's a people thing. We have to communicate. And, I mentioned that the tools aren't the thing. The tools are merely a mean to an end. Don't focus on the tools. Focus on the journey. Focus on figuring out what is preventing you from delivering value to your customers. And then processes. Every organization has processes, right? And policies and so forth. And some of them are set in stone because either they've always done it that way, or I've worked at some places that have long tenure for their employees. One place I worked at, I'd been there for 11 years, and I was still relatively new. And so there were rules that were written kind of in stone, but if you asked to see the tablet, you'd never be able to find it because it had been decided in a meeting 10 years ago by 3 people that you're working with out of a room, that had 5. But the 3 people are there, and they knew exactly why that particular rule was there. You got to be able to look at changing the status quo. Just because something has worked okay for 300 million years does not mean that it necessarily is the best thing that you could be doing today. Nor is DevOps about automation. Yes, you will likely use automation in order to solve issues of getting value to your customers. The less human involvement, potentially, the faster it can be. But, again, it's not about automation. DevOps isn't fast. DevOps takes time. DevOps takes patience, work. It's an iterative process. Let's find out what's causing us the most grief that we can solve. All right, let's solve that. All right, what's the next thing? Where can we streamline? Where can we go faster? And it takes time. It takes effort. And DevOps is not, despite what some vendors might try to claim, a magical silver bullet. It's not going to solve all your needs. If your organization has fundamental structural problems, fundamental communication problems, transparency problems, and so forth, then DevOps probably is not going to solve the problems that your organization's having. It may solve 1 or 2 minor problems. You might be able to get something shipped more regularly, but if you aren't in an organization that functions, then it's not going to solve your problems. So what can DevOps be? What can we see come from it? Well, DevOps is about change. Change hurts. Most people don't like change. Being able to manage change is very useful, very helpful. But again, most people don't like it. Most people are uncomfortable with change. They get comfortable. Have you ever, how many people have cats or have been around cats? Okay, a fair number of you. What do cats do when they see something new? Either they sniff at it and run, or they'll look at it and, what is this thing? Okay, that's weird. I'm running away. If you don't even get the cat teleport happening. You know, guess what? Cats are not that different from us. Working with developers is like herding cats. And I strongly suggest that when you get a chance, if you haven't seen it before, watch the old EDS, Ross Perot's company, by the way, cat herding commercial from the Super Bowl. It's only about a minute and a half or so long, but if you've ever tried to manage or be managed in a IT or other organizations, you'll find it funny. You might find it's a little too close to home, so it might be a little uncomfortable. So, you know, this is your warning. This might trigger people. But that said, you know, if you've ever been around cats, the herding bit makes a lot of sense. And speaking as a cat slave, the main idea is to convince them that A, it's their idea, and that B, that they really want to do it because they're going to get something from it. Same thing with developers. DevOps is about repeatability and reproducibility. How many people have ever heard the, but it works on my laptop? You know, in that case, okay, all right, cool, it works on your laptop. Now, make it work on this server. You know, if something's not repeatable, then you don't know that you're going to be able to deliver value. Likewise, if something's not reproducible, can you reproduce a bug? Well, sometimes, you know, maybe not. You know, there could be a solar flare. That's not really reproducible. But, or a power surge, or any of a number of other things that aren't reproducible. But outside of those, you know, acts of God, as it were, you should be able to reproduce things. If you can't reproduce, then it's going to be really hard to deliver value. It's going to be really hard to try and debug things. DevOps takes time to do it right. You know, I mentioned it's not easy. It's not fast. There's learning involved. One of the projects that I've worked on, a big part of our thrust and focus was along the lines of empowering developers. So instead of them putting in a request for a server or a container or what have you, a place to run their code, and having to wait 6 months because, you know, capacity's full in the cluster. We have to put in before finance because it's not budgeted, of course. And it's going to take 6 months, 9 months, a year. Well, I'm sorry, you can't deliver. You can't deploy until we have the place for you. We were looking to where the developers could decide what they needed and then create it themselves. But they had to learn how to do this. This is new to them, and new things are scary. So there was time needed, hand-holding, and so forth. So it takes a lot of time. Once you've overcome some of the resistance to change, there's a learning curve. It's going to take time. But at the end of the day, DevOps is about reliability. How reliable are our products? How reliable are our systems? So we have 3 R's in DevOps, and this is a nod back to the talk that Warner mentioned earlier. Repeatability, reproducibility, and reliability. And if you're familiar with Maslow's hierarchy of needs, you know, you have fundamental needs, then you have ones that are emotional needs, and finally, way up at the top, you have self-actualization, where you actually feel like a real human being and can enjoy life. Well, The 3 R's of DevOps are like that. You need repeatability, reproducibility, and once you have that, hopefully you can get to reliability. So we've talked about some practical-ish things. Now I'm going to shift gears and speak a little bit about philosophy of DevOps. After I drink, speaking is thirsty work. So DevOps isn't something you can learn from a book. If you recall at the very beginning of the talk, I mentioned that back 2012-ish, I was working on ops for devs and was writing a book. And I wish I'd gotten it out to market before DevOps came around. Yeah, it would have been my meal ticket. But DevOps really isn't something that you can learn from a book. Books can help. Books can give you ideas. But that said, unless you actually do something with it and experience it, then the book's not really going to help you. It might give you jargon. It might give you a few buzzwords to use here and there so that you too can sound like a DevOps expert. But really, at the end of the day, if you don't use it, you'll lose it. And DevOps isn't easy. We've talked about people changes. We've talked about some technology things that come as an aside. The biggest and hardest part of DevOps is making sure that you have the right culture and the right environment for your culture. And this takes time. This takes a lot of effort. This takes communication. And one of the things with communication is, part of the way that our head works is that the first thing that we hear sticks in our head. The very first messaging. So if the first thing you hear is that, DevOps doesn't work, we tried it on project XYZ, and it just failed. The project failed. So now, you have in your head the idea that, well, DevOps doesn't work. It failed. Do you know why it failed? Most likely it was a cultural thing. But they don't tell you that. Or, oh, we don't want to do this. It doesn't work. Or, somebody might hear that, yeah, we can do this with DevOps, but it's going to take us 6 months. They don't hear the next sentence, but then we can deploy every day. They hear the 6 months. Oh, so, we have this other thing where we can be done in a month, and you're telling me that DevOps, this thing that's supposed to help us, takes 6 months? Where's the value in that? What's the ROI? What's the return on investment? So that's the first thing that they hear. And then they don't hear the rest, that we can deploy every day, that we can deliver new value every day. DevOps isn't about extra work. Initially, there might be, indeed, extra work required. It's entirely possible. Well, probable. Well, guaranteed. But still, it's not about the extra work. And DevOps doesn't have gurus. As an aside, I am available for speaking engagements, so please feel free to contact me. Now, in general, if you hear someone claiming to be a DevOps guru, I wouldn't say run away screaming, but you might want to just look kind of okay. What qualifies you to be a guru? I've also seen job listings that say that, they want 12 years of DevOps experience. How many times have you seen, you need X number of years of experience, and it hasn't been around that long? Yeah. So yeah, there's no gurus. But again, I am available for speaking. So how can it be? In a world where we're doing DevOps right, How can it be? Well, first off, DevOps is learned by doing. The doing is the first thing that you do. If you've ever done any martial arts, the first thing that they have you do is practice. Practice a block. Practice a block. Or anybody ever see Karate Kid? Wax on, wax off. He's practicing. Does he know necessarily the end goal of his practice? No. That will come with time. That will come with practice. And DevOps does take a lot of work. It takes head work, it takes people work, it takes finger work, and so forth. DevOps, again, it's going to take time. It's a journey. It's an investment in and a change in how we do things, how we look at problems, how we measure things. As an aside, plug the, you don't know something if you haven't measured it. If you've got a measurement, then you know something. And there are things that you know. There are things that you don't know because you haven't measured it yet. And then there are things, to paraphrase Rumsfeld, that you don't know that you don't know. And those are the things that bite you in the butt. But again, this hard work and learning takes time. It takes effort. Most people who are studying martial arts, it's several years before they start seeing the underlying reason for things. Anybody hear of Tai Chi? Did you know that Tai Chi has weapons forms? Did you know that Tai Chi, once you get to a certain level working with it, that they can mop the floor with just about everybody else? So you've got these long flowing movements and so forth. Well, you just happen to be pushing somebody. You don't know it at first until you put in the hard work, the practice. Then you'll start seeing after that, how it all fits together. And it's about empowerment. If you recall a few moments ago, I related an instance where a project, would wait. And it's not just one project. I've seen it elsewhere. Would wait for months and months and months to get resources. If we can empower people to speed up and remove roadblocks, that will make our devs' lives easier, any operations people's lives easier, and so forth. And it will make our customers happier. The reason that we have jobs in IT is that people have problems. By empowering everybody along the stream of creating value, we then are able to solve people's problems faster. Now, if you're comfortable with where you are, I've done this for 15 years, 20 years, 30 years, and I'm going to retire in 2. Well, more power to you, but that's not going to get value to the customer quickly. So why am I interested in DevOps? At the end of the day, DevOps makes me happy. DevOps allows me to investigate things that are holistic. I can see the entire process. I can deliver value faster. I can get things out to my customer faster. I'm not having to do the same thing for the next 15 years. I can do other things now. Hopefully, as you explore DevOps, if you choose to explore DevOps, that is, DevOps might also make you happy. over the course of my career, I've worn a lot of different hats. And I worked at different sizes of organizations, from a little software shop that worked out of somebody's basement, all the way up to a TLA, three-letter acronym for a business machine company. And worn a lot of hats over the years. Originally, I was doing a lot of development. I've also worked in small colleges where, well, if you're part of the department, you have to do everything. And I discovered over time that I really want to understand better end to end what is happening, as opposed to being told, okay, write this function, take a number, multiply it by 5, and give me the response. That's boring. By working end to end and understanding end to end, that brings me joy, makes me happy. And it happens to be one of those things that, while there are a lot of different parts, you are more likely to understand what's going on in a DevOps-enabled organization than not, or in one that is not. So now we are at our journey's end for this envisioning that we've done together over the past, 35 minutes. But this journey's end is only the beginning of what is the true journey. In the DevOps and its pursuit, it's a type of craftsmanship. A craftsmanship is a practice and a process that takes a lifetime. It's not something that you can go out tomorrow just because you bought tools from Sears and claim to be a craftsman. And they don't even have the good warranty anymore. So yes, you cannot go out today, buy some tools, and claim to be a craftsman. But again, it's all about the journey. It's understanding people, understanding processes, understanding how we can make people's lives better. I'd like to close by saying that DevOps is not an impossible dream. It is obtainable. You do not have to go tilting at windmills in order to make DevOps work. I thought somebody would get the joke. Oh well. That's what I get for being obscure and literary. Yes, that's Don Quixote. Either that or it just wasn't funny. That happens too. So, what's a world with DevOps done right look like? It's a world sort of like the world we live in now, but, people's problems are solved faster. Developers and other IT professionals get to work on more interesting things, get to do more things, because it takes less time to do the first thing. It's a world where people communicate more. It's a world where we talk, where, we cooperate. And by working together, your developers, your testers, your QA, your sysadmins, your database people, your PMs, your product owners, and so forth. By working together, we all understand better the types of problems that each of the individuals might have. And you might have something that's an issue for you that somebody else has the answer to. But if you're in a, let's write our code and throw it over the wall type of world, you're not going to have that interaction. So at the end of the day, DevOps is about people. bringing people together, solving problems for people. Any questions?
Big hand for the most interesting man in the world. If you have a question, please raise your hand. I will also be trying to keep an eye on Slack in the main stage channel. If you're dialed in remotely, or watching us remotely, dialing in, what decade is it? Feel free to ask your questions in main stage on the Slack, and I'll try and pull those as well. I'll switch this up a little bit. In addition to questions, if you had any insights about DevOps that you acquired through Matt's fine presentation, please take the opportunity to share that as well. Do you have a question?
Ooh, I have a microphone now. I did want to ask more generally what sort of led you to the realization that IT is fundamentally about solving people's problems and not just programming for fun, unfortunately.
That's a really good question. I had been working at a place for a while, and my manager and I had gone back and forth for several years and basically said, you know, technology's easy, people's stuff is hard. And then one day it was like, but wait a minute, we're solving things for people. So all of this is a people problem. And it was just one of those serendipitous. So I recently did the Berkman personality profile. And one of the things that showed up on it was that it might take me a while to realize something or, you know, make a decision. But once I do, it's like, wow. So it took me several years to get there. And my back brain's churning on it and churning on it. And then one day it's like, ping. Oh, okay, I'm an idiot. But yes, it took time.
I know it may be a stupid question, but do you know what Agile is?
Yes.
Okay. Have a development group is Agile, but the DevOps group is Waterfall.
Oh, I'm sorry. That might be a resume generating event. That's one of those places where the culture needs seriously changing. I don't know, without a lot of investment at all levels of the organization, from top to bottom, that could easily be solved, unfortunately.
DevOps team is an anti-pattern.
Yes,
if your
it is.
organization created a DevOps team, they're doing it wrong.
Amen.
What ways, for people who are practitioners of DevOps, what ways have you found that are effective in educating peers and on how, like, when you create these repeatable and sustainable processes, like kind of letting them in on the goodness? How do you convey that and show them how to use it and how not to use it, or how it facilitates what they do?
So one of the things that I am very opinionated about is that the top skill that we need in IT as a professional is communication. That's the number one skill. Okay. I saw dark, and so I'm like, what's going on? But yes, that's the number one skill. That's the most important thing. You know, as an aside, I'll list the others. Being able to learn quickly by yourself, not just something that's being spoon-fed to you, but by yourself. And then finally, being able to solve problems. You know, there's also things about, you know, inclusiveness and so forth along the ways. But the top thing is communication. So learn how to communicate. Practice active listening. Understand people's problems. So if something's been going down and they're getting called every night, well, you don't know why it's going down unless you measure it. So have logs, have metrics. Once you start to develop those, then you might be able to repeat it or reproduce it and can move from there. I'm going to plug another talk, the 3 R's of DevOps. That's the one that Warner alluded to before. If you Google for it, you'll be able to find it. Once we get the slides out for Ohio Linux Fest, you'll be able to click on it. But this talks about different other things that you need in order to be able to achieve repeatability, in order to be able to achieve reproducibility, and so forth. Okay. So it's going to take time. And just like herding cats, you have to show them why there is value in doing this thing. You know, you change out the litter box, right? It's a much better location. It's a bigger litter box. It is a bloody hotel, 4-star hotel litter box. But unless they recognize that, hey, this is a good thing for me, they're not going to use it. But yeah, it takes time. Show them why. Well, not show. Let them discover why they might want to do these things. Because then it's their idea, and they own it.
Other questions, thoughts? Double check Slack one last time. No questions there. Big hand for Matt. Thanks so much.
Thank you all for having me. Thank you all for listening. And I hope that you've been open and are able to take ideas home with you. Thank you.
We will resume the program in this room at 3 p.m. Thank you all. Hello, OLF. I heard someone in the audience accidentally DevOps. That sounds like an interesting accident. I'm pleased to introduce our next speaker, Ben Cotton. Coincidentally, like back in the olden days, Ben and I were both on the top 10 of server fault, folks who answer questions on the internet. So we were both there in the top 10. So Ben Cotton is a principal program manager at Red Hat, focused on the Fedora project. In his role, he works with Red Hat and community contributors, including developers, designers, marketing, and many more roles. That's probably a not-so-accidental DevOps from the sound of it. To produce a community-driven Linux distribution, Fedora, Ben is also an author, not only on the top 10 of server fault, once upon a time, maybe still, and his book is Program Management for Open Source Projects. Coincidentally, you can buy the book here, and he's signing the book, so I encourage you to check it out. Ben's presentation is Your Bug Tracker and You. He's going to be talking about bug trackers. Please welcome Ben to the stage.
Thank you. All right, everyone, thanks for being here. It's great to be back at OLF again. I was here in 2019, and a few things have happened since then, apparently. I do want to go over a few regular housekeeping things before we get started. You know my name. I use he, him pronouns. The usual disclaimers apply here. I'm wearing a Fedora logo. Red Hat owns the laptop I'm presenting on. I'm not speaking on behalf of either of those. These are my opinions. In this talk, there is nothing that I disagree with myself on. That's not true in every talk I've given. The talk is under a Creative Commons Attribution Share Alike 4.0 license, so do with that what you will. I don't have the slides from this version available online yet, but I'd be happy to share them with you if you want to take it and chop it up. If you have kind things to say, I'd love for your feedback. There's my Twitter handle. I'm not on the Fediverse yet, largely because of inertia, but you know how that goes. If you have unkind things to say, you are, of course, welcome to keep those to yourself, because nobody is a bigger critic of me than I am. And we will have time for questions at the end. I'd love to have some engagement and talk to you about all the things that I said that were wrong. Do want to put in a shameless plug for my book real quick. I'll try not to talk about it anymore during the talk because I'm not here to sell you anything, but if you want to buy something, I'll let you. But there is a promo code for the ebook through the end of this month, I believe. I have like one physical copy left, and there's one going in the raffle. So if you don't get that or you'd rather have electronic form, save yourself some money. So what are we going to talk about today? I want to talk about why to have a bug tracker, what to track, picking a tracker, how to triage the bugs, how to close the bugs, and then how to analyze them. What we're not going to talk about is like actually fixing the bugs, because if we get to a point where I'm trying to fix a bug in the software, then something has gone horribly, horribly wrong. I know just enough Python to get myself in a lot of trouble. So why do you want to have a bug tracker? To track bugs. Like, that's kind of obvious, right? But it's more than just that. You don't want to just track bugs for the sake of it. I honestly think that bug trackers are the cornerstone of building an open source community. And just like you can't have a building with just a cornerstone, you can't build a community with just a bug tracker. But if you don't have a bug tracker, you are going to have a hard time building a community around your project. In Carl Fogel's book, Producing Open Source Software, he talks about how an active and full of bugs bug tracker is actually a really good sign because it means people are actually using your project. If nobody's using your project, you won't ever get any bug reports. So the point of having a bug tracker, and the reason that I think it's the cornerstone of building the community, is it allows you to communicate with users. It's probably not all of your communication, like you're not going to put out your release announcements in the bug tracker. That'd be kind of weird. But it's how your users tell you, hey, this thing doesn't work, or gosh, I really wish your software did this, or you're terrible, I hate you, and then you close those bugs. But it's also a way to coordinate with contributors. I've had a project where I'm the only developer on it, and I'm amazed that people actually use it sometimes. It's a Perl Twitter client that I inherited from somebody else when he got tired of it, so he did all the hard work. But it turns out if you have more than one person working on something, you probably want to coordinate, hey, which of us is fixing this? Which one of us is adding that? And the bug tracker is a really good way to do that asynchronously. Bug tracker maintains a historical record of what you've fixed and what you've not fixed in your project, which can be really important just to go back and learn from yourself. A project like Fedora has been around for 20 years. There's a lot of history, and there are very few people who were around 20 years ago who are still active contributors. I'm not fully sure that anyone is anymore, but I don't quote me on that. And so really it's building a source of information about the project. So what do you want to track? Well, you want to track the bugs, but like what sort of metadata do you want about them? Some of the things I think are kind of basic to track are the type. Is this a bug? Is it a request for enhancement? Is it a question that maybe is a better fit for a user support forum if you have one? Is it spam? You know, these are sorts of things that you might want to know just because it helps you kind of understand what's going on with your community. Obviously, you want to be able to track status or state, which like, is it open or closed? Like that's sort of the basic, but you might want to have intermediate states like assigned or, you know, on testing or things like that, just so you can kind of see at a glance where is it going without having to read through all 30 comments. You might even get really fancy and have a closure type. So was it fixed? Was it not fixed? Was it can't fixed? Was it invalid because we couldn't reproduce it? That sort of thing. And then tracking the impact. So this is how bad is it for your users? Does it catastrophically destroy all of their cat pictures? That's bad. Is it like a typo in the documentation? Could be bad, could be not. Is it a typo in the logo? That's embarrassing, but it doesn't actually cause any harm. And then you also want to track priority, which is a little bit different. It seems like they'd be one-to-one, but priority is basically like how important is this for us to work on, as opposed to impact, which is how important is it for the user to have it fixed. Ideally, those are in lockstep, but the reality is sometimes people will want to work on the things that are interesting to them, and if they're volunteer contributors, you kind of can't force them to do something else. Other things you might want to track when you're thinking about the bugs is version. Not all software is released with version. Sometimes it's clone this Git repo and you've got it, and cool. If it's not the top of the Git repo, it's not supported anymore. Most software that people actually use has some sort of versioning. And so you might want to know if a bug is reported against version 3 or version 4, because it turns out those are very different in how they work, and so knowing how to fix it is important. If you're a larger project, like say a Linux distribution, you might have multiple components where you want to know, hey, is this this piece over here or this entirely unrelated piece over here? Being able to split that out makes it a lot easier for people to search for the bugs they actually care about. And the platform matters. Does it run on Linux? Does it run on OS 10? Does it run on Windows 3? What architectures are you running on? Those sorts of things make it easier to sort your bugs sometimes. And also, you want to track timestamps. Those will come in handy as you calculate certain things like how quickly are we closing bugs. You want to track, this is kind of obvious, who reported it, so that way you can reply to them and say, hey, I need more information, or hey, we think this is fixed, can you please test it? You want to track the assignee, because remember one of the things I said was you're using a bug tracker to coordinate among your contributors, and knowing who's assigned to the bug at the moment is kind of an important thing. And there's a lot more, like Red Hat Bugzilla has approximately 11 billion fields that you can fill in. Most other Bugzilla implementations are similarly complicated. There are things specific to your project that you almost certainly want to track. I'm not going to sit here and tell you what all the possible ones are. But you think about what's important to your community and what you want to understand about the bugs as a set. So it's really important, if at all possible for you, to track these as separate fields and not bug content. Because if you're trying to parse out the text in the bug content, you are just going to be sad all of the time. Think about how much fun it is to like handwrite JSON or YAML, and then think how well your users are going to do that when they're upset and trying to report a bug against your project. And if you're lucky, the tracker provides this already. Some trackers allow more flexibility than other than creating custom fields. And depending on how many custom fields you want to use, that might feed into picking a tracker. So I have opinions on different bug trackers. I've used several. I'm not here to tell you that one is good or bad. They're all terrible in their own way. But you want to pick the one that's right for your community. So some of the things you want to think about are authentication and accounts. If your project is large, you might have your own account system that you want the bug tracker to be able to authenticate against. If not, you might want to authenticate against GitHub or GitLab or some external identity provider to make it easier. You might want to be able to do both. Think about, does your tracker have API libraries? Because as you develop tooling around your bugs, you're probably going to want to interact with your bug tracker in some programmatic fashion. And so having API libraries where you can just very simply do that makes your life a lot easier. Think about the FOSS status. Is it important to your community that the tooling you use is free software? For some communities, it is absolutely essential. For some, if there's a choice between hard-to-use FOSS software and a easy-to-use proprietary system, they'll go with the proprietary system. That's a value judgment for your community to make, but you need to pick a tracker that aligns with it if you want people to use it. And then similarly, hosting. You might have an open source project that you can pay the developer to host for you, and that might be okay for your community, or your community might insist that you host everything yourself on your own infrastructure. Again, if you want to be able to do that, that's an important factor. You're thinking about, can you hide comments or attachments, maybe because they're spam, or because people are submitting logs that might have sensitive information, and you don't want them to have to divulge the entirety of their configuration to the world just to get a bug fixed. Can you moderate accounts? That's a consideration for any tool where people can write things on the internet, because if it's on the internet and people can write to it, it will get spam. Can you customize fields? Can you set metadata ACLs? So you might have certain things where I want anybody to be able to change the version because somebody might come along and say, oh, yep, it's still on this active version. You might want anyone to be able to reopen it. You might not want anybody to be able to set the target milestone field where we think we're going to fix this in this version. You might want to restrict that to only your contributors who actually can authoritatively say that, yes, we're going to try and fix this in a particular version. Can the tracker link to version control or to other bugs? And this isn't just like, can you paste a URL in the comments field? Because of course you can. But like, will it actively be able to check the status from a GitLab repo and include that in the summary? Or if you type in a bug number, will it automatically link to that bug? Just little minor convenience things. But if you spend a lot of time in a bug tracker, those sorts of things add up. One thing to think about when you're picking is, can you do bulk updates? Because you probably will at some point, whether it's because you need to branch a whole bunch of bugs, or you need to close a whole bunch of bugs, or you decided to add a new field, so you just need to go back and, all right, I've got these 100 bugs that all need this label applied. Cool. If you have to do that one by one, that's going to be painful. Does the tracker support things like milestones or epics? And these are, again, we're going to fix this in version 2. We'll fix it in version 3. Again, it might not be important to you, but it's something to consider. does your tracker have built-in reporting? For Fedora Linux, and there'll be a link to the talk about it at the end, every release I go through and do a huge analysis of our bugs. Well, there's thousands of bugs per release and many releases, and frankly, Bugzilla is not going to provide that. I'm going to dump it all into a Jupyter notebook with pandas to make all the pretty graphs. But if there's some basic reporting that your tracker provides, that's great. And then private bugs and comments, it kind of goes back to the hiding one. Like, can people give you embargoed information? Like, hey, I found this very important security vulnerability. Let's not share it with everyone just yet. Last set of bullet points on this one, it's cool. You want to think about assignees. Can you assign a default assignee to a bug? Maybe you want that, maybe you don't. If you don't have a default assignee, a lot of times people think, all right, well, cool, that means somebody knows that they can claim it. In my experience, what often happens is nobody steps up and claim it, so it just sits there and never gets looked at. Can you have multiple assignees? You might want that because most of the time you're fixing a bug and one person fixes it, another person's testing it, or several people are working together. So you might want to be able to have several people be on it. Or at least mention them and let them subscribe to the bug and watch it. And then the last thing I added earlier today, as I was thinking about it, like, can you lock bugs? There's this one particular bug in Red Hat Bugzilla that had the word crypto in it because it had to do with cryptographic libraries. Well, this bug is 10 years old maybe, and every few days I get a notification that somebody has posted some sort of spam comment, sometimes related to cryptocurrency, sometimes not. Unfortunately, you can't actually lock the bug from ever being updated again in Bugzilla. So if that's important to you, you might think about looking for that in a tracker. And then one thing to keep in mind is that whatever you pick, you'll use it as more than a bug tracker. The Fedora Council uses a bug tracker for voting on trademark requests and other sorts of leadership issues. I talked about picking the type. Like, you're not just tracking bugs, you're tracking requests. A lot of times it ends up being a support mechanism. So keep that in mind as you're picking one. All right, so let's talk about actually using the damn thing already. One of the important things that you'll want to do is to triage your bugs. This is less important when you only have a few, but you're getting a bunch in. You kind of need to sort them out into buckets. So the first thing you're doing as you sort, and this can be a great task to kind of get new contributors active and engaged, is just asking some basic questions. You don't need to understand it well, but you're trying to figure out basically the validity of the bug. So is it a bug? Or is it like a request for enhancement? Is it something else? Let's sort it that way. Is it a duplicate? This is a little harder because if you have a lot of bugs, nobody can keep all that state mentally. So you might have to go search through the bug tracker and try and find things like it. But if it is a duplicate, you want to know that so that way you're not duplicating effort. Is it a security bug? If it's something related to a vulnerability, you might want to flag that for certain review, or it might increase the priority, things like that. Is it filed in the right place? So if you have multiple components, is it filed against the front end when it's actually a back-end bug? Is it filed against your application when it's actually in the upstream library you're using? That sort of thing. That one's a little harder for new contributors to always understand, but sometimes it can be pretty obvious if you have a little bit of experience with the code. Is it reproducible? So recently, my washing machine flooded the house. That sucked. What sucked more was the fact that the next time I did a load of laundry, it didn't. And the next time it didn't. And so we ended up replacing it anyway, because if you can't reproduce the problem, you can't know that it's fixed. And then finally, does it say what happened? A lot of times people will file a bug report like, such and such is broken. All right, well, what am I supposed to do with that, right? Ideally, you think philosophically, what's a bug? It's a difference between what the user expected and what actually happened. So if they can tell you what they expected and what actually happened, you can then understand, and it might give you the answers to some of those other questions. So the next thing that you're going through in your triaging is now you're going to start prioritizing. And there's a lot of different ways to do it. A lot of times people try and attach a particular, like a score to something, and well, this is a priority 7.2 bug, and this is only a 7.1, so we'll work on that first. But the reality is that's not how people operate. Like, nobody's going to come and automatically grab the highest priority bug from the stack and work on it, because they might not even know how to. So really, realistically, you just want to place your priorities into buckets, like low, medium, high. Those are good buckets. So the way I like to think about it is to take this list of questions, and the sooner you hit a yes, the sooner you dump it into a bucket. So these first 4 questions, those are the high priority bucket. The next 4 questions, medium priority bucket. If we get to the bottom of the page and it's not in the bucket, then it's in the low priority bucket. So I do want to talk about each of these individually for a moment. The first question is, can physical harm result? And you're like, it's software, of course it can't. But sometimes software is controlling hardware, and hardware can cause problems like overdrawing current and catching fire. That's bad. Maybe you have a robot and it smacks somebody upside the head. But also, like, the way we use software impacts what we consider the real world. And people can be harmed if you are disclosing important information. If you're taking abuse reports and that information gets out, that can really put a person who reported it in danger. The next question is, does it cause data loss or corruption? Losing data is like the meanest thing you can do to your users. And you can be like, well, they should have backed it up, but that's not kind. That's not how we work. And if you lose, grandma's birthday video or baby's first steps, your users are not going to come back. And that's why file systems take so long to develop and release, because they really, really want to get it right. Does it permit unauthorized access? So if I type in the magic command in the box, do I all of a sudden get root on the account? Can I use it to create a spam network? Things like that. And then, does it reduce accessibility? This one might be a little controversial. I hate to use that word, but it's not something we think about in open source software very often. And I will be the first to admit I often don't actively consider accessibility. But because we are so bad about it in general, anything that makes it worse is a high priority issue if we want to get free software truly available to everyone. All right, so those are the high priority issues. Medium priority is the default configuration affected? Because if you have to set like 30 different special flags in order for the bug to appear, most people aren't going to be impacted by it. Now, it could still be a serious problem for those who are, but most people aren't going to touch the defaults or going to make very minimal changes. And this also then applies to things like, does it only affect, a certain hardware architecture? If it does, then maybe it's the most important architecture for your project, or maybe it's not. And if it's not, it's lower priority. Is there a reasonable workaround? And I generally don't play with font too much, but I put reasonable in italics because, like, recompile while standing on one foot and holding your ear with one finger in the air and singing the battle hymn of the Republic is not a reasonable workaround. And reasonable is going to, that's going to vary based on the technical savvy of your users. If you're making a general purpose desktop application like a web browser or something, you have to assume that most of your users aren't technically savvy. If you're writing something that is only going to be used by the most hardcore of developers, then maybe there's a higher barrier for what's reasonable. So I already mentioned, does the bug affect all platforms? And so, again, like if it's only affects, Windows 3.1, you probably don't care that much. If you're writing software designed for IoT and it doesn't work on, ARM, then you probably want to fix that because that's actually super important to the IoT space. And then the last question is, does it embarrass you? And some people are like, well, all my bugs embarrass me because I only want to write perfect software. But what I'm talking about here is just sort of the stuff that'll just get you made fun of a lot. So if you just like completely misspell your project's name in the software, that actually doesn't cause any harm, but it just makes you look really bad. These are the sort of things that if Ars Technica or somebody is writing about your new release, they're like, well, everything is great, except these guys are kind of dumb. So like that's what I'm talking about there. You do want to fix that stuff just because you want to look like you're competent and you want to give a good first impression to users. Cool, so we've triaged the bugs, all of them have been fixed, everything's great, cool, now it's time to close bugs. You should totally close bugs. This is actually a little bit of a controversial statement. I have had debates with people before. Obviously you close bugs when you fix them, but what about when you don't? So the reason I think you should close bugs is that it sends a very clear signal of your intent. Like, yes, we acknowledge this bug exists, no, it's not getting fixed. And that could be because we don't care, or it could be because we can't get to it, whatever the reason is. And it also makes your bug tracker easier to scan through. If you have a whole bunch of open bugs from 10 years ago that you're never going to fix, they're just kind of there clogging it up, and it's hard to kind of, what I call eyeball grep as you scan through the list. On the other hand, closing bugs makes people angry. And I know this because every 6 months, I close 3,000 to 4,000 Fedora Linux bugs, and invariably on social media and in my email and in the bugs, I'm like, Fedora never fixes anything. You guys suck. I'm never using this again, blah, blah, blah. Yeah, and I understand the anger. And sometimes it's like, I don't want to deal with that. Let's just not close the bugs. There's also people like, well, I was going to work on that, someday. Sure, it's been open for 10 years, but this year's the year. And then, there is the argument that it represents a catalog of known issues. Known being known and also submitted to the bug tracker, because a lot of times bugs are known in the collective, we understand this exists sense, but they're not documented anywhere. And for that one in particular, my personal preference is to, in your release notes or somewhere, just include a list of the major known issues, because people are going to want to know about that anyway. And they're not going to go look at the bug tracker before they install or upgrade anyway. So you're not really doing a lot of good there. So when do you close the bug? Obviously, when it's fixed. Cool. But if it's duplicate or invalid or spam, you can close it, and you can close it right away because it doesn't do anyone any good to leave it open. If the version reaches end of life, again, assuming that your software has versions and you have a life cycle of some kind, when it reaches that point, close it. If at some point you figure out that you can't fix it, or that you won't fix it, that's a good time to close it. And those four you can basically do as soon as you've decided that it meets any of those criteria. On the other hand, if it's missing information or if you can't reproduce it, that's good. It's good to close those bugs too, but you want to give people a little bit of time. So how do you close the bug? The most important thing to do is to set and communicate the policy ahead of time. You can't decide, well, I'm just tired of seeing these bugs, I'm going to go through and close them all. People really like to know what's going to happen. They like that certainty. They like to have been warned. So setting that up ahead of time then kind of saves you from the accusation of, well, you're just closing it because you're mean. Like, no, I'm closing it because we agreed this is how it's going to work. So you want to explain why the bug is closed, and you want to give instructions for how to reopen it if it should be reopened. So, for example, if it's because it reached end of life, say reopen it and set the version to a supported version. or if it's closed because you can't reproduce it, say if you come up with a reproducer, reopen it, we'll work on it. And this is the hardest one for me personally, ignore the complaints. Like, it's not personal, and it's almost never actually your fault if you're the one doing all the bug closures, unless you're managing all of this in a single person project. But people are going to be mad on the internet. Sorry. So the process is going to vary by type. So like I said, some of them you close right away. Some of them you wait, give people time. One of the things I like to talk about is, open source projects, even if they're entirely volunteer done, they have costs, and those costs are people's time. That's the most precious thing they can give to your project. Well, even though it doesn't feel like it sometimes, your users are also contributing their time by reporting those bugs. And even if they're being very rude in their bugs, they're still making a contribution of some way. So in the same way that you wouldn't want them to come back after a day, like, why isn't this fixed yet? Give them time and understand they're volunteering to provide the information you need. So if you ask for more information and they haven't provided it in 24 hours, give them like a couple of weeks. Kind of give them the same grace period that you would want to have being on the fix the bug side. And like I said, tell people how to reopen it, because then it's a little more cooperative. It's like, hey, we had to close this because this. Here's what we need from you to reopen it. Like, it's not closing the door forever. So your bugs are closed, cool. Now it's time to analyze them. And you might say, well, why do we analyze them? We're just going to go fix bugs. It's cool. So you can learn about your user community. And one of the things that's kind of neat about your bug tracker is that surveys are really hard to do well, especially in open source software, where typically people do not want you to have things like, I don't know, built-in telemetry that automatically phones all the details home. Open source projects generally have no clue how many people are actually running the software. And so you can't get a representative sample by just emailing everyone saying, please fill out this survey. But your bug tracker, if you're getting enough engagement on it, can be a reasonable approximation. So you can learn how many people are using the software on Windows versus Linux, or on x86 64 versus ARM, just sort of by the number of bug reports. You can kind of figure out how quickly are people adopting the new versions. If we put a new version out and we don't see any bug reports for it for 3 months, it means the users are going to be generally pretty conservative about when they upgrade. If you put out a new version and you have a whole bunch of bug reports all at once, all right, people are excited about the new releases. You can learn things about your project as well. So you can track things like bugs over time. You can track the time to resolution. Are we getting faster at closing bugs, or are we getting slower? You can learn about the bug severity. And this is kind of a cool thing to do if you've got like 5 years worth of data, and then you start putting some CI into your workflow, and then you've got like a couple more years of data, and you can kind of see like an inflection point maybe, where, oh, the bug severity went way down because we're catching a bunch of stuff because we're doing testing now. Isn't that cool? But there are also things that you can't learn. So you can't learn things like time to response, like how quickly are you just replying, acknowledging, saying, yes, we see your bug. And that's kind of a lie, because you can do that. But it's really hard to do programmatically, because is the first comment on the bug from somebody in your community saying, yep, we see it, thank you for the report, we'll take a look at it? Or is it somebody else saying, yeah, I see this too? And so, like, how do you do that in a programmatic way? I had a job where I was leading a support engineering team, and we would actually just like manually do it, because we had a small enough amount of tickets that we could do the math, and then we could report to the customer, yes, we're meeting your SLA. But to try and do that on an automated basis is really hard. You also can't figure out who's the best or the worst at fixing bugs. And you might be like, well, we have the assignee, we can know. But sometimes the person who actually fixed the bug isn't the assignee, especially if you have default assignees on your bug tracker. Because maybe somebody else came in and fixed it and they just didn't click the take bug button. And that's fine. So just realize you can't try and reward people solely based on that. And honestly, I don't know that you want to highlight your worst bug fixers anyway, because one, that's not going to make them want to participate in your community anymore. And two, maybe they're super active somewhere else. Maybe they're writing like all of your documentation. Maybe they're doing all of your testing, and so they're just not fixing that many bugs. They're still doing really important work. You also can't learn affiliations. And I was having this conversation with somebody yesterday about like, well, how many people at Red Hat are working in Fedora? Or like what percentage of Fedora contributors are Red Hat employees? And the honest answer is, I don't know. I tried at one point when CentOS Stream was getting started to provide some information to management based on the email address in the Bugzilla. But the problem is, not everyone at Red Hat who works in Fedora uses their @redhat.com email address in Bugzilla. So it's really just impossible to tell affiliations with any reliable sense of certainty. So if you're trying to figure out like what company is contributing to my project the most, you need to find a better way than looking at your bug tracker. Because turns out sometimes people work for companies and also do other things. And just because they work at the company, it doesn't mean they're doing it as part of their day job. Another really fun thing is challenging your own assumptions. And I'll admit that I was super cynical about bug reports. The first time I did the analysis of Fedora Linux bugs, I was like, everyone always marks their bugs as urgent severity. Like, of course it is, because why, if you're going to take the time to report the bug, you're going to say it's urgent, because maybe that'll get it fixed faster. So then I looked, and it turns out most people don't even set the field. And of those who do, it's actually a pretty reasonable distribution. Urgent is the smallest slice of the pie. High is next, it's bigger. And then medium is actually the largest. And my suspicion here is because if it's low severity, people are just not bothering to report it. So this actually matches pretty well with what you would objectively expect. And so I kind of felt bad. I'm like, oh, I need to give our users a little more credit. All right, so when you're thinking about how to analyze the bugs, you want to look for trends that will cause a change in behavior. If you're not going to do something about it, then it's just kind of interesting, but maybe not the best use of your time. So you want to look for things like, can I do something to affect this? Like, can we, like I was talking about with the CI, can we reduce bug severity, or can we reduce the number of pre-release bug reports by changing our development process, changing our testing process, things like that. In most cases, you want to ignore the duplicates, because unless the question is how many duplicate bug reports are we getting, it doesn't really add anything. It just sort of inflates the most popular segments. And you basically always want to ignore spam unless you really are just like, I'm curious how many spam reports we're getting. Is that changing over time? But again, like, what are you going to do about that? And typically, I like to look at percentages versus raw numbers, just because, like, if you go from one high severity bug to 2, that's a big percentage. But if you're looking at like how many bugs of the 100 bugs from the previous release and the 100 bugs we got in this release, okay, well, the percentage isn't changing that much in the total number of bugs. Sometimes the raw numbers are better, but usually it's percentages of the total bug reports is what you're actually looking at. All right, so like I said, I've done a talk at Nest with Fedora the last couple of years, just exploring Fedora Linux bugs. I go through, there's a lot of pretty charts and graphs. I still kind of forgot to get around to writing the blog posts about it with the summaries, but that QR code and the YouTube URL is to that video. I would love to sit here and redo it for you, but we're running short on time. So with that, I have reached the end, and I am open to your questions, comments, or heckles.
server bounce because I got plenty of stuff signed off, bounce the server. But if I have the accessibility to go to the logs in the database, I'll pull the data from there too to give them as much information as possible. But I have also got friendlier with the devs, so I'll show them it on my machine, and if possible, show it on the dev environment, because in the dev environment they have a lot more tools to track it down. Plus, if you're somewhat friendly to them, if they start writing code that they're not sure is going to work well, they'll ask you to try it and see if it works. And if it works, great, they'll add more code. If not, they'll fix what you found.
It turns out that the biggest thing you can do is being nice to the people you're working with, and then they will help you out, and you'll help them out, and we'll all do a better job. Open source is inherently social, it turns out. But yeah, I think your point of providing as much information in the bugs as you can, or like here's the bug, and then here's also a bunch of supporting information, is really helpful to people. Right. Any other questions? All the way in the back.
So you mentioned that any form that you can fill out online will be filled out with some spam.
Mm-hmm.
Also, every time GNOME crashes, I get an error reporting system that comes up and says, hey, do you want to go ahead and send this off? If all of us in this room just did that one time today, it would create unknown traffic on their bug tracker system, right?
Right.
So knowing that, how does that system play into the overall systems of bug tracking that you're talking about here? Is that helpful whenever dozens of us are just willy-nilly reporting bugs with no information, whenever it's just a crash? Or is there systems in place that people should look to move to for situations like that are just like a quick one-off?
Right. It's sort of the balance of, like, do you want to make it super easy to report bugs, or do you want people to put the effort into reporting good bugs? And so automated tools like that can be really helpful because they can collect a lot of information in the background and provide it. I know the ABRT service that Fedora uses does some amount of like deduplication, so it can recognize, hey, this looks like the same report. So it's just recording multiple instances of it instead of opening 10,000 bugs. So I think if you can do something like that, that's really helpful. Automatic bug reporting, I go back and forth on it, just because if the user didn't notice, does it matter? And in some sense, yes, but I think a lot of times there are more important things you could be working on that people are actually noticing if it's not actually causing any harm or any like degradation of the user experience.
So more so it's analytical than actual bug tracking?
I think so in a lot of ways. Okay. And the most important thing is, if you're going to collect that data, use it. Like, don't just let it fill up a server and never do anything about it. Like, if you've got it, whether it's just doing some simple analysis of like, hey, where are we getting the most crashes from, or you're actually using it to like dig in and fix the code. But what's the point of collecting the information and never using it, right?
Thank you.
I thought I saw another hand over this way. Yeah, go ahead.
Yeah, my question more relates to, at the very beginning of your presentation, you talked about some of the importance. You mentioned cornerstone of bug trackers for your open source project. Beyond just the first order effects of reporting bugs, there were all these second order effects, like engagement with the community, understanding how your community is using it, et cetera, et cetera. In light of that, do you see any innovation happening with bug tracking software, like currently today, that maybe take some of that into account, or adjust for some of that, or incorporate some of those the ways that you're maybe using bug trackers outside of their scope. You mentioned some of the leadership council uses it not as a bug tracker. Yeah, just curious to see, is there innovation in this space happening, whether it's proprietary or open source?
That's a really good question. I don't know that I have a good answer for you right now. I think tools have become a lot easier to use, which is a very important innovation. I think, people kind of, talk about Jira and, they hate it, but one of the interesting things is like, as tools do everything, then it becomes really easy to connect with each other in the different parts of it. I would not necessarily want Fedora to switch to Jira, but I do think there is a lot of value in sort of being able to connect the different pieces, all, collect that information all together. So for example, right now in Fedora, we have Bugzilla, we have Koji, which is our build system, we have Bodhi, which is the updates system, and all three of these things are talking to each other a lot, but they're not really connected, if that distinction makes sense. I think the ability to do that, and especially for things like feature requests, like an upvote system, can be really helpful. You're sort of almost kind of merging it, so it's sort of a forum and sort of a bug tracker. Obviously, that can get out of hand really quickly, but I think that's an interesting space. If we can do it well, that really gives us the opportunity to use it as more of a, more than just a bug tracker kind of tool.
Thank you.
Other questions from the audience? Checking Slack. It doesn't look like we have questions on Slack. Going, gone. Big hand for Ben Cotton.
Thank you, everyone.
We will resume the program on the hour, so looking forward to seeing you back then. It helps if I turn on the microphone. Hello, OLF. Almost through the long stretch. A beer is starting to call me. I'm looking forward to our next presentation. Esther has various certifications and an above average amount of experience with old technology, which relates to the conversation we were just having right now. And also an unhealthy obsession with old technology. I might have some stuff I can give to you in my house, old tech. In fact, open invitation to anyone in the room. I have lots of old things I'd love to give away. By day, she's an ecology student, and by night, she turns into an abnormally tired sysadmin from her small fleet of servers. Her spouse tells her, I have a beige box hoarding problem. So today's going to be fun. It's going to be a history of technology, starting with punch cards, which is great, and going all the way to modern smartphones, which you don't have with you today, I noticed. Big hand to Esther. I'm looking forward to this presentation.
Thank you. Thank you. I was not expecting an introduction. Yeah, so this here is punched cards, portable computers, and Linux ISOs. This will be a very quick tour of how we, as humans, mostly, have interacted with computers over the past 70-ish years, in hopefully fewer than that minutes. Yeah, he just introduced who I am, but I am up on stage, so I know what I'm talking about. Take it on faith. This talk is known to cause cancer in the state of California. So let's just start with defining human-computer interaction. This may be something a little bit basic, something we all learned about in like Computing 101. These days, it mostly means using a keyboard and a mouse or a touch screen, and you have some kind of graphical interface. More interesting input and output devices exist, like Braille displays or the old deck talks that gave Stephen Hawking his voice, but unfortunately, this talk is just going to focus on HCI through the lens of sort of able-bodied humanoids. Very boring for the time systems, but talk to me later. So, the timeline. Back in the Dark Ages, we had punched cards, and many things came after that. I have grouped things very loosely by decade here. I'll go into way more detail about each of those fun bullet points. But sort of to summarize, in the beginning, a individual person could not afford to buy their own computer. Or if you could, you probably had better things to spend that much money on. And then computers got cheap enough that we could all have them, first just in our basement and then eventually in our pockets. And then, you know, computers begat more of themselves, and now we just use our computers to talk to other people's computers living in a cloud somewhere in California. Something else to notice here is there is a progression from batch processing to more interactive user experience. I'll get more into that. If any of the machines in this talk look familiar to you, feel free to share a war story afterwards. So, I promised punch cards. There are young people in the audience here. Do you know how to program these? Yeah. Yeah, you get your hole punch and you punch holes in it, and let's see then. You give it to someone babysitting the machine down in a machine room, probably locked, and you don't have the key for it. And if you are very, very lucky and it's not too late in the day and maybe you've bribed the babysitter with alcohol, you're going to get the output of your program the next business day, which might be a syntax error if you're unlucky. Yeah, these were invented by the Hollerith Tabulating Machines Company, who is now IBM, and they were a major source of recurring revenue because for every part of your program's development cycle, you have to have so many of these, and I really hope you don't drop them on the way to the machine room. Yeah, this was very much not your computer. This is by no means a personal computer. And also, only one person could have their program running at once. We get, eventually, from punch cards to the teletype, sometimes pronounced as titty. These were an order of magnitude cheaper than the computer they're hooked up to. You could have multiple of these for the computer, which gave birth to multi-user, multi-processing in the sense that you had like time sharing. Some early systems had multiple CPUs. These were electromechanical devices. These were very much akin to a typewriter with a printer glued to it, and when you hit keys on the typewriter, it would send an electrical signal over to the very expensive computer it's hooked up to. But a major improvement over punch cards is that these really were interactive. You could hit a key and get a response, and it was great. These typically ran out about 110 baud. That's bits per second. That's very slow. Transmitting this entire presentation in binary form from one teletype to another at 110 baud would take about 10 days. So that is a teletype ASR model 33 hooked up to a PDP-7. The PDP-7 you see is very large and very expensive. It was $72,000 back when it was introduced. This is a PDP-8. This is sort of recognized as the first mini computer. It would run you only $18,000. There is a very lovely fellow in the front row who has programmed on one of these. You would typically have at least one teletype. You know, if you were lucky, you would be the only person using the machine hooked up to this. But you could also technically program it just directly from the front switches if you didn't feel like having fun that day. These are, I'm going to call them glass terminals to differentiate them from the old-fashioned paper terminals. These pretty much just replaced the printer mechanism with a CRT. They were far cheaper, quieter, easier to maintain. You could run them faster. They were more reliable because you didn't have moving parts because it's not electromechanical. And these were great, particularly because you wouldn't go deaf from the sound of the printers. And these were also incredibly popular. That machine in the upper, from Yerzal perspective left, is a DEC VT520, which was still in service as late as 2019, according to the internet where I got that picture off of. These were small enough you could theoretically take them with you. Like, they didn't have batteries integrated, but you would have a lot more luck sneaking this onto a plane than an ASR 33. Down there in the lower right is not technically a terminal. That is a TV typewriter. It was a hobbyist design that was published in Byte magazine. You type text and it gets shown on your television, and it's incredible. But you could very easily modify it to be a glass terminal, and it was great. So I've been talking about terminals mostly. These are computers. These are personal computers, very much the first of their kind. You still needed a terminal to hook up to these, but you could actually buy this for a reasonable sum of money. So these are a bit of an anomaly, perhaps by our more modern eyes, in that they don't have the user input-output hardware integrated. You still have to hook up to them over a serial connection. That, by the way, is a Kenback 1 and an Altair 8800. And then some very smart people had the great idea that buying a terminal was not the most fun thing to do, so what if you integrated it? So we get sort of the microcomputer, personal computer, where you have the user input-output hardware integrated into the rest of the computer. Something else very special about these is that you could fit these on your desk. They were big. That Altair came in a 19-inch case. These were very much meant to live on your desk. They used a microprocessor. There was a time when CPUs were not just in one chip. And these were also only going to be running one person's programs at one time. These were single user, single tasking systems. They didn't have any of the, well, they didn't have few of the features that the more expensive mid-range and mainframe machines would have had. This is also sort of the beginning of the end for the big iron, because now instead of having the computing power locked somewhere in your corporation's basement, you can stick it on everybody's desk for relatively cheap. Let's see then. These were first called home computers. That is an IBM PC. That is from 1981. It is far from the first, personal computer, then called a home computer. These are home computers. These were called the 1977 Trinity. That is a Commodore PET, an Apple II, and a Tandy Radio Shack TRS-80 Model 1. Yeah, you programmed on one? Yeah. This wedge form factor came first before the desktop form factor with the detached keyboard. This is also technically a home computer, and that's a computer at home. That is Mary Ann Wilkes working on the Link computer circa 1965. That would not have been very popular, though. Then, before now, we have been talking about the command line, text, but that was allegedly not very user-friendly. Yeah. When we added the M to KVM, the mouse to keyboard, video, and mouse, things got more user-friendly, and something very special happened. The computer was encouraged to do more than one thing at once. You could have more than one window on the screen at one time. So this sort of developed in tandem with multitasking hardware, trickling its way down to microcomputer personal systems. But you could not have like a GUI that did preemptive multitasking on an 8086. There were a lot of graphical metaphors used in the early days. The Amiga displayed on screen had something called the pin board, which the idea was you like pinned windows to a board. The Macintosh hasn't changed so much yeah, I mean, it's gotten better. You can do more than one thing. Early versions of Mac OS only supported running one app at a time. Then while I'm naming the computers, that down there is a B-Box. Does anybody here have a B-Box or seen one? Wow. Oh, on a Pentium. Okay. Yeah. Fair enough. This is also sort of around the time that the access to the internet became a lot more mainstream. This is when people started dialing up from home. You could dial up from like your Apple II, but you wouldn't be connecting to the internet. You would probably be connecting to a BBS. So we get this Cambrian explosion almost of internet access services like CompuServe, AOL. Anybody here use NetZero? Yeah, yeah. Yeah, so we get more and more connectedness between people sitting behind their computers typing and now using the mouse. This is sort of, there is this false notion that like the graphical user interface was birthed, fully formed in 1984 by the Macintosh. Before then, the GUI was conceived of in the mid-60s by this man called Douglas Engelbart. You may have heard of him, and then commercialized in 1973 by Xerox PARC. So by the time we all got Windows 95, it had fully 20 years of R&D behind it. But for us mere consumers who were not in academia at the time, it did more or less arrive fully formed. These were still tied to your desk by a mess of cables and not particularly portable. These were. These are, well, they're laptop computers mostly. These are portable computers. So you could take the internet out of your basement and take it wherever you wanted to go, which also meant your boss could now email you all around the clock. These, I would argue, are even more personal than a PC, because while this only one person can use at a time, you know, it is still ostensibly owned by the family. It can still be a family machine. If you're taking it out on the go, it's a lot harder for, like, if you're someone's sibling, it's a lot harder for your mom and dad to get you to give up the computer if you have it out on a bus or in school with you. These arrived in tandem with wireless networking. I don't want to say they necessitated wireless networking, because that down there in the lower left is a TRS-80 Model 100, which did not have wireless networking, and they sold pretty well, so allegedly people liked it. But that is when this pervasive wireless networking technology came to be. You could now hop on the internet from anywhere pretty much anytime. This also led to, because you could access the web anywhere, anytime, you get a lot more of tools living in your browser. Like these days we have those YouTube to MP3 converters. This is where those were born. When you no longer had to download an app or download the source code to an app and /configure, make install. You can now just get it anytime, anywhere. They got smaller. I say compute crossed out on the go, but I guess what I really mean is consume on the go, because smartphones are very consumption-oriented devices, particularly back before they had touchscreens and you had a little keyboard that was a little bit hard to type on. This is not meant for like typing your PhD thesis. This eventually became meant for looking at cat pictures on the internet. And as long as it has a battery installed with a charge, it is turned on. This is a crowd that is probably in the know that your modem is always online. The cell modem in your phone is always online and runs its own little embedded operating system. And somehow we are fine with this collectively. Also, this is when software started to become more app-oriented. You had apps back on the laptops and desktop, but this is when they became more something to be engaged with, something where engagement is the priority. You want people to keep using your app rather than a tool, a means to an end. In the case of social media, this manifests as the app trying to become addictive, whether they claim it or not. I'm going to ask the crowd a question. Does anybody currently not have a smartphone or cell phone on their person? If you what?
Does it count if we don't pay a plan? If we just island hop from Wi-Fi to Wi-Fi?
I'm still going to say yes, because the point I'm trying to make is that now we all have computers in our pockets, and it is even more pervasive. It is hard to get away from the internet and from other people, particularly when someone realized that you could do these things called notifications, where instead of the user having to open your app to see what other people posted or whatever, or what your boss emailed you, they can now just make your phone buzz and you'll know it immediately. Originally, I had a clip from a 1976 movie called Network in here after this slide, which was about the role of the television in how humans perceive reality. The point of that movie, it's a good movie, is basically that the television was, and this is a quote, the greatest goddamn propaganda machine in the whole great godless world. Televisions of the time lived only in your living room. The smartphone lives in your pocket. I got through this way too quickly. So where are we now? I've sort of gone over the past few decades, and there were major milestones in user experience that we now, with hindsight, were able to pick out. I think only with more hindsight will we be able to pick out what this decade-ish time's defining UX change is. But here are some suggestions. It could be everything as a service. It could be, other people trying to rent you things that you used to just buy once and not worry about again. We, being Unix bigots, may have heard of this thing called Windows 365, which is like your operating system as a service. And if anybody reads the Register lately, they did a piece on Intel software-defined silicon where you gotta pay either more money up front or pay rent to unlock features that are already baked into your CPU. I would like to call that greed. Teslas do this with their batteries, but at least that's a one-time fee for now. Some high-end BMWs in some locales want you to pay $18 a month for the privilege of having heated seats. And don't even get me started on John Deere. It could be Chromebooks. I talked about the web previously and how it is everywhere all of the time. Very few non-technical people do things outside of their browser these days. And I know this because I asked. So, it's great if you can just make the browser like 90% of the operating system. That takes out so many moving parts and so many things your end users can break, which is why they're great for the K-12 market. But yeah, I think at best, most non-technical people just use their laptops for browsing the web and maybe an email client if they just don't use the Gmail web app. It could be virtual reality, maybe. Mostly, I've seen that as being a top-down push, like Facebook wanting you to buy into their metaverse rather than there being an actual organic demand from the people to want VR. It could be voice assistants. If we're lucky, we'll live in the Star Trek future where you can just say, "Hello, computer, please get me something," and it will do so, if we're lucky. More likely, it'll be Alexa trying to sell you something. Yeah, or Siri. I know it's definitely not going to be NFTs. So, yeah. I would say this is the most important slide in this presentation because this summarizes it all up. We as humans have shifted from using computers as a tool to computers using us and demanding our attention. As well, with the computers that demand our attention, we just use our own little computers to connect to massively centralized services living in the cloud somewhere. The means of computation, as it were, are just as, I'm blanking on a word. The means of computation are still distributed away from the people, just like way back in the mainframe days. It's just now there's more of it. Those are two very good articles there. Death by Hockey Sticks is all about hockey stick curves, which is a scary term, and Moore's Law is about how, it's a Wikipedia article, it's about how sometimes instead of making your code run faster, you can just wait 2 years and buy a faster computer and it'll be great. The World Wide Web. or the worldwide wasteland. I do not like it. I think that should be obvious. There is a very different experience, not just for like people who have an ad blocker installed and people who don't, but also for people who have lower end computers that struggle to run a browser and people with very high end computers that can load all the JavaScript libraries you need. And with people trying to optimize their websites more for search engines, it's hard to find something written by a human these days on Google. There are so many like AI Markov chain generated websites, all for the purpose of showing people advertisements. What can we do about it? That word was originally a different one. You can try staving off the future for a bit. You can tell your computer to stop bothering you. You can stop using web apps. You can try to stop using websites. You can own your data in a way that if you flip the Wi-Fi toggle switch on your laptop, you can still access it. You can use hippie services, like recently everyone's been talking about Mastodon. If you don't know what Mastodon is, there's someone in the crowd who will tell you. But eventually give up, realize it's futile, embrace the future, that it may be done of your own choosing rather than thrust upon you. It is coming. Someone in an earlier talk said that all technology problems are fundamentally people problems. And going by that same logic, we cannot solve most of these tech problems without changing fundamentally as a society from one that values consumption and more technology and more technological solutions to one that values the individual more. That's all I have to say. I don't think I promised a cat picture at the beginning, but it was in my notes too, so here's a cat picture.
Thank you so much, Esther. Any questions from the audience? And if you're on the internet, you may ask questions on Slack as well.
Or war stories. You, red hat.
Am I limited to one question?
No.
Okay, so I have two, one smaller than the other. For one of those slides, you said present day, present time. Is that a Serial Experiments Lane reference?
Yes.
Yes. The other thing, what would you say about not necessarily getting rid of the internet, but taking it back in a federated way, similar to what Mastodon's doing with ActivityPub?
I'm glad you didn't say taking away the internet, because I did sort of do this as an anti-technological tirade, but fundamentally technology does allow us to, in many ways, improve our lives. It's just it can be very easily corrupted. So taking back the internet in a federated way, I guess you could kind of link that mentally to the early days of the internet. I'm not talking about like CompuServe with their walled garden, but I'm talking about back when you could run a website of your own, and you can still do that, but most people don't. Most people host their blog or microblog on Facebook or Twitter. So the analog to the federated internet would just be returning to hosting it yourself. Your blog living in a little black box in your basement running HTTPD.
Hello.
Had basically a quick question. I hear you're into beige boxes. Can you clarify which beige boxes? For instance, are we talking Spark stations, Power PCs, or certain other beige boxes?
I mean, are you offering me something?
I don't have any beige boxes to spare, unfortunately, or at least not at this point in my journey yet.
I probably have a 486 and certainly some Pentiums I'd be willing to give up.
Well, I'm a little bit bored with x86 because it has become the dominant architecture for now, hoping that will end soon. I am more interested in the 90s RISC machines. I do have not just one, but 2 alpha servers back home.
Mike was suggesting a Spark station or a Spark anything. I think I finally got rid of my last Spark server in the past 5 years. Any other questions for Esther?
That was a great talk. I wanted to ask you about the value for value model that you start seeing in podcasts, such as like Jupiter Broadcasting is really pushing it right now, with streaming Bitcoin as sats. So Satoshis are just a percentage of a Bitcoin. And I see a lot of potential to replace the current greedy ad revenue model that you see every site taking on, which only attracts greedy types. Whereas we might be able to replace some of that with a value for value model, which would then attract more creators, and content creators would then be able to take a fraction without having to take on sponsors and be directly funded by community members. Do you have any thoughts on that being maybe the best future for us going forward, rather than continuing to pump ads and ads and ads?
I specifically have strong opinions about cryptocurrency.
Bitcoin, not cryptocurrency. I mean Bitcoin.
Okay.
I'm not talking about the thousands of coins.
Next question.
One little nit on your slide, the Palm Pilot was not a smartphone. It was
You're right.
It was a PDA. You could make telephone calls with it, although there was a Palm Pilot 7 that did have connections to a service that the service died, so did the functionality that had. I also would like to put your PDP-8 into perspective, because although the ASR33 teletype and the PDP-8 was a wonderful machine, I'd like to go through briefly the process of creating an assembly language program for it. You had 12 switches on the front of the PDP-8. And so the first thing you had to do was to set the address of where the bin loader was supposed to go. Then you would toggle in 17 12-bit instructions to put in the RIM loader. And then that's the bin loader. And then you ran in the RIM loader tape, which took about 30 seconds to read in. So that was not a big thing. But then you had to put in the editor, and that was on paper tape, and that took about 5 minutes to read in the paper tape that held the editor. Then you would type in your program, and typing it in wasn't bad because you could only type so fast. But remember, it actually output at about 10 characters a second. So if you had a 3,000 character program, that took 300 seconds for 5 minutes for it to be punched out. Okay. So then you took that tape after you made that, and you would then put in the assembler. Now, the assembler was a much longer paper tape program, so it took 15 minutes to be able to read in the assembler of that. And then because the assembler was 3-pass, you make the first pass to create the simple table, the second pass to punch the object tape. But because the ASR33 could not print the object code and the listing at the same time, you needed a third pass to create the listing. Okay, and the listing was kind of expanded because it had addresses and stuff in it. So even though the tape was the ASR33 could read the tape in only 5 minutes, the source code tape you had. Printing the listing took much longer, okay? So now you have your listing, you have the object code, you now read your object code into the computer, however long your object code program was, and then you set the address at the start of it with the switches on the front, and then you said go, and immediately your program would wipe out all of memory and crash, and you start the whole process over again.
John Mad Dog Hall.
Way to ruin the romanticism, Mad Dog.
There is a reason we moved away from doing things this way.
And to add to your talk sometime, I think you should talk about storage devices, okay? So for example, the original personal computers, yes, they use a television screen to have the output for video, but the data was typically kept on an audio cassette tape. And it used the same tones on the audio cassette tape as the modem did. So in effect, you were recording the modem sounds onto the tape. Usually you did a couple times because it was analog tape and could easily crap out on you. So, you know, you might think about just going through the same type of talk, but talk about storage devices and how they went over the years.
Noted.
TR Sadies, any other questions? All
Please,
right.
I've got answer. Oh. I do have one question. Microphone?
No, I don't mean the microphone.
We have folks streaming on the internet, so it does help.
Never mind, yeah.
So you seem to be a really interesting person. I have to ask, do you have any socials? And if you do, where can I follow you at?
I do not have social media.
Fair enough. I understand.
That was a trick question. All right, anyone else? Lots of positive feedback on the Slack. Big hand for Esther. We will resume the program in this room at 4 p.m. We have another track going on and the expo. Thank you. "5 p.m. I cannot tell time. Staring at the clock, it is now 5 p.m. I'm pleased to introduce our next speaker, Terry Howell. Terry has a long history in software development. In addition to being a software test engineer, he has served as an adjunct physics professor. So needless to say, Terry is a pretty smart guy. He's also been a past speaker at multiple OLF conferences, so we're glad to have him back. Recently, he saw Rust in the Linux kernel headlines that sparked his interest. Terry's going to be talking about what is Rust. Having learned Rust is a relatively new systems programming language, he's wondering, should he pay attention to it? Is it right for him? What does it take to become a Rust developer? Well, Terry's going to tell us just that. Big hand to Terry.
Thank you. Okay. Hello, I'm Terry Howell, and thank you for sticking around for the last sessions of the day. Just before I start, I'm kind of curious of who's in the audience. Do we have any software developers here? All right. But just in general, write code. How about C or C++ developers? Do we have any? No? Oh, we got some hands back there. Yeah. Do we have any Rust stations in the audience? Oh, so we do have some Rust people. Okay. All right. Well, maybe someone else should be giving the talk rather than me. But yeah, so why am I interested in Rust? Some of you may have seen these headlines recently or within the last year. Linus Torvalds talking about allowing Rust compiled code into the Linux kernel. So, I thought, well, what does that mean? I had to read the article to try to understand why might Linux want to allow that into the kernel. I just saw this last night. I was browsing articles, and Google reporting less memory problems in Android as they've allowed more Rust compiled binaries into Android. So that sort of falls in line with, as a software developer, should I be paying attention to Rust? So my first question is, what is Rust? And in general, it's a general purpose programming language. And again, if you go look on Wikipedia, this is what you'll see. It emphasizes performance, safety, and concurrency. Just a little history. It started out as a research project of Mozilla. Eventually, it was released into the wild and the public in 2014. And it's been adopted by a number of tech companies like Amazon and Microsoft and so forth. So Rust compiled code is starting to make it out into the working world. And just to figure out where does Rust belong, if you want to categorize programming languages. And again, it's a compiled language, so it falls into the category of things like C and C++ and C# and Java. It's not interpreted, so it doesn't fit in that category with things like Python and Perl and Ruby and so forth. And that tells you a little about Rust's performance. So you can automatically assume that if you write something in Rust and you write the equivalent thing as close as you can in, say, Python, you're probably going to see a performance improvement in the Rust code just because it's compiled instead of interpreted. And we can further categorize that, break it down a little more. So when we say compiled, what is it compiling to? And Rust will behave more like a C or C++, where you're compiling to native instructions as opposed to like a virtual machine with C# and Java. So even before you look at, say, benchmarks or anything, I should tell you, you should expect Rust code to probably run more efficiently or faster than you would see in C# or Java, code that uses a virtual machine. So okay, I'm starting to figure out, so it gives me some idea of where Rust fits into the programming world. And Again, on the Wikipedia explanation said it was a system programming language, but it gives you this wonderful circular definition. System programming language is a programming language used for system programming, which, I love circular definitions that tell you basically nothing. But in generally it's system programming languages are designed for performance, and they allow you easier access to underlying hardware, but you still have higher level programming concepts. So, unlike ease of access to hardware, so does assembler, but it's very hard to read assembler code. It's a lot easier to read a C or C sharp or C++, C or C++ program. Where do you see system level programming showing up in the world? Well, it's system level software is used to build operating systems. It's used to build games and game engines, and a number of GUI applications, especially those that require performance, like the Adobe products like Photoshop and so forth. Those will be written in a system level program, probably C++ at this point. Again, web browsers, Chrome to Firefox. If you do any embedded programming, Raspberry Pi or IoT devices, right, you will be basically using system level programming. Although with Raspberry Pi, Python works pretty well for most things, unless you really need performance. Again, compilers, is GCC and Clang, are either built in C or C. I know GCC is C. I'm not sure about Clang. When I worked in New England in the mid '90s, Fidelity would always be hiring a lot of C++ developers because, again, they want that performance in their server-side code. And of course, things not modern, but things like machine learning and AI, all of that is going to want performance. So you'll see system-level programming languages used there. And these categories have been primarily the domain of C or C++, but these are also places that you could use Rust. And the reason why I put an asterisk by Firefox is because Mozilla did use Rust for some of Firefox. It's not entirely written in Firefox, and there's a reason why. And Firefox is not entirely written in Rust, and there's a reason for that, which I'll get into in a little bit. So what about in my workplace? So I spent the 90s working as a C engineer, starting out in 1991. I started out as a C programmer and eventually moved into C++. Since then, and more recently, in recent years, my current job, I just wrote C code, and that's been all converted to something else. And I work for a company called Kessler Crane, and we build motion control camera rigs. And so typically our products, I don't know if you can see my mouse wiggling around. Where I'm circling the mouse, there will be a microprocessor-based controller inside the camera rig somewhere, and then we'll have customer-facing user interfaces for them to use. So we provide to set up and control camera moves. And we build small footprint camera rigs. So instead of, you've probably seen behind-the-scene Hollywood movies where they have these massive things. Ours are all small small footprint, which started out for corporate video type applications, especially when DSLR started to allow video. A lot of that's moving to smartphones now, right? TikTok users do not buy DSLRs to make their videos, right? Those are all being made on smartphones. So my current job, I don't decide how we do our end user applications. We have a senior level developer. And so we did the Windows version about 10 years ago. So we've had a lot of, over the course of 10 years, there's a lot of man hours and time invested into our applications. And the lead developer brought C# with him, and specifically we talk Wi-Fi to our controllers from our GUIs, and all that code he had brought in as C#. So he's basically reusing code. And the reason why to develop our Android application, we're using C# and Xamarin instead of Java is for the same reason, because we're reusing code that, again, you've invested in at some prior time. And again, on Mac and iPad and iPhone, if you've ever done any development in the Apple world, you're kind of sort of forced to use those tools. And that's, in general, that's true of any, like if you want to do a Windows or Apple program, right, or app for a smartphone, you sort of have to use the tools they want you to use if you want the application to look like, an iPhone app, or to look like an Android app, or to look like a Windows application. And if you, like for example, I've looked at, do you guys know Qt at all? The cross-platform GUI development application. And we had a competing competitor who built their GUIs with Qt, and I was, man, they look the same on Windows and Mac and Linux. They had a Windows, Mac, and a Linux version. And I thought, oh, that would be so much easier to deal with. But my boss who makes the decisions on how things look, says, nope. That the version of Qt running on Mac, it doesn't look like a Mac application. So we got to, so anyways. So point I'm trying to make, and again, and finally in our controllers, it's an STM32. For those of you in the microprocessor, in the embedded world, you might recognize that. And that's basically C code, and the developer uses Visual Studio to, our firmware guy does. So over the course of a decade, we have a lot of time invested in how we've done our programs. So is there room for Rust? And the answer is absolutely not. I don't make any of the calls on how we implement things. I write some of the code, and I do all the software quality. I do all the testing. So it's my job to make sure this stuff is safe to put out in the field. And if it isn't, then I'm on the front lines with hearing back from the customers. So yeah. And thing is, so how do you sell using Rust to somebody? Because in my job, there's I do some things in Python, but it's just if I want to develop an algorithm or something we might consider using, I could use Rust in that case. But as far as an end user application, our end user applications, it's just absolutely not at the moment. And so I thought, well, who does use Rust? We have some folks that do. So I did some Google searching, and I found this Dan Olson from Treyarch Software. And if you don't know Treyarch, they build AAA games. Call of Duty Black Ops is probably one of their top titles. And this is one of their software architects. And so the question is, are they using Rust in Call of Duty? And the answer is no, they're not. For the same reason that my coworkers will not want to use Rust. And it's because we have all this time invested in what we've already done. They're not going to rewrite it from scratch. And whatever benefit Rust has, what we do now works. There's no real incentive or to switch to do something different. And so Dan, I found this YouTube video that he puts out, and this is the sales pitch he gives at his company to try to convince some developers to do some of their software tooling, their game tooling in Rust instead of in C or C++, well, C++. So they have a lot of support software that they use to build the components and the pieces that actually end up in the game. And they've been rewriting those in Rust. And so he gives this compelling video that what is it, 1, 2, 3, 4, 5 or 6, I think he gives 5 positive things about Rust to consider. And so I thought, okay, let's consider them. So writing Rust code, is it closer to Python? And that's what Dan Olson says, and he's an experienced Rust developer. I'm not. I know Python, and I know C, and I know C++, but I don't know Rust enough to tell you, oh yeah, it's closer to Python. So in that case, yeah, I can't confirm or deny that particular point. And in looking at Rust up to this point, to me, it looks more like C++ than it does Python. And I think, by the way, I got this picture from, I walked around GalaxyCon, and some guy agreed to pose for me. But what about speed? Another of one of Dan's selling points is he says that in terms of speeds, Rust runs closer to C++. And this we can actually check out. There are websites that give you benchmarks. And I found this benchmarks game website. And if you just, these are basically, there's a FASTA algorithm, which I don't know. But these are various versions of C and Rust that have been written. And if you look at the CPU time, you can see the first two were the fastest, which were written in C. And then there were a couple versions written in Rust that came in after that. And then after that, you find some faster run times, again, in C versions. So what that tells me is that, okay, I suspected that Rust would run, you know, relatively close to what you would expect out of a C or a C++ program. A lot of it depends on how you write the code. All right, so there are things that you can do that will make a C programmer run faster or slower, and the same thing in Rust. So in general, I think the nod goes to C. You can write probably the fastest code in C. I don't know about C++ and Rust, but they're all sort of in the same ballpark. So I would say yes to, okay, I believe when Dan says he expects performance to be closer to C++. Another selling point he gives is large centralized ecosystem, and that's definitely true. Rust has this community-created site or registry called crates.io, and in the Rust community, they refer to packages as are basically what we would call libraries, you know, in the C language, or modules in Python. And this is just a place where you can share your code or share your libraries. And if you look at the number of crates down in the right-hand corner, it says 98,000. So a lot of people have put reusable code. And this is, by the way, I didn't mention Rust is an open source project. So people like to share their work. And I don't know if that's 23 billion, but there's been a lot of downloads. So certainly a lot of people have been utilizing this large centralized ecosystem. So that sounds like a positive selling point to me. And just for fun, a few years back, I gave a talk here at the Ohio Linux Fest on my first Pygame. And I'd gone to a PenguinCon, and somebody gave a talk on Pygame, and I knew Python, and I thought, wow, that looks kind of fun. So I wrote a goofy little game in Python and then gave a talk about it here. So I thought, well, if I wanted to rewrite that game in Rust, how would I start? Well, you need bindings to the simple direct media library, which is what Pygame uses. And so I searched the crates.io site and found this. Sure enough, there are bindings for SDL2. So I thought, okay, that's encouraging. Another selling point that Dan Olson gives is this: Rust has an integrated build package test tool. And when you install Rust, you'll see, or you start reading the documentation, you see this mention of cargo. And cargo does many things for Rust developers. And if any of you have gone to GitHub, you need it. The example I can give right now is I got this new laptop and I installed the latest Ubuntu on it. And of course, Wi-Fi driver didn't work, so I had to go find a driver and compile. I found it on GitHub and compile a driver and install it. Unfortunately, it wasn't too hard. The reason why I use Ubuntu is, I was interested in Debian, but Debian you had to install a lot of drivers, and it made me mad, so I went to Ubuntu. But anyways, so sometimes when you go to GitHub and you pull down some software, hopefully it will compile. Often there's some dependencies that might be missing, so then you go back and you read the README, right, to see, okay, what was I supposed to install before? So Cargo addresses this problem of missing dependencies. So if you reference a library from the crates.io IO site, it will pull that down for you when the first time you build your code. And I found that works pretty well. Another thing, you can use Cargo to compile your program or your package. You can use it to run. You can run tests. You can create tests and run them from Cargo. You can make distributable packages with Cargo. And you can even instruct it to upload your libraries that you want to share up to the Crates.io site. So it's, I thought, oh, that sounds encouraging. Again, if you've dealt with pulling code down and trying to compile it, right? If you've ever dealt with CMake and trying to put together dependencies, or if you've dealt with makefiles, you know, a lot of that. I was a build on a project when I worked at PictureTel in Massachusetts. I was responsible for the system software builds, and which means I had to, I don't know, 20-some developers, and so I had to set up a makefile for each one of their. Oh, it was awful, and yeah, I still have nightmares from those days. So yeah, that sounds pretty good to me, coming from a C background. Anything to make building applications easier, that's a win for me. The big selling point, I think, that of Rust is these validation of memory problems. And again, just reading, again, this is you see I got a link down there to remind myself where I found this information. But you know, you read things about Rust being memory safe and null safe and thread safe. In those early days in the 90s, we were afraid to write multi-threaded programs because we just never get them right. It was just with C. Well, we were doing C++ and Microsoft's object component model, or component object model, COM, and just anything threaded just was a disaster. So, of course, you know, I say my memories of those days aren't accurate today because, you know, C# has really evolved since the 90s, and you know they've gone a long way towards fixing a lot of these, making these things easier to deal with, I guess. But anyways, oops. So how does Rust do this? And the way Rust validates memory problems is through the compiler. So when you compile your Rust code, it does a better job at detecting memory problems than what you would expect from a C or a C++ compiler. In fact, a C++ compiler will not check for memory problems at all. So is that true or not? I don't have enough experience as a Rust developer, which is not, what was like a month. I've been looking at this for a month or so, to say that's, you know, is that marketing hype or is that true? All I can do is look at anecdotal evidence of other places saying, yeah, we're getting less memory problems with Rust code that we've written. And so what Rust does, it has this ownership model for memory management, and that the compiler can check, as opposed to like C# or Java, where you don't worry about memory. You just allocate memory wherever whenever and whatever, and you use it as you want, and you forget about it. And then it has, at some point, while your program is running, right, the garbage collector will kick in, and your program takes a huge hit. And game developers trying to write high-performance games in C# are full aware of that problem. And again, with C or C++, you're responsible for managing your memory. So you allocate memory and you free it, and it's on you to make sure you don't have, you know, multiple pointers pointing at same memory blocks, and you free up a memory block and then you try to use one of those pointers. That's all on you to get correct. And the selling point of Rust is that it keeps track of when you're using memory and when it should be allocated or deallocated to prevent misuse and mutation. Again, I can't stand here and tell you it does a great job at that because I don't have enough experience at it. But it does interest me as a long-suffering C developer. So what about documentation? You know, often hear about some technology, you think, wow, that's kind of cool. Let's go read more about it. And then you can't find anything. Or the documentation is sparse or out of date. And I will say, I've been very impressed with the Rust documentation. It's well written. It's clear. I've been teaching myself the Rust language just from one of the Rust books on this site. I found it easy to install. If you come, I know if you looked at how the company I work for and everything we release, you would think, what am I doing in an open source software? Because we do Windows and we do Mac and we use all closed source stuff. But I have actually been interested in Linux for over 10 years, and I've been, I do all my personal stuff on Ubuntu Linux. And so for me, I found Rust very easy to install. But I'm not a newbie at installing software in Linux on Ubuntu or on a Debian based. I don't know anything about Fedora or the Red Hat side of the branch. I know nothing about. But on the Debian side, I know exactly what to do to install stuff. And I found this very easy to install. So, thumbs up on the documentation. Thumbs up on it was very easy to get going. I've been reading this, the Getting Started, Read the Book, which I've found very useful in learning Rust. I think, and for those of you who want to, indulge in the dark arts of unsafe Rust, you can do that too. So remember, Rust uses the Rust compiler to try to help find memory problems. Well, you can tell the compiler, okay, ignore this block of code. Don't check for memory problems. And if you want to take that risk, make sure you say the words correctly, because if you misspoke the words, right, you risk unleashing the army of the dead. And by the way, this is another guy I found over at this picture here, over at the GalaxyCon. Okay, so I spent some time talking about the Rust command line interface. I'm sorry, the Rust packaging tool Cargo. So it's very easy to get started from the command line. You can just I don't know if that's readable. Well, it's not too bad. Maybe in the back it's probably hard to read, but you open up a folder, you type cargo new and some name, and it'll create a directory structure and automatically create you a hello world program. And I did a tree command just to see what that initial directory structure looks like. And you see this cargo.toml. That's a configuration file that allows you to put like versioning information, and that's also where you put in what your dependencies would be, and that's how Cargo knows, okay, let's just say I'm working on a game using the SDL2, right? I would put in that TOML file the version of the SDL2 that I wanted to use, and then the first time you compile this, it would go get that library, download it, and compile it. And I'm not going to do that here because it took like 10 minutes to pull everything down and compile it. But yeah, so again, it's probably a little hard to see here, but you can use Cargo to build your application. You can use Cargo to run your application. If you run your application and you've made changes to the code, it'll turn around and build it again and allow you to, and then run it. And as you can see, my hello world was a success. But that's not how I work. I don't work from the command line. I wasn't a computer science major, I was a physics major, and I learned to write software with Turbo C. Do we have any people? Yeah, Turbo C, that's how I started. And I never learned how to build software from command line tools. So when I first started out working as a software developer, and somebody said, oh, we want you to work on the makefile. I was like, what's a makefile? Because even back then in the early 90s, Turbo C would build projects just like Visual C does now, or Visual Studio does now. So for me, it was just, you just start writing code and you don't worry about command line switches. So anyways, that's not how I work even today. I use, and you know, I've seen, every time I come to these, this conference, I'm amazed at what people do with Vim or VI. You know, they not only do they just use it as, I use VI all the time for configuring files on Linux, but that's it. I can edit, you know, the text, and I know how to save it and quit. And but people, they can debug their programs, and you know, and they just, yeah. What I see people using Vim for, it just amazes me. But that's not me. And I started out on Turbo C, but as soon as I started working in commercial software, on development teams that were, you know, 3 or 4 or 5 or even more people, they all were using Visual Studio Code, and we were writing C++ programs on Windows. So I had to use the tools that we used in the workplace. So I got very good with Visual Studio and knowing how to use that for debugging and all of that. So when I first learned about Visual Studio Code, I was kind of excited because I wanted that same user experience that I had had with Visual Studio in the past. I wanted to be able to use that to write code on, you know, a Linux system like Ubuntu. And I didn't want to just have, and I want the same development environment on whatever platform I have to work on. So with Visual Studio Code, I can install it on Windows, I can install it on Mac OS, I can install it on, you know, Linux. Ubuntu is what I use now, and it looks and behaves the same. And not only that, so well, what language are you going to program in? Well, you can install add-ins, right, of the language that you want to use. So I have C++ installed, right? I have Python, and Rust also has an add-in for Visual Studio Code. It's called the Rust Analyzer. So that makes it very easy for me to get started. So, you know, for this talk, right, I kind of went through the hello world, and are you guys familiar with OpenCV at all? Anybody? Yeah. So, CV stands for computer vision. So it's basically a library for developing computer vision applications. So there's some AI going on there, you know, image recognition and that kind of stuff. In my job, we want our end users' camera. We have a lot of people that do interviews with our products, or say, you know, like we got a cameraman here filming this. What our customers would like is they want the camera to track the person on the stage, or in an interview as they move their head around and reframe the camera. And so I went to my boss and I said, well, you know, there's this thing called OpenCV. And he said, oh, I don't know. And so then I wrote a Python demo showing just a simple, you know, head tracking with OpenCV. And I put together that demo for this talk, only I did it in Rust. And again, I mentioned SDL2, and because I'm familiar with the simple direct media library, I thought, okay, can I do that in Rust? And the answer is yes. I was able to. So let me just sort of bail out of Rust here, and we'll see if we can get a couple simple demos going, or if I can thoroughly embarrass myself, because people doing demos today, they work pretty well. There hasn't been like a horrible flop, so you might see it here. But in general, again, this is if you haven't seen Visual Studio Code, this is what it looks like, and I can bump that up to something that's probably too large. Yeah. And over on the left here, I have various projects that I have open for me to look at. But and let's just close that out, and we'll go down here to the hello world. And so there's my first Rust program. Simple hello world. And when you look at that as a C programmer, so that looks like C, or that looks like C++. Other than this FN you see in front of the main, right? And In C, that would be an int or a void or something, but you can see. And the print line, it kind of looks like printf, so you kind of sort, and there's a semicolon at the end, right, of the line, and you see these squiggly brackets, sort of defining a block of code. So, my first reaction when you look at it, you said, okay, well that looks like, a C or C++ program just from looking at the hello world. And again, you can run this stuff from the terminal, right? You can just say cargo run, right, if you want, and you see the hello world down there on the bottom pop up. Or, because in Visual Studio Code we have this plugin, Rust Analyzer, we can actually, it puts in this run or debug, so we can literally just run the code from there and not even have to mess around with the terminal if you don't want to. So that only took a few minutes to get going, and so how about something a little more complex? Oh, I forgot to show, over here on the left-hand side, right, you see these are the extensions or the plugins that I have installed. Right, there's the C++. Scroll down a little farther, you can see the Python, and below that is the Rust Analyzer. So these are, different plugins, or I guess extension is the proper term for Visual Studio Code, but they allow me to write software in different languages. And all that Jupyter stuff you see in Pylance, when I installed the Python extension, it added in all these other things too, but I don't use any of them. But anyways, I'll close that out. Close out the Rust Analyzer. So this test SDL, again, I have, I'll just close this out down here. I have some familiarity with SDL from previous projects. In fact, when I wrote the Pi game, I turned around and rewrote it in C++ just to see, okay, can I, the Pi game was, it wasn't simple, but it wasn't too hard to get going. How hard would that be and it wasn't really that much different than in rewriting it in C++. And so I thought, okay, well, what about in Rust? This is something that, I have some familiarity with. And so I put this together, and it's pretty simple. It just opens up a window, and it creates a canvas for you to draw on, and I create a little event pump so that I can get out of the program with a keystroke, and I just change the color of the background in steps, 255 steps of single integer. So it just loops through that, and I thought, okay, well, let's see. So that's my first Rust program that I put together, and it just does a simple, it just changes the color. I thought, okay, well, let's see, did I use the escape key to kill it? Yeah. So that's one example. Another, again, I talked about OpenCV, right? And again, it's, and like I said, when I look at this stuff, and I don't really know what a lot of it does yet. I'm still figuring out Rust. But I do know that, to me, it looks like a C program, or C. It doesn't look like a Python program to me. And again, in that selling point, Dan Olson's selling point, he said, it kind of writing Rust code is more like writing Python. And I'll tell you, no, it's not, because how many of you enjoyed copying and pasting Python code? All right, what happens? You get that dreaded indent error, right? And yeah, I hate that. And you don't get that in C or C++ or Rust, right? So to me, that's a big win. Right, so again, this is pretty simple. There's the main function. We're going to create a video camera, which is my web camera on my laptop. And we're going to use a cascade classifier called the HAR cascade. And it's basically image recognition technique where they've trained a bunch of faces. And so this is going to be looking for a face. And so it's pretty straightforward. You just have a loop. It grabs a frame from the camera. Right? It looks for a face, or faces. It looks for faces in that frame. Actually, it converts it to grayscale first, and then it looks for faces. And if it finds a face, it draws a rectangle around it. And then right, does a little wait here to see if I press the key to break out of the loop. So let's see if this runs. Let's see. Trying to run. All right, so there I am. And you can see it's detected my face. It's pretty easy to defeat. Actually, I think it works better with, but as soon as you turn your head, it breaks the detection. So anyways, this is basically the demo I showed my boss that I wrote in Python, and I converted it to Rust. For this show. So it's not, I kind of feel like, again, I haven't studied, I've only looked at Rust for about a month. So I don't know if I can call myself a Rustacean yet, which is a Rust programmer. But I feel like I'm understanding it well enough that I can start to convert stuff that I've written before. And I've done, at Pi Ohio a few years back, I did a talk on building GUIs with Python and GTK. If any of you are familiar with the application builder and GTK. Again, I mentioned if you're going to build a commercial Windows application, it needs to look like a Windows application, which sort of forces you into using Windows tools. Same thing with Mac. If you're going to build a Mac application, you're almost forced to use their tools to make it look like a. So when I was thinking about building a Python GUI, most of the solutions I looked at, like tkinter or whatever, none of those look like. So on my Ubuntu laptop that's running GNOME, none of those look like a GNOME application. And I thought, well, I want it to look like a GNOME application. So that's how I went down this using GTK, which is right. The GNOME Foundation uses GTK to build, and so I wanted to use the same libraries. So maybe the application. So that's how I did. Why they did the Python thing, and I thought, well. I found, let's see if we can do that in Rust. And so again, this is sort of a simple, again, it's not very sophisticated. It just puts up, a little window. But this is how you get started, right? When you're learning a new language, you take baby steps. You don't try to write this huge, complex, sophisticated thing. You do little things that you're familiar with, and then you grow from there. And so, okay, yeah, I believe that. That looks to me like it's a GTK application. And I'll show you an example that doesn't. And let me look at my time here. So eFrame, I'm not sure if it's called eFrame or eGUI, but this is a native Rust GUI library. So if you don't care that your program doesn't look like it was natively targeted for GTK or Windows or Mac, because remember, this is all a class platform. I could be doing these same demos on my Windows, what is it, 11 now? And, or on my Mac OS. So thing is, so what does this look like? And, when I pop it up, I can immediately say, well, I can tell it's not, it already looks different to me, even before, I've really displayed any of the controls. But you may not care, right? You just want a GUI working. What this has convinced me is that, yeah, I think, well, let me go back to my slides here, kind of wrap it up. So the bottom line is, should I become a Rustacean, which is affectionately known as a Rust developer, and they have cute little logo of Ferris the Crab. And again, it all depends, right? If I want to do, in my own personal situation, if I want to write Rust code on the job, the only option I really have is to replace what I do with Python, which is try out ideas, which Python's excellent at, right? You just figure out the module you need, and within a few, 5 or 10 lines of code, you can get pretty far. The only reason why I would switch over to Rust to do that is for educational reasons. If I really want to learn Rust, and why would I want to learn Rust? Well, what if I want to become a Rustacean, as an occupation? Well, I have to show that I have some skill in Rust, so I've got to write some stuff in Rust before I can convince a hiring manager that, okay, this guy actually knows what he's talking about. So that's the end of my talk, and we'll open it up for questions. Anybody? Thanks.
Thanks, Terry. If you are watching from the live stream, I will be monitoring the Slack channel, so feel free to ask questions on the main stage Slack channel. If you're here in the room, raise your hand.
I saw in the Visual Studio project the Rust has a directory called Target. Is that for like dev versus prod, or does Rust by default allow you to cross-compile for a different architecture?
I don't know about cross-compile. What it does is, you notice that my choices when I ran from Visual Studio Code were run and debug, when I just click. So the target would be whether it's a debug or release. So you can tell, the Rust, okay, I want to build a release version which takes all of the debugging info. Yeah, so.
My next question is, I guess, more of a generic systems programming type question, but also does tie into Rust a bit. Since I know you haven't done anything major in Rust yet, but you've touched a lot of C and you've touched a lot of C++. How do you feel in terms of code organization? Do you think that Rust is helpful for a project as it becomes less trivial compared to what you have at your disposal with C or C++?
Oh, I wouldn't say it's any better or worse. One thing that Rust has that people pointed out to me at this conference that I had read about, but I just kind of dismissed it and didn't think about it, and I forgot to put it in my talk, is that Rust has a code formatting tool called Rust FMT. And those of us that have worked in teams know there's nothing worse than looking at someone else's spaghetti code. And so what the Rust formatter does is, and I haven't used it, so I can't say, but for sure, but from what I've read, it will lay out the code in a defined fashion. So, and the people that brought this to my attention are teachers. They teach Python, and they get these messes of different solutions from their students, and they would love to have a tool that they could have their students run on the code and then have it formatted in a consistent way. So I think that would be very useful, because in a large development team, what we had is we just had like a PDF of, okay, these are our coding standards, try to follow those. Whereas this tool would force that. So I don't know if that answers, but. Yeah, I think that'll get me close enough, but thanks. Okay.
Any further questions?
How good of a package manager is Cargo? Like, would you replace what's the Debian thing? Would you replace apt with it?
No, I think those are apples and oranges. I think the Cargo is just for whatever application you're working on, or others. I don't see it as in the same context as a application manager like APT or something else. But we have some other Rust developers. Do you have an opinion? Any of you guys? No. Okay. Don't put the camera on them. Don't put them on the spot.
They're clearly opting out.
Yeah, I see the Cargo as more of just managing your own package, but I'm new to this. There's more to that. That's a good research question.
Perhaps one quick comment, if I could.
Sure.
Cargo is probably best compared to Python, pip, or JS Node, or NPM.
Yep.
In that it's a package manager for build dependencies, but not necessarily for programs for the operating system. And I think from what I've heard or from what I've seen, other people who have used Rust, it compares very favorably to pip and Node and the other development packaging systems. but it is
Yeah.
something totally different from what you would get from
Yeah,
apt-get.
my,
or anything
my,
like
my
that.
experience so far is that it's easier to deal with than like CMake or a Makefile, by far. So.
Any further questions? All right, big hand for Terry.
Hey.
We will be resuming the program shortly at 6 p.m. Until then, we'll take a short break. Thank you. Hello, OLF. We've been really good at staying on time today, at least when I remember what time it is. It's been a fine day, and I'm excited for the nightcap. But first, I'm going to introduce our president, who should be in here any second. Right now. Who here had a great time today? And our fine president, Bethlyn Eicher, will be coming to the stage to transition and introduce our next speaker. Thank you all.
Fantastic. I am so glad that you are here. And I am so glad that I am here at the 20th annual Ohio Linux Fest. All of this would not be possible if this gentleman, John Mad Dog Hall, didn't take a risk on me and help me save the second annual Ohio Linux Fest. He taught me how to raise funds so that free software events like this could continue to occur. It's not just about paying for this year. It is paying for the next year and the next year beyond. Now that we have the internet involved, we are truly Linux International. What do you think?
That's true. Yes.
We have also taken our raffle to the internet. And I will remind you that we still have these fabulous prizes that will be drawn sharply at 7 o'clock. We've got the Raspberry Pi 400, quantity of 2. As a consolatory prize, you could still get one of these cute little Raspberry Pi Picos, soldering iron not included. You could have this lovely gift bag from Team OLF with a large t-shirt and a vintage t-shirt and some non-boozy libations for later and some high-quality candy and something to help you get caffeinated. You could win these Bose earbuds. They are spectacular. Or for those playing at home, you could win a swag pack from all of our exhibitors. I went around and grabbed the swag that was left to give you some of the flavor of what it was like here, in hopes that you may be able to join us in person one day. With that, it is very important to continue to appreciate these types of mentoring relationships. And I just want to continue to say thank you, sir.
You're welcome, Beth. You're welcome. And I would like to take this opportunity to remind everybody that this is a volunteer organization. They don't make money, they don't make a salary or anything. They meet constantly over the year, at least once a week, and talk about this and set up the rooms and the equipment and things like that. So I think that all of them really deserve a round of applause.
Thank you. And without any further ado, I introduce John Mad Dog Hall. United we stand. United we stand. John Mad Dog Hall.
Thank you. So my name is John Mad Dog Hall. Mad Dog is actually a nickname. It's just that everybody except my mother called me Mad Dog. I could never get Mom to call me that. She always called me John for some reason. And I want to remind people that Linux is a trademark, registered trademark of Linus Torvalds, and we should remember to say that when we use the word Linux to help him protect the trademark. For those of you that don't really know me, I've simply been in the computing field for a very long time. I started in 1969, and I've worked in a wide variety of different systems, not just Linux, not just Unix. And I've learned a lot from each one of them. And I've had a wide variety of different jobs. And I want to point out that this morning we had a keynote from Amber, who talked about the types of non-technical skills that people can use to help the free software community. And I was inspired by her talk. I actually went through my talk and made little notes. Every once in a while I say, thank you, Amber, for this thought. And the first one is in the red type up there, which talks about the types of jobs I had which had less technical information in it and more people skills, as she was talking about. A product manager, a technical marketing manager, and some of the upper management jobs. I still try and maintain a technological bent, but it gets harder and harder when you take a look at the fact that there's over 400,000 types of open source or free software projects out on GitLab, GitHub, and even SourceForge still, and even private sites. So it's hard to keep up with it. I do the best I can. But I'm going to take you back in time now. I'm going to introduce you to some people that some of you know and some of you don't, and tell you a little bit about them and why they are unique. We'll start with Ada Lovelace. She was the daughter of Lord Byron. Her mother was a mathematician, which was odd at the time because women weren't thought to be mathematical people. They were to take care of the house and raise the children and things like that. But her mother was a mathematician and a scientist, and she made her daughter, or she allowed her daughter to become a mathematician too. And Ada got to know a man named Charles Babbage, who had this strange idea that machines could actually compute numbers. He got this idea because he was a civil engineer, and back in those days, civil engineers used books of tables and slide rules and calculators in order to calculate what they needed to build buildings and bridges and things like that. But in order to make sure they were doing it right, they would have two people sitting there comparing their answers step by step to see that they got the same answer. And one time they did a calculation and they got different answers. And they went back and did the calculation again and got different answers. And they couldn't figure out what was going on until they compared the books of tables and found out that one of the books had an incorrect entry in the table. And this scared Charles Babbage because he said, if we had had the same book, the same edition, we wouldn't have seen that. Or, if we hadn't compared each calculation, we wouldn't have seen that, and the building could collapse, or the bridge could collapse. So in this time frame, the steam engine was coming about, and people got the idea that mechanization was going to solve the problems of the world. So why couldn't mechanization allow us to create a machine that would do these calculations perfectly every time? And he started to design that machine, and you can look up the troubles and tribulations he had while he was doing that. He first tried to design something called an analytical engine, which basically could solve any problem, he thought. But that was really complex, and he never got very far with that. Then he did a difference engine, which only did differences to do certain types of mathematical calculations. And he got about halfway through that, and that was becoming too expensive and too hard to make. So he figured out a way of cutting down on the number of parts to make the difference engine, and it's about that time he ran out of money. So he never built his engines. On the other hand, Ada Lovelace was fascinated by this, and she said, if you build the engine, I could program it to do certain calculations. And so she wrote, in effect, programs back in those days that would control the difference engine to make those calculations. And even though she never got the chance to put those programs on the actual engine, she was very good at doing that. So good that until 2002, there was a difference engine built by the Science Museum in London, built to Charles Babbage's plans. By this time, machining had become much better, tolerances were much better, material parts were much made out of materials that could stand up to this. And they built this engine. And they applied Ada Lovelace's programs to it, and the programs worked. Later on, there was a gentleman, Nathan, I'll probably murder his name, Mihro, who worked for Microsoft, funded a duplicate of that. He was going to put it in his house, believe it or not. And, but then the machine was finished and his house wasn't, so he allowed the Computer History Museum out in Mountain View, California, to display it from May 2008 to January 2016. Well, in 2008, I decided that I would like to see Linus Torvalds become part of the Hall of Fellows of the Computer History Museum. So in 2006, I actually submitted his name. It took them 2 years to decide to award Linus the award. And in 2008, they called me up and they said, Mr. Hall, we'd like to give him the award, but we have a problem. Linus doesn't want to come. He doesn't like the pomp and ceremony. He doesn't want to put on a tuxedo. We can't get him to come. So I took a look at their webpage and saw something there, and I said, leave it to me. I called up Linus, and I said, Linus, you're winning this prize. He goes, yeah, I know. I don't want to go. I said, Linus, you could crank the engine of the Babbage, the handle of the Babbage difference engine, and you could compute according to Ada's program. And he said, I'll come. And there was a picture of Linus cranking the engine with a huge smile on his face. So that's Ada Lovelace. And, somebody who just did not listen to people saying that she should not be doing what she was doing. Second person, you may know him, Alan Turing. He was at Bletchley Park during World War II. He was a mathematician, he was a logician, and a cryptologist, a cryptographer. He helped to break the German Enigma code. And because of that, it's estimated that he reduced World War II by 2 years and saved an estimated 14 million lives. He was considered to be the father of computer science. He wrote a paper which kind of shattered people's ideas. He said there's two types of problems: the problems that can be solved and the problems that can't be solved. And if the problems can be solved, they can be solved by a digital computer. And any problem that a digital computer can be solved by any digital computer, given enough time and memory. And from that, they created the essence of computer science. And later on, he helped to define what artificial intelligence was. But he had a problem. He was a homosexual. This is a time when, in Great Britain, homosexuality, or sodomy as they called it, could be, you could be arrested, you could be put in jail, and otherwise pretty much tortured. They settled on hormonal treatment to Alan. He was a cross-country runner. He kept himself in good shape, but the hormones made him gain weight, made him grow breasts, and basically depressed him a lot. And so in 1954, 2 years after he was arrested for this, he committed suicide. There are some people to argue that it was an accident. Other people say it was suicide. But in any case, if he had been able to live on, we might have been able to learn a lot more or have him do a lot more good things. The next person I'd like to introduce to you is somebody I had the honor of meeting and spending some time with, Rear Admiral Grace Murray Hopper. In 1944, there was a war going on, you may have heard of it, and they had ballistics. So if you've ever seen movies of World War II, people in the front lines would have these really big guns. And the really big guns would launch a really big shell with a lot of black gunpowder and fire it at the enemy. Now, if you know anything about ballistics, you can fire the gun horizontal to the earth. As soon as the shell leaves the end of the barrel, it starts falling at the rate of 32 feet per second squared acceleration. So it may get 10 or 15 feet, and then boom, it hits the ground and explodes. That's obviously not a good thing. Or you can shoot it straight up, and it goes straight up and comes more or less straight down, and given rotational earth and wind and stuff like that, you may be lucky not to have it hit you. So obviously, the place you want to elevate the gun is somewhere in between 90 degrees and 0, 45 degrees or something like that. But there's also other problems. Windage. Okay, the wind is blowing. This is a big shell. It's going to go a long distance. The wind could actually blow the shell off course. Other things affect it, like moisture in the air. The moister the air is, the more the shell is going to slow down, not travel as far. All these different things cause problems. And so the science of ballistics is to figure out how much powder you need, what the elevation of the gun is, what the windage is to be able to hit the enemy. And you would see two soldiers sitting there with field goggles on, or using binoculars, and a field telephone to call back to Princeton, New Jersey, where there was a room filled with women, typically women, trained in mathematics, with books of tables and calculators that would then calculate all these figures to fire the gun. Then the gun would be fired, and the person with the binoculars would see, where does the shell land? And then they say, well, the shell didn't quite hit, it got close, but it's off by a little bit. And then they might call back in again. But there was another problem, because the enemy also had a gun. And they also had people with binoculars and a field telephone, except they were going back to Berlin. And so they, having seen where you fired the shell from, would start firing at you. And of course, the wind speed would change, and it would start raining, and birds would fly overhead and crap on the shell and stuff like that. That would all change the ballistics calculations. And these women would have to calculate. And of course, now they're under incredible pressure because the enemy is firing. So the idea was to create a machine that would do the calculations fast and accurately, no matter what. And so at Harvard University, a man named Howard Aiken, in the Navy, a commander, but also an electrical engineer, put together a team of people to create the first electromechanical, actually, computer in the United States. And they got it all finished. Everything was great. And then the Navy said, now program it for ballistics. And they said, we can't, because we're electrical engineers. We know nothing about ballistics. Navy said, okay, well, bring one of these women up from Princeton. And Aiken said, no, you won't. I don't want to have any woman on my team, because he was a male chauvinist pig. But unfortunately for Howard, he was called to Washington, D.C. for like a month of meetings. And while he was gone, this one naval lieutenant came up to Harvard by the name of Grace Murray Hopper, and she taught herself how to program the machine. She also whipped Howard Aiken's men into a staff, because you're in the Navy now. And when Howard came back, he had to admit that Rear Admiral, or Grace Murray Hopper, was more of a man than he was. Now, Grace went on a long number of years, still staying with computers, because she loved computers. She thought these were the greatest thing on earth. They built the Mark II at Harvard. One summer night, it was very hot. The window was open. There was no air conditioning. And all of a sudden, the Mark II started having problems. And so Grace went into the machine, looked around, took a pair of tweezers and pulled a moth from between the relay contacts, posted in the logbook and said, I found the problem with the Mark II, there was a bug in it. Now, the term bug had been used in other things before that, but this is the first time it was applied to computing. Later on, she said, gee, I think, you can program the machine in something other than ones and zeros. I think you should be able to program the machine in some type of a almost English-like language. And people laughed at her. She went on to develop two languages called Flowmatic. And then she headed up a team that created the COBOL language, which was used for many years in business. It actually is a very efficient language for business use. And she became known as the mother of COBOL. She had other things that she taught because she stayed in the Navy, and the Navy loved giving her young ensigns that she would then teach. The ensign is the lowest commissioned officer in the Navy, and she was in there, and she was a rear admiral by this time. And the ensigns would come into her office. She said, you have to think outside the box. And the ensign would look up, and there would be a clock on the wall behind her, and the clock was running backwards. It had numbers backwards. Now, in clocks, this is known as a barbershop clock or a bar clock. And if you look in a mirror, it's reflected back, and you see it running forward but of course, she was sitting at the desk looking at the mirror, in front of her, and the person standing at her desk was looking at the actual clock itself. But think outside the box. She went on to figure out why communications really needed to have cables that still ran across the surface of the earth or under the ocean when satellites were so cheap and so easy to put up. It's just because there's a lot of distance between the ground station and the satellite, and it uses a lot of time, latency, to send a signal up and down. And so she created this concept of the nanosecond, which is a piece of wire about 11 inches long, that she would hand out to people, namely representatives of Congress, to show them why we needed to spend all this money. But one of the things that most endeared Grace to me was something I alluded to earlier in one of my talks, that you don't always ask permission to do stuff. You have to decide what's the right thing to do, and then you do it, because it's easier to ask forgiveness than permission. And I have a little note here that says, thank you again, Amber, for reminding me of that. She retired from the Navy in 1986 on board the USS Constitution, which is the oldest naval vessel in the world, and I miss her dearly. Kathleen Booth was the first woman, or the first person, to actually define assembly language. So again, you have the ones and zeros of the computer, which are hard to program. It's hard to keep them all straight. And she said, I think we can develop a language that uses characters. It's much easier to do to line up with these ones and zeros. And so she developed this language, and David Wheeler actually wrote the first assembler program. But without her input into this, that might not have happened for some period of time. The Unix developers, many of you know about Ken Thompson, Dennis Ritchie, who basically wrote the first Unix, and Dennis went on to create C and a bunch of other stuff. But you may not have heard of Doug McElroy. Doug was actually the director of the Bell Labs laboratory that hired Ken Thompson and Dennis Ritchie. And Doug ran interference between upper management of Bell Labs and Ken and Dennis, who were doing this weird thing of working on these computers and stuff that AT&T didn't really feel was in their business. I mean, why do you need computers for telephony? And Doug was actually credited with the creation of the idea of macros. And those of you who have programmed in assembler or those of you who have worked with word processors understand the concept of macros, that you can expand out and duplicate the same blocks of things over and over again with different variables inserted. But even more than that, it was Doug who came up with the idea of pipes and filters. And most people that work with Unix or Linux, if you're thinking about differences between those and different operating systems, one of the main things that comes out is the use of pipes and filters in using command line processing. It was so new and so revolutionary that Doug had to write some of the first Unix commands to illustrate what he was talking about to Ken and Dennis. He is one of my heroes. Many of you have seen the movie Hidden Figures or read the book about a bunch of black women who were working for NASA, and they were called computers. And they would do the same type of calculations that Grace Mary Hopper would do at Princeton, but they were not given very much credit for it. And they went on to calculate some of the first trajectories of the Mercury mission and other missions like that, using hand calculators, books of tables, and made huge contributions. And until recently, received no attention. The same year that Linus Torvalds joined the Hall of Fellows at the Computer History Museum, Jean Bartik also received recognition. She programmed some of the earliest computers and was a mathematician and a person who helped bring these systems forward. Now, the reason I'm showing you all of these is because I've been in computers a long time. And when I first started, the percentage of women in IT was high, 45%. There were lots of women in our data processing classes. But then over time, that percentage started going down. By the time I got to digital, all of the women were in the documentation group. They were docos. And all of the men were in the development group. They were devos. Now, when I say all, there were a few women who were software engineers, programmers. And there was even one or two men in the documentation group. But there's very definitely a division between the sexes. Now, at about the same time, I went over to Malaysia, and the interesting thing about that was that 70% of the programmers in Malaysia were women. And about 70% of the people in lower management were women. And I asked them about this. Why do you have such a high percentage? And the answer was simple. That men at the age of 15 could get a job digging ditches, doing hard manual labor. And the women were seen as unsuitable for that. So when the women graduated from high school, they went on to university and got the training necessary to do the programming, to be the manager. And the government of Malaysia had an active program to try and bring this down to 50-50. Now, some interesting theories about why this has happened in the United States and Europe and other countries is that at a particular time in history, the personal computing was coming into the home. Computer games were happening. And parents would give dolls and cooking things and stuff to their girls, but they would give the computers and the games to the boys. And this formulated this. So you can blame your parents for this problem, of course. But then we have to ask ourselves, what about people of color? What about people who simply their families didn't have the money to buy the computers and the internet and stuff? What about them? Are they really less intelligent than white male programmers? My experience has been no. And so what we need today is more diversity. We need to actually work towards the diversity. We have to find the people out there and make sure that they can make their contribution to computer science. Now, over the years, I've had some nice experiences. A group called Linux Chicks started in 1999 by a person named Deb Richardson, the founder. And I remember Linux Chicks in particular because I was at Digital, and one day Deb called me up, and she was really upset. And she said, Mad Dog, I registered the domain name linuxchicks.org so we could have people find it and, come on board. And then somebody has gone in and created linuxchicks.com and made it a pornography site. And I said, I think I can handle this, because we had just finished protecting the Linux trademark. And I had a lawyer by the name of Jerry Davis, who was a very high-powered lawyer in Silicon Valley. And I called up Jerry. I called up Jerry and said, Jerry, we have this problem. I explained it to him. He says, well, Mad Dog, the only person who can solve this is Linus Torvalds, because he's the owner of the trademark, and you have to get him to say he wants to protect it. So I called up Linus. I said, Linus, explain the problem. He goes, well, he says, I personally don't have anything against pornography. But Tuve, my wife, does, so yes, we sued the pants off him. And so Jerry wrote an email and fired it to this guy, simply along the lines of, if you don't take your website down immediately, you're going to be in the biggest trouble of your life. And the next day, that website was gone. So Linux Chicks continues, especially strong down in Latin America. And we have other groups down there, like Women Who Code and stuff like that. We should encourage them. We should encourage them to continue going. We should mentor them, and maybe they can mentor us. The Association for Computing Machinery that I've been involved with for a number of years has the Grace Murray Hopper Award that they award every year for projects and things to bring more women into computing. The Unix Association, I've been very proud to be associated with. I've been on the board of directors. Had a president called Margot Seltzer. And Margot was a faculty member of Harvard. Now recently, Harvard reproduced the Mark I computer. They took a large section of it, not all of it because it was very long, but a good section of it, reconstructed it, and it could actually solve problems. And I went there to see it. I really liked it. And they had photographs of the team that built it, but there wasn't one picture of Grace Murray Hopper, not one mention of her. It was all about the men. And so I got back to my house and I wrote an email to Margot and says, hi, Margot, really nice display in your building about the Mark. Did you realize that there wasn't a single mention of Grace Murray Hopper? I could hear the nuclear explosion all the way up in Amherst, And 2 weeks later, I happened to be back in Boston, and there was a very lovely display of Grace Murray Hopper working along with the crew. And then we have the Linux Professional Institute, where we have just gone through and worked very hard to create a diversity statement and a diversity policy to try to bring in all of the different diverse people. But diversity is more than just whether you're male or female or black or white or different sexualities. It has to be financial and cultural. We have to be able to break through in order to be inclusive of everybody. But the good news is that back when this diversity, segregation was happening, the hardware was extremely expensive and very limited, and you had to belong to a certain organization to have access to it. And the software was closed. You couldn't have access to that. You couldn't extend it. Collaboration was difficult because the internet wasn't there. And reaching customers, once you had a product or had a project, was difficult. And all of that, as you know, has changed. And so now we can have some really amazing things happen. And I'm going to show you some of them, because these are my heroes. I'm going to start, I'm not going to say names because I don't want to embarrass them in any way, shape, or form, but I'll tell you what they did. The person on the left-hand top side is a person I met at the age of 10 and a half. At the age of 15. At 15 years old, he had created a distribution called PHAT, P-H-A-T, Linux. It was the first distribution of Linux that installed into the PHAT file system, so you didn't have to repartition your disk. You could either boot Linux or you could boot Windows if you wanted to. And he had sold 20,000 copies before his parents found out what he was doing. And they said to him, "Why didn't you tell us?" And he says, "Well, I really didn't need your help." I still remember he took this picture at Linux World in San Francisco. His father had come with him. And as they walked into the show, and you had Sun Microsystems and Digital Equipment Corporation and IBM and Hewlett-Packard and Fat Linux, a little 10 by 10 booth. His father was looking around like this. I said, "You really didn't understand what your son had done, did you?" He says, "No, I didn't." The next one on the topmost line is a similar story. This person at the age of 10 and a half created a distribution that used facial recognition as a login. It was the first distribution to do that. And he started selling that and supporting that. His father, who had worked for IBM for 30 years, retired from IBM and went to work for his son. Today, his son has been recognized by Forbes magazine as being one of the 21 people under 21 that you should keep your eye on. The next picture is Margaret Seltzer. I've told you about her already, but she is up in Vancouver doing amazing work up there. I'm going to skip for a moment down to the second row, far left. This is a school in Brazil, a high school. And public high schools in Brazil do not receive a lot of funding. Private high schools typically have a lot of funding. But the public schools, they don't have swimming pools, they don't have football stadiums, and they don't have computer labs. And this teacher said, "I'm going to create a computer lab." And so he went out to a bunch of companies and said, "Do you have some cast-off computers you're going to get rid of?" And they said, "Sure." And he brought them back to his classroom and he created racks and they took them apart and they reconfigured them so they had more memory, more disk space, and of course they put Linux on there. Now there's some of his students around him, and I want you to take a look at their faces. Those are the faces of pride. And so these students learned three things. They learned how to reconfigure the hardware, they learned how to put an operating system on there and get it working, but more importantly, they learned pride in the fact that they did it themselves. And this was a whole computer lab created with no cost to the school system. In the middle and the bottom is a young man that the one on the left, is a young man that I met at age 15. I was in my house in Amherst, New Hampshire, and I received an email message that said, "Oh, Mr. Hall, I like Linux, and you live close to me, and I really like to talk to you about Linux." I says, "Oh, great. We'll meet for beer and pizza." He says, "Well, the pizza will be easy, but I can't drink beer because I'm too young." He was going to a very progressive high school. He had taken every single course that the high school offered. There was nothing else for them to teach him. So his father let him stay home, and his father paid him $40,000 a year. His father ran a consulting business. Paid him $40,000 a year to write device drivers for his business. And he was worth it. Then later on, he actually attended a small school in Massachusetts that tailored to exceptional kids. And I say kids because he was underage. But he didn't actually matriculate at the school. Instead, he became their network systems administrator and reconfigured their entire network. And while doing this, he realized that there were these people trying to break in from Italy, or trying to break into his system. So he created a honeypot and trapped them and kept them going, called the FBI. The FBI contacted the Italian FBI, and they captured him. And this generated a 2-page spread in Business Week magazine with this young man who at that time was age 19. And he's gone on doing work for University of Washington research. He met the creator of Star Wars special effects for Star Wars 1, was helping this gentleman create the special effects for future Star Wars movies. Did I mention he never graduated from high school? I'm going to now switch to the gentleman in the bottom in the right, black gentleman. I met him in Soweto, South Africa. Soweto is a community north of Johannesburg, and before apartheid, they generated a lot of the service people to service the people in Johannesburg, maids, gardeners, butlers, cooks, things like that. It was in Soweto that the first riots of apartheid happened. Maybe you remember some of the pictures of a boy carrying his brother who had been shot. Well, apartheid was quite over. I went to a Linux World in Johannesburg, and a black gentleman comes up to me and says, "Mr. Hall, I liked what you had to say. Would you like to go to Soweto?" I said, "Yes, I'd like to go to Soweto." So we went to Soweto, and I was staying there and looking out across the Soweto city. It's kind of in a bowl. And I said, I think there's people here that know about Linux. He goes, No, there's nobody here knows about Linux. He says, I was born here. These people barely know how to use Windows. I'm looking out and I say, this would be a great place to put in Wi-Fi. You could blanket the whole thing with Wi-Fi and people would have access to the internet. And he said, nah, they wouldn't really know anything about that. It's not worth it. So, okay. He took me back to the airport and I flew home. But after that, he talked to his boss. He told his boss what I had said. His boss said, let's go see. And so they set up a meeting in Soweto and they advertised it broadly, and 350 people showed up to see what open source was all about. And after the meeting, there were these 3 black kids sitting in the front row arguing with each other. They went up and said, what are you guys talking about? And one of them pointed to this gentleman and said, he is running a consulting service out of his house with dial-up networking because the government won't give us any broadband. He said, he is talking with Linus Torvalds, helping Linus figure out a problem in the AMD memory subsystem. And this blew away the 2 men from the government so much that the next year, when I went back to the show, to the event, they asked me to go to Soweto again. I said, okay. They took me up there, they took me to this building, they took me inside. This was the opening of the first open source development center in Soweto. And they sat me down, and his boss did a talk. And after opening up the office, and then his boss came over and looked down directly at me, and he said, you have no idea what your words that you said that day meant. And this gentleman is now taking a picture of him helping other people understand about open source. So I've left one last person up there, the upper right-hand corner. His name is Marcelo. And I met Marcelo for the first time in a favela in Brazil. A favela is a slum. Marcelo had been born in the slum, raised in the slum. At the age of 18, he got a job as a janitor in a bank. The bank was throwing out some of their old computers, and Marcelo said, could I have them? And the bank said, why not? He took the computers home, he reconfigured them, he put Linux on them. He taught himself Linux, he taught himself Linux networking. And after a while, he said, I think the favela needs Wi-Fi. And people laughed at him. They said, nobody in the favela will pay you for Wi-Fi. That's crazy talk. He said, no, I think they need Wi-Fi because they'd be able to advertise their crafts and stuff like that to a larger audience outside of the favela. And that would bring in money, and they would realize that this is something that they really need. And they laughed at him. And 6 years later, he had 6 people working for him full-time, providing Wi-Fi to the favela. He sold that business off, and he decided he wanted to open up a school to teach web design and networking. And he had a small room with tables and chairs and stuff in it, and he was teaching students there. And that's when I met him. And we were standing out on the street, and this young man came up to me, and I looked at that guy, and I looked in his eyes, and I saw fire in his eyes. I saw intelligence in his eyes. And Marcelo turned to me and said, "Mad Dog, they used to talk about guns and drugs, and now they talk about the web and the internet." He eventually left that and went to work for research division of the Catholic University of Rio de Janeiro. He's working on IoT. That's where he's working and putting together some electrical circuits for that. Did I mention that he never graduated from university, never graduated from high school, completely self-taught? I have one last person, my newest hero. This is a woman who worked for DEC Documentation back in the day. Her husband was a Ristus E product manager for DEC. And over time, they both found out about free software, taught themselves about free software, Linux, and they both founded the New Hampshire Python group. Now, she never really got that much into programming Python and things like that, but she was a great cookie maker. And she made cookies and brought them to the meeting, and that's how she contributed to free software. So what can be done? How can we be more inclusive? I know a lot of you are doing a lot for free software. You're not just working with free software, but you believe in free software. One of the things you can do is to try and help form more local groups and bring more people into the free software goal and group. You can do mentorship of people. And again, thank you, Amber, for reminding me of this, because that was part of your talk. You can do more inclusion. And I don't know if you've ever heard the music Living Years by Mike and the Mechanics, but in it he says, you can listen as well as you hear. Listen to the people. Help them out. I'm proud to say that LPI, the Linux Professional Institute, is opening up a program of open source clubs. We took this from a person, a teacher who had created this and done a lot of work on it, and we're going to help to support that and expand it even more, especially for the non-technical user. And maybe we'll make cookies. So finally, I'll remind you that one of the most famous things that Linus has ever said is, show me the code. I don't care if you're male, female, young, old. A friend of mine started his daughter installing Debian releases at the tender age of 7. And she would try and install it, and if she ran into a problem, she'd tell Dad, and Dad would look into it and create the problem report. This is one of my favorite cartoons of all time, the two dogs sitting there, and one saying, on the internet, no one knows that you're a dog. So let's work to be more inclusive, not only in free software, not only in computer science, but through the rest of our lives, because we need everybody. We can't be divisive anymore. And so thank you very much. I thank you for coming and listening, and I think it's time now for the drawing. Maybe.
Thank you, Mad Dog. It's just always a pleasure to be here with you today, and it's always a pleasure to actually be together. There's just so many people to think about how it all came to be for us being here for the 20th anniversary. But we will have an answer as to who wins the prizes at 7 o'clock sharp. So this is your very, very, very last chance. If you'd like to ask a question that is not prize related, you can ask it now to give us a few more minutes to go ahead and move your final selections to the basket and go ahead. Does anyone have any questions for Mr. Mad Dog?
I don't have any questions, but I do have a story that I promised somebody. It has to do with data storage in the ancient times. Aetna Life and Casualty was the largest commercial user of IBM equipment in the free world in 1973. We automatically ordered 2 of everything that IBM announced. No salesperson had to call. We had a huge data storage facility, 500,000 magnetic tapes on site, another 100,000 in a salt mine in Idaho. But we also had a very amazing device called the IBM Data Cell. Now imagine a top-loading washing machine with a big tub. And in the middle, you had a hub, and from that hub to the outside of the rim, you would have a plastic strip. And actually, you would have 360 of them. Plastic strips. Hanging off of each plastic strip was a nice, wide piece of magnetic tape. And so when you wanted to access a record, the magnetic drum would go, the fingers would then come out and pick up the strip, wrap it around the read head, read the information, then unwrap the tape and try and put it back. And there was a vacuum that would suck it down back into the data cell, and you go and get the next one. So the whole thing sounded kind of like this. Okay. And this was hooked up to the mainframe computer. So I had a friend of mine who was an operator. We didn't call them systems administrators there. They were operators. And he was Rod, the operator. And Rod was a big guy. I mean, he was big. And one night, he was there at the console, and he saw data cell in trouble. Oh, he knows what a data cell is. He knows that this is bad. The data cell's in trouble. So he goes over to look at it, and sure enough, there's one plastic strip that's just not going down where it should. And he's looking in, trying to see what's blocking it. He's looking in, he can't see anything. So he grabs the data cell and holds it up to the light so he can see what's going on. And all 360 plastic strips fall out onto his face and onto the floor. And meanwhile, back at the console, data cell trouble, data cell trouble, data cell trouble. And across the United States, there's 1,300 people sitting there entering data that's now come to a halt. And they've taken out their crocheting and stuff because that's all they can do. At this time, John Filer, chairman of the board of Aetna Life and Casualty, who's spending millions of dollars a year in computer equipment, is taking a group of stockholders around the data center, because he's very proud of that. And he says, and here's our CPUs, and here's our disk drives, and over here is our data cell, which has all of the records that we have in our company. And he looks, and there's Rod trying to put these back. And he was smart, and he was fast, and he was quick. He said, and over here we have the printer pool. And leads the stockholders away from that. It takes him about 5 minutes, but he gets rid of the stockholders, and he comes over. John Filer is a tall man with pure white hair, very distinguished. And he leans over to Rod, and he goes, what in God's name do you think you're doing? And Rod goes, so we close the image of this. Now, the reason I brought this up was that, as I said, Aetna had this policy of getting two of everything that IBM announced immediately on announcement. One of them would go up to our research division to figure out how we're going to use it, and the other one would go down to the production floor to install it, so when we figured out how to use it, we would use it. And we took that, and year after year we did this, except for one time that IBM came out with something called the storage mechanism that was a honeycomb of cylinders that the fingers would come across and pull the cylinder out that had magnetic tape wrapped around it, and you would then read that magnetic tape, put it back on the cylinder and put it back, the fingers put it back. And we said, what happens if the fingers break? And IBM says, the fingers will never break. And are you sure? The fingers will never break, never break, never break. But what if they did? Well, if they do, we have a little garage here with another set of fingers. And so Aetna said, we're not going to buy those right away. We're going to let the Travelers have the first one, or the Hartford or something, but we'll wait on the mass storage system, okay? Because you know the sound the mass storage system made? Almost like the data cell. So thank you very much.
Thank you so much for yet another insightful keynote. Everybody, John Mad Dog Hall. When I look out into this audience, I see people who came together over the course of this weekend as speakers and guests to participate here in Columbus, Ohio, and I'm very happy that you're here. And I am also very happy to those watching wherever you are in the world. And I know that we've had people who have signed in from all continents except Antarctica. Mad Dog, do you know anybody from Antarctica?
I can only say that when Mark Shuttleworth went to start Ubuntu, he took the entire Debian mailing list and Debian source code down to Antarctica on a laptop, spent 9 months down there looking at it and watching the penguins, and then came back and said, I want you and you and you to come work with me on Ubuntu. So they're the only person I know who went to Antarctica and spent that much time.
Well, since we are archiving this program on YouTube, maybe one of these days somebody might download our YouTube stream and go ahead and make that available to them to go ahead and watch that every single year that we amass about 20 hours of programming, sometimes a bit more, to celebrate the diversity that makes free software possible. So I do want you to take a moment to like and subscribe and go ahead and support us that way. It would really help us a lot to continue that internet presence. We are all very much anticipating the answers to this raffle. I do not have them for yet another 2 minutes. So maybe I should just go on and tell you about the wonderful prizes again. Oh, wait a second. I have a message from our chair, Vance.
Yeah, I can start recognizing folks for a couple of minutes while you're waiting on those raffle results. So first off, I want to recognize all of you who came out and attended today. Thank you so much. Especially those folks who sprang for the supporter pass. It really makes a big difference in our finances. Also, I want to call out the people who are involved with our OLF Institute this year. That's our professional training program. And we had instructors. We had Jay Ryan and Steve Ovens from Red Hat, and we had Don Corbett teaching the LPI boot camp. So it was fantastic. You guys really did a huge amount. So thank you. Do we have an answer yet? Nope, still working. Okay, so we will go on and recognize our team members. So if you're part of a team, volunteer with the event today, please come on up here. Yes, you folks sitting there in the front row, that means you. Patrick there in the back, and Sam, if you can step away from the stream for a while. Mike as well. Come on up.
Oh, here we go.
Yep, come on up. Yeah, so these folks all spent a lot of effort, not just this weekend, but throughout the year to put it all together. We've got Patrick, who was overseeing our expo area. Did a fantastic job. We have Jared, who was helping out with the setting up the speakers and also put together the schedule app for this year. We have Stephen on the end, who was a volunteer helping us out today, so thanks, Stephen. We've got Sam, as I mentioned. He was the streaming guru for yesterday and today, and that just went fantastically. Mike, who is managing our registration yesterday and today, and he also manages our online infrastructure. It's Susan Rose, who is the social media and community coordinator. And then we've got Warner Moore, who is the VP of the Ohio Linux Fest Corporation, and did a fantastic job of introducing our talks and handling Q&A yesterday and today. And Beth Lynn Eicher, who is the president of the OLF Corporation, and did all this, collected pretty much all the sponsors, pulled them in, and just handled so many different things. I can't even, I don't even know how to list them all. But thank you so much.
And last but certainly not least, Vance. Vance worked his butt off all year long to make this happen for you. So huge hand to Vance.
Thanks so much, Warner. Okay, so I'm going to start talking about our sponsors. So please go ahead and look out see if we have some raffle winners to announce. Some of our fantastic sponsors we had at our partner level, LPI, SUSE, NGINX, and Red Hat. They contributed a huge amount to us financially. At our associate level, we had CentOS and Alma Linux. And then at the entrepreneur level, we had Aeronetics and GammaForce as well. And finally, our after party is going to be sponsored by the Linux Foundation. But before we send everyone over to the after party, it looks like we have raffle results to announce. So please take it away, Beth Lynn.
With pleasure. We're doing this with the pies first. So we have 2 grand prize pie winners of the Raspberry Pi 400. We have Bob Murphy, who I believe is virtual with us today. And we also have Catherine Devlin. Yeah, you can come running up and claim your pie.
Very happy little elephant. Okay.
Claim your pie. Yay! Catherine was one of our former keynotes. You did talk about what it was like to operate as a fast technology organization within the United States government and using free software while at it. So thank you so much, Catherine, for your support. We have a winner of the additional pies. It is Savvy Smith. So you win a nano, and we have several other nanos. So I'm just going to cut ahead to the other prizes.
I'll just sit down. I was really excited. I was super.
But way to go, Savvy.
Go through all the names, and they can come up and collect them so that we can.
Okay.
Get through it.
Okay, great. So we've got Tave McAllister winning Bob Cotton's book. We also have Dave McAllister also winning David Booth's book. We have Thomas Featherton winning the Boz Sports headphones. We have the goodie basket for OLF being won by Jeff Casavant. Is Jeff Casavant here? Hi. Yes, you get some non-alcoholic libations. You can claim it now. Thank you. There you go. Okay. Fantastic. And then we have more pie winners. I wanted to cut to who won the art. Who won the art was Stephen Pritchard. Stephen Pritchard wins the original penguin art. And I do know that he's in the building, perhaps a bit shy. Yes, that's Stephen. Stephen was one of our speakers today, and you get the penguin walk. We also have the virtual swag grab bag for someone who isn't here physically today, and that is Nathan Diekmaker. So Nathan, you're out there. You got it, dude. I'll definitely go ahead and mail that to you. And now, to name very quickly the rest of the pie winners, we've got Neil Hamilton, we got Grant Root, I'm sorry, it's making me page through all the names. And this is what I get for giving away 18 pies. I'm sorry, folks. Because I do appreciate that it is beer o'clock. So it was Scott Remen and Stephen Pritchard. You get a pie, too. There's Matt Williams. You get a pie. And Clark Hahn, you get a pie. And Mike Krokowski, you get a pie. And I think, ladies and gentlemen, that is all the prizes I have today. What you may notice is you'll have an email in your inbox with whatever you chose to register, so that we can continue to collaborate to claim your prizes should you not be here tonight. We are going over to the gallery bar for our after party. That is in the Hilton across the street, kind of, sort of. And you can follow all of us as we head over there. Or you could perhaps go out to dinner and come back and greet us there. No matter which Hilton you go to, they'll be happy to redirect you to the space. But the gallery bar is on the second floor of the Hilton at 401 North High Street. I hope to see you there if you're here in Columbus. Otherwise, thank you so much for joining us, your YouTube audience. We honestly could not have done this without all of you. And there's one more person that I would like to acknowledge before we go out air. Mike Methy. Can you please come up here? Mike had a dream 20 years ago that we could band together as a user group members to go ahead and pool our resources and have really outstanding world-class speakers. That's how it started. How's it going?
Mad Dog's here.
Success! Well, thank you very much. I couldn't have done it without Mike Murphy and without all of you making it all possible. I hope to see you all next year.
If you were on the OLF core team, would you come up front? I just want to get a quick team photo. And if you're going to the party, see you at the party. Thank you all.